Hello and welcome. In this session, we are going to see how to set up an EC2 instance with password, and we are trying to get rid of the private keys. So I have listed all the steps on a notepad, and we are going to launch an EC2 instance for testing our PostgreSQL installation and doing a lot of testing on that. We start with the introduction of EC2. In EC2 instance, by default, they do not allow the password authentication. So if you need to log into an EC2 instance, you have to go with the private authentication. That means you have to use the private key so that you can authenticate, and it is going to allow you. But for our testing purpose, wherein we have to do a lot of testing, wherein I believe hundred of times you have to install the PostgreSQL, you have to do a number of things. For that purpose, just to do it on a fast forward manner, you have to launch EC2 instance. You have to set the password authentication. Though from the cloud perspective, it is not recommended to use the direct password. But for just our testing purpose, we are going to launch EC2 instance, and then we will get rid of the authentication, which is through the private key, and we will set up the password authentication using user ID and password. So let us quickly go and launch an EC2 instance. This is the prerequisite. So you need to have this console ready. So I'm going with the free tier only. I'm going to launch Red Hat Linux. So we are not going to discuss what are all these details. So it is just quick. And we just wanted to have it accessible from our local system, and we are just going to access it using SSH. So we'll say just launch, and we are going to launch the instance. So within 30 seconds or so, this instance will be up and running. So what do you need is you need an EC2 instance which is getting launched. You should have the putty already available on your system, and once it is ready, what we will do is we will using the public DNS. So if you just scroll it up, what all you will see is this is still coming up. So this should the 2 by 2, this should be up and running. So it is still so to log in, you need to use the public DNS, and this is the public IP. On the left hand side, you will be able to see the private DNS and private IP. So for the login, we are going to use this, and okay, this is getting initialized. I have the private key already downloaded on my system, so I'm going to use the already created authentication key. So let's quickly go ahead, and so I'm just waiting for this to get launched. So once it is done, we will go with the steps. So these are the steps. The first thing, you have to log into the EC2 instance using the username and the password. In my case, it is RHEL. The user is EC2-user. If you have Ubuntu or Debian, so make sure that you use the proper user ID and the private key which you have already downloaded, or you need to create it, and you should have the access to it. In our case, we are going to use the putty, and let me check. Still it is getting initialized. So once you are able to log in through the console on putty, what you will do is um, because EC2 user, if you do the sudo, it has the sudo access by default. So if you simply say sudo PASSWD and the username, in the logged in user is EC2 user, so it will enter for the new password. So you just change the password, and from here it is going to start. And in the next step, what you have to do is you have to look for this file etc ssh /sshd underscore config. So what you have to look in for is password authentication. What you have to do is you have to modify the password authentication. By default, it is no. You have to modify it to yes. In case you wanted the root login for any purpose, but in our case, we don't need it, but you can search for the permit root login, and you can prohibit password to yes, and then you can say permit root login to yes, and then you save and exit. Finally, you need to restart your Sshd services. One more thing, extra thing we are going to do is we are going to disable the SE Linux, because that creates a lot of problem for our testing demo environment. So we are going to remove it. And what we will do is then we will log into the EC2 instance using the user ID and the password which we had set up in the earlier step. And there is one more step which we will do is we will set the host name. So we will say sudo host name ctl set host name, and we will give some name. That's the way we are going to do it. I hope by this time this should be up and running. So instance is up and running. So let's go ahead and launch it. So I have given the access location to my EC2, the private key. The EC2 hyphen user is the user ID. It's logged in. Let's go to the first step. The first step says we need to change the password. So you say sudo passwd and the currently logged in user. So we are saying sudo passwd ec2 user. Just give some strong password. So I'm setting up the password. Oops, seems. Yes, it is done. We have set the password for EC2 user. Now the next step we will do is uh, we will look for this file etc ssh sshd underscore config. So you need to use sudo, and the first thing which you need to look for is password authentication. So by default this has been set to no. We have to make sure that this is password authentication is changed to yes. This is changed to yes. And in case you wanted the root login and those details, you make sure you do this thing. But for our demo, this will never be required. We have the sudo access, and we will give the sudo access using EC2 user only. Now let's save it. This is saved. And then the next step is restart the SSHD service. So we are saying systemctl restart SSHD. So it is restarted. If you wanted to check the status, just check it because it doesn't prompt for anything. So it is up and running. The next thing which will you can do is for PostgreSQL we have to disable the SE Linux. So by default you will see there is something called as enforcing. So you need to make sure that you change it from enforcing to disabled. The next step which you will do is let's log in, or what we can do is okay, let's go ahead and log in. I'm opening a new putty session. I will feed in the public DNS and just say open. It is going to prompt for the password. So you can see that it has prompted for the password. So just enter the correct password which you have. Okay. So I'm able to log in now. You can see that this is the user ID and this is the private host name. So what next we need to do is, though we have made the necessary changes, one more action we have to do is, because most of the time this is not the desirable host name. So we will say sudo host name ctl set host name to some host name. Let's say I'll say this is pg host. and if you say host name now, you will be able to see that host name is changed now. And that's all about it, like how we are changing it from private key login to password login. And next thing you can do is you can reinstall install your PostgreSQL 13 from here onwards. This is not advisable to use without the proper security, but this is just for our short demo wherein you can do the testing and you can destroy the system. So for my purpose, I have already done it using the password, and in case I need to install, I'll do it. I'll play around it, and then I'll destroy it. So just to recap, what we have done is there are just 4 steps. First step, you normally log into the EC2 instance using the private key. The second step, you just change the password using sudo passwd and the username. In the third step, you have to modify the sshd underscore config file, and there is a line which will say password authentication. By default it is no, you have to make it to yes. Then you restart the sshd service. Then you disable the SE Linux from enforcing to disabled. Then with the new password, you open a putty session, fill in the public DNS, and user ID is EC2 admin user, so EC2-user, and then it will prompt for the password. Put in the password, and then you will be in. In case you change the host name, because for our demo we will be doing that, so we will change the host name. This is our EC2 instance with RHEL, so you just need to do where is the command, sudo systemctl set host name, and you have to give the new name, and it is going to change from the default host name, which is the internal IP of internal private IP that it shows as the host name. So we will make it more readable format so that that can be used. I hope this is going to help. Thank you. Hello and welcome. In this session, we are going to learn why PostgreSQL has been so famous and who are the top cloud providers which are providing the PostgreSQL as a managed service. So you can see I have put 3 logos. So I'll be just talking about those. That's a basic introduction, who is providing and in what form. And then we will talk about the basics of PostgreSQL. Okay, so these are the 3 top providers of PostgreSQL in cloud. So the first one we are going to talk about, it is AWS. So AWS is, if we talk about the open source databases, so open source relational databases has been in demand because of their increasing popularity, because of no licensing, and in the terms of the features which they are being added on regular basis, the new versions which are coming up, and they are according to the requirement of the industry. So let's talk about the Postgre, because we are talking mostly about Postgre in this slide, like who are the top providers and in what form it is being provided. So if we talk about the AWS, AWS is providing PostgreSQL as RDS in terms of the managed database instance. So they provide PostgreSQL as PostgreSQL RDS instance, and that is having all the major releases so far. I think 13.3 is the current release which is being provided, and same is for the Amazon Aurora cluster as well. So Amazon Aurora cluster is having the 2 engine. One is for MySQL compatible and another is for PostgreSQL. So this is also being in good recent news because of its popularity and the amount of the clustering solution it provides for the Postgre. It's tremendous. On the parallel side, we'll talk about some of the open source databases which are very popular and being provided as a managed service from AWS. So it is MySQL and MariaDB. So if you have worked on MySQL, then MariaDB you will not feel any kind of difference because it is a fork out of MySQL. We are not going to talk about the Redshift cluster, wherein at the backend it is going to use the PostgreSQL database as an engine, and it is really used as a data warehouse. And using your database migration services, you can convert the schema from other database engine to PostgreSQL. Let's say you have a big data warehouse of Oracle database, and in case you wanted to convert it to PostgreSQL as a data warehouse solution, so you can use the Redshift cluster. So back behind the scene, it is going to use the Postgre as the database instance. So that's the basic about the AWS, which is providing the open source relational database PostgreSQL in cloud. If you talk about the Google Cloud is also providing PostgreSQL in terms of Cloud SQL. So when we say about the Cloud SQL, it is an umbrella which provides three types of relational database service. One is managed MySQL, like AWS is providing, and another is PostgreSQL, which we are talking about. So this is really doing a lot of things, because if we see its report in 2020, fourth quadrant, this has been in news because it is doing tremendously good. So Cloud SQL is really going good in terms of the PostgreSQL and managed MySQL. We are not going to talk about the enterprise level database, a relational database SQL server, but Cloud SQL, it provides PostgreSQL as Cloud SQL. If we talk about the another major cloud service provider, it is Microsoft Azure services. So you can Azure is also providing PostgreSQL as Azure database for PostgreSQL. If we talk about another relational databases, so it is being providing for the MySQL and MariaDB. So you can see PostgreSQL has been so popular that all the top service providers for the cloud, they are providing it as a managed instance. And the reason being is on continual basis there has been a lot of development which are going on at the community level for the Postgre, and this is one of the most favorable relational databases which are available in the market, and it's day by day it is trying to phase out the enterprise level database. So we are not going to talk about the why about the comparison with the enterprise level relational databases with the PostgreSQL, but yes, the kind of the extensions which are coming up, the kind of the development which are happening back behind the scene, and the PostgreSQL is doing great. So the current stable version is 13, and current preview version of 14 is in testing phase. There's just a basic which we have seen earlier as well, like what is PostgreSQL. PostgreSQL or Postgre, they are one and the same thing. It is a free and open source relational databases, and there is a big community which works behind the scene, and they work mostly on the extensions. Day by day developments are happening, and then it is given to the community. If we talk about the relational database like PostgreSQL, it has an SQL compliance. So if we are not already knowing about the SQL compliance, that means there is kind of directory which says I believe it is 177 features of SQL compliance. Say for example, the create table, select table, insert in the table, or these are some kind of SQL compliance. So there are about 177 SQL directory list. Out of that, PostgreSQL is meeting the condition of 170. So this is one of the relational database which is so close to the SQL compliance, and this is also known as the world's most advanced open source relational database. And as you have seen in the previous slide, all the topmost service provider of the cloud, they are working on it and they have given it a place as a managed service. If we talk about the history, it was first in 1996, it was named as the Postgre, and it is it is successor of the database which was called as Ingress, right? And in 2007, it was renamed to PostgreSQL because of its compatibility with SQL. And so PostgreSQL or Postgre, they are one and the same thing. What are the features of the PostgreSQL? Since we know it is SQL compliant, so it supports transaction. And if you say about the relational database, it has to support the ACID property. Say, for example, the bank application. Each and every transaction which is happening, it has to be atomic, consistent, isolated, and durable. We are not going to talk about what are those, but it is like it is so popular that it is trying to make its own place in the industry, right? And it is also being used as a data warehousing solution like Redshift cluster, which is being offered by AWS as PostgreSQL database managed service. And most of the database service providers in the cloud, if you talk about AWS, you talk about Google or Azure, they have provided the inbuilt support. They have the database migration services. What is that doing? It is making sure that whatever uh, uh, enterprise databases you have, using their service, you can transform that to, you can convert them to PostgreSQL. So it is not like 100% migration is automatic. There are some of the things wherein you have to take manual action because there is a difference in the engine, and it is a kind of heterogeneous migration. But the idea behind this is, if topmost service providers are providing this kind of migration services, that means PostgreSQL is doing great. And this is something which is asking all the engineers which are in this field to learn and work on about it. This is just a basic of the background history. Like 1982, it was called as Ingress, then it was called as Postgre, and it was being used in Berkeley. And then for the first time in 1994, it was released as Postgre. 95 version was released, and now it is a version 3. And from 1996, its first release version 6.0 was released. Since then, it is in news, but in recent years, it has been very, very popular because of the kind of the community work which is happening and the kind of support it is being brought up. And all the service providers, we talk about the cloud, they are offering new features and the extensions which are in place. So one of the most important feature of PostgreSQL is multi-version concurrency control. So it is like you can have concurrent access to data. And in the multi-version concurrent model, what is happening irrespective of the current state of the database, you can see a snapshot of the database, like how it was sometimes uh, ago. So it is something like you can see the data which was available earlier as well. Though there are a lot of pros and cons which are causing the slowness in the database, and you have to perform some kind of vacuuming, you need to delete the dead tuples, but it is part of, and it is being offered as one of the best feature from PostgreSQL. It is synonymous to your locking mechanism, which is there in your enterprise level relational databases. So since it is not offering that kind of locking, uh, so it is becoming so popular. There is a concept of a schema like other enterprise relational databases. So you have this kind of concept over here. So you can create a schema over here. So multiple schema, and if you wanted to use the same name, so those can be used over here. So nothing different from others, but it is like these features are available. There is a huge support for different kind of database data types, and some of the newer type of data types which are not available in other databases. We are talking about both open source and the enterprise level relational databases. Asset compliance, we all know what it is, and PostgreSQL is compliant with that. That's why it is being used in most of the OLTP applications where this kind of compliance is required. We have a lot of database administration tool which are available. So if you're working in the cloud also, and since you do not have the access to SSH because we are using the service as a managed service, so port number 22 or that kind of accessibility to the operating system is taken away, but you have the tools using which you can connect to the database which is hosted in the cloud. So you can use PSQL, or you can use the pgadmin, or if you have PostgreSQL Studio, so you can use these. So as a cloud native tool, so PSQL is supposed to be one of the strongest tool in terms of the CLI. If you are familiar with the pgadmin, the administration of PostgreSQL is very, very simple. So these are some of the service providers which are there, apart from the three most uh, successful service provider of PostgreSQL in the cloud. So in 2007, it is Heroku who started providing the PostgreSQL as a managed service in the cloud, and it has been very, very successful. Looking on the footprints of those, PostgreSQL came up as an enterprise database by the company Enterprise DB, and it is providing a lot of features which are not being provided by other cloud service providers. So it is really doing great. When it was so successful, then the big cloud service providers like AWS, they started releasing it, and in the 2013 the first version of PostgreSQL in the cloud was released as a relational database service. In 2016 only, it released Aurora cluster, which is a clustering solution, Postgre cluster, which I believe it has some 15 read replicas which you can create out of it. I believe that's the correct number. And then in 2017, Microsoft Azure released the Azure database for PostgreSQL. So the three big players, they have already released it. And then you have the Alibaba Cloud and IBM Cloud. They also release similar kind of PostgreSQL service. So in short, open source relational database service like PostgreSQL is making its place in the cloud, and it is doing really great. And that's all about it. I hope it's going to help. Thank you. In this session, we are going to learn how to launch an AWS EC2 instance and how to deploy a PostgreSQL instance on top of that. So what we are going to do is, since PostgreSQL is one of the most world's famous open source relational database, and the way it is growing up, it has taken the attention of all the cloud service providers. So if you are already there in PostgreSQL in your on-premises environment, there may be two options. Either you go for the managed service like AWS RDS, or if your applications are logged in due to some reasons, then in that case it is good to lift and shift. In that case, whatever databases you have in Postgre in your on-premises environment, you wanted to let the database run in same way in the cloud also. So you have the possibility of using the lift and shift. So what we are going to do is we are going to launch an EC2 instance, and on top of that we will deploy the the binaries of PostgreSQL 13, and then we will enable the remote connectivity, and then finally we will try to connect it using some GUI tool. So just the basics of like why we wanted to be on the unmanaged service like infrastructure as a service or EC2 instance, so wherein we have to manage all the infrastructure which is related to the management of backups, patching, the patching of the operating system, and the databases and everything we have to take taken care. Where in the managed service we have everything covered up, but because of the n number of reasons, the way it works is in RDS the SSH control has been taken away, and there is a lot of restrictions which has been imposed. And if you wanted to continue with the way you are working in your on-premises environment, you just go and use the database in EC2. So whether we are going to use the EC2 instance or the relational database service, it entirely depends upon the way the application works, and it is all the ask of application only. So what we are going to do is it is a 5-step process. We are going to launch an EC2 instance using the AWS console, and then we will try to log in it through the PuTTY, and then we are going to configure the remote connection from the local system. Then we will try to connect it using the pgadmin and the command line interface. So let's quickly start up. So I'm already logged into AWS console. I'll say just launch instances. Okay, let me create an instance. So we are going to use the free tier instance. So the best way of learning and practicing the open source relational databases or the NoSQL databases is just go ahead and quickly launch some of the free tier EC2 instance or from some other cloud service provider, the lightweight virtual machines, and then you can log into that. Or if you have already some local virtual machines, you can use that as well. So I'm going to launch RHEL 8 system, which is in free tier, and that's more than enough, one virtual CPU and 1 GB of RAM. I'll just say next, configure instance details. We are going with all default settings. We are not going to get anything which is non-default, so everything will be default only. And we'll say next, add storage. We are going to use 10 GB of the storage, which is more than sufficient for our testing purpose. And then we will say add tags. We are not going to tag anything. Then we will say configure security settings. So this is very important if you talk about any relational database or any other database. You need to ensure that from where you wanted to access your system and what port. So one of the things we will be doing is we will be accessing the PuTTY session using port number 22, and I'll be using my IP address. So, or you can mention the IP address of your system, so it will pick up that as well. So let us say my IP, and I'll add one more rule. This is for PostgreSQL. Once we install that, I wanted to allow the port of PostgreSQL as well, so that we can access it remotely. Let's go with I will try with those and we'll see how it works. And then we will say review and launch. I have already created a key pair. I'm going to use that. So I do have an access, and we'll say launch instances. It is not going to take more than 1 minute or so. Once it is available, then we will see how to connect with that. Still it is in pending state. It is still initializing. So once it is done, it is still initializing. So okay, we have all the details over here. We will go to the networking, or simply we can say action or connect. Still it is getting initialized. We'll try to access it using the putty session, and okay, this is the public DNS which we have to use. And let's go to the putty session. There's the public DNS, and we have to go to authority, and we have to give the location of the key. So it is ec2-user. Those details are already over here. So we are logged in. Now what we are going to do is we have completed the first two steps wherein we have logged in. Now one of the things which we should do is we should disable the firewall. So just say, I think I have mentioned the commands over here. Okay. SC status. So as of now it is enabled only. So we are going to disable it. So vi config, and instead of enforcing we will say disabled. I should have used a sudo and just mention disabled. We might have to reboot the instance. Okay, this is done. Well, the next step which we have to do is we have to download and configure the PostgreSQL 13 on Linux EC2 instance. So what you need to do is you need to go to this site, and there you have to select the Linux and the version. If you simply select that, it will show you what all steps you have to do. So these are the steps which you have to follow. I have already copied it on the notepad, so we are going to just run it off. So we have to use sudo to install the requirements of Postgre. It is just 5 steps. We are getting the repository for Postgre. And there are some default modules which are available, so we have to disable those. Just disable them, and then you have to install the Postgre 13 server. It's very fast. Within 5 to 10 minutes your EC2 instance having PostgreSQL will be up and running. You will be able to access it from your local system either through the command line or through the GUI tool. Whatever you feel is better, it will be ready. You need an internet connection to perform all these steps. This is done. Go to the next step, initialize the database. This is initialization of Postgre 13 server. Then we have to enable it so that after reboot it should come up. And finally we have to start the PostgreSQL server. What we will do is, so when you install the Postgre on your system, by default it creates a Postgre operating system user, and it creates a database also, which is Postgre, and there will be a user also whose name will be Postgre. So let's switch to Postgre OS user, who is going to be the owner, and this is the command line psql, and there is a user also with the name Postgre. We have to change the password. So let's change the password of the user. We have changed it. Now the next step which we are going to do is we are going to verify if we are able to do the remote login on the same server. So it doesn't make sense when you have to say you have to log in on the same server with the IP address. So what we are going to do is so I'm logged in as PSQL. We'll say show config underscore file. So this is your postgresql.conf file. So we have to add the IP address of the system where this is running. So this is running on this. So we are going to add this. So we'll say vi. Okay, I'll show you from here. So by default, Postgre do not allow the remote connection. So anything which is on the local host, it will be allowed. So what we need to do is we need to change this. So we will say vi and listen address we have to change. Listen address we are going to change, and we are going to make it the IP address of the system. And the IP address or the host name, we'll try with both, which one works fine. Where is the IP? Okay, here it is. There is a caveat using it, but just for testing we are doing this. We have added it, and the next thing which we have to do is we have to add the IP address from where you are going to access this. So there is a file which is called as hpa underscore pg underscore hba.conf, which is Postgre host based authentication. We are going to add that as well, and at the bottom of that we are going to say who all are going to access the system. So these are the virtual IPs of the system from where I'm going to use it. So you need to check out on which system you are going to log in. So it should include those. Okay, so I have added IP addresses. In your case, you have to add the IP address of your local system. This is done. So once this is done, you need to restart the Postgre server. I'll exit from Postgre operating system user, and then I'll say sudo systemctl restart. I haven't given the permission so that Postgre can restart it. So it is done. Now let's check the status. We'll check the status. I need to reboot the server because CLinux might create some problem. And we will try to log in through the host name from the local system. And I need the host name. So the host name is, where's the public host name? This is the public host name. We'll mention it over here. So if I simply say psql-u Postgre and the password, which we have just set, you will be able to log in. But what if we have to mention the IP address or the host name of the system? It is saying this IP address, it should have been added in Postgre hba.conf. So let me check if this is the IP address which is added or not. Okay, I think we need to reboot the system as well, and then it may work. Okay. Or we will try rebooting the system from here, and we will say reboot instance 194. Okay, let us reboot the instance. It is getting rebooted, and within a minute this should come up. I should have mentioned the IP address, sorry, the host name. Let us check the status. This is the public host name. We'll say restart the session. ec2-user. We'll say sudo su space -postgre. And let's log in. PSQL, it is not accepting, so that means it is still down. We'll restart it. Sudo systemctl restart, and then we will check the status. I need to use it from this user. So okay, this is done. Let's check the status. This is running. Now let's try to connect it remotely. So it will show us, this is my PG admin which is running on local system. So I'll say connect. I'll go to create, and from here I'll mention the IP address. Let's say public IP address is this one. The only problem will be if the ports are not opened, and it in inbound rules that should be opened, or hba.conf that should have that entry. Okay, this is saying 122.80. This is not there in the hba.conf, so we are going to add that entry over here. So it should be in this format. So what we will do is sudo su space -postgre, and we will add the postgre-hba.conf file. Go to the bottom and add this line. let's restart the Postgre services. Check the status. Okay, this is working fine. And now try to connect remotely. Okay, we already have the connection. Just say OK. Um, 122. Okay, let me check. If config okay. One 122.80.200.23. So let me check. Oh, I missed one over here. So let's switch to Postgre user and added the file. This should work now. The IP address which I mentioned for host base access authentication, it was wrong. Restart the service, check the status, and retry the connection. It shouldn't work now. You are connected. So you are connected remotely. Your database is installed on EC2, and this is what we have done. So just a recap of what we have done is we have launched an EC2 instance, and we are trying to replicate a scenario wherein we have to migrate our application or the workload to EC2 cloud. In our case, this is just an open source relational database which is Postgre, which is still running on the older versions. The newer versions of the RDS support 9.6 onwards till 13, and 14.0 it's in the preview version. And this is what we have done. As a prerequisite, we should have then access to the AWS console. We should have PuTTY and PuTTYGen downloaded on our system. We should have a GUI client. In my case, it is pgadmin. Then we logged into AWS console. We created an EC2 instance with RHEL 8 image, and then we connected it to using the PuTTY. Then we downloaded the PostgreSQL 13 and started it. We enabled the remote connection. And the two important things which were here is PostgreSQL.conf file, wherein you have to remove the local host with the IP address of the server. And then we have a PostgreHBA.conf file, wherein we have to add the IP address of the destination from where you wanted to connect. So those IPs we have mentioned, then we have checked the status. And one of the thing in PostgreSQL is when we install Postgre or download Postgre using yum, it creates your Postgre OS user, and by default there is a Postgre database also, and Postgre um, uh, database user. Postgre database is also there. Sorry, so there are three Postgre, and Postgre OS user is the owner. And this is how we have done it. If you wanted to transfer the workload from here, it is the things will be almost same the way you work in on-premises environment. I hope it is going to help. Hello and welcome. In this session, we are going to learn something very, which is a basic part in PostgreSQL, that is setting up the kernel parameters for PostgreSQL when it is deployed on a Linux-based system. In this case, in our case, we are going to do everything on a Okay, so everything what we are going to do is everything will be there on a Linux system, and we are going to see what are the basic kernel parameters that we need to check or set to ensure that Postgre keeps on running properly. So the discussion topic is how do we manage the kernel parameters for PostgreSQL? So this is a very basic thing. Whenever you install a database on a Linux-based operating system, then you say that if the parameters of the kernels which are required for properly running, if it is not properly set, then you may run into problems. Talking specifically about the PostgreSQL, you may run into problem if you have the multiple instances of PostgreSQL which is running on the host, or there may be a case if your database size, I think this spelling is wrong. In case your database size is very huge, in that case, there may be an issue with the kernel parameters. The default one may not be sufficient, and you may have to adjust some of the parameters. I'm talking particularly in case when you have very large database application connecting through the n number of connections. You are not using any kind of connection pooling like PG bouncer. So that's the basic kind of scenario. So before we go and discuss what are the different kernel parameters and their usage, we will see a few things which are important. So we are going to see the details about shared memory and semaphores. So buffer, it is very important component of PostgreSQL like any other relational database. So there are two terms which we will be talking over here is SHM max. So this says the maximum size of shared memory segment. By default, this is at least 1 KB, but on your system, this will be always higher than 1 KB. So uh, I think where is my, okay, yeah, it is back. So I have a Linux system which is running over here. It is Ec2 Instance, so it doesn't make much of sense when we check the details over here. But let's talk about the SHM max. So this is maximum size of the shared memory which will be available for your Postgre. I'm assuming either there are multiple copies of Postgre or the database size is too huge. And the another component which you need to understand is SHM all. This is total amount of shared memory available. So these two are normally same, but when you see the value of SHM all will be different because it is divided by the page size in our case as well. Then you have an important parameter which is called as SHM min. This is the minimum size of shared memory segment. So in any case, this is the least value, which is 1. So that's more than sufficient for the minimum value because that's the minimum which can be available. There are two more parameters which are SHM MNI, which says the maximum number of semaphore identifiers. And there is another value which is called as maximum number of semaphores, which is on the system wide. So these are the five parameters, kernel parameters, which you need to check when you have the Postgre running. So this is SHM max and SHM all, which are related to shared buffers, and SEM MNI and SEM and MNS. So these are the five parameters. Why number 5 and number 6 parameter, they are very important because they have a dependency on some of the PostgreSQL components, which is max connection, the number of connections which is allowed to the PostgreSQL, the auto vacuum maximum number of workers which will do the auto vacuuming in Postgre. Then max wall sender, so this is the sender parameter for the wall files. Then you have the max worker processes. And these parameters are very important. The moment you increase this, it has the dependency on these as well. So when you increase this, you ensure that these parameters are also taken care because they are interdependent. So you need to check these 6 parameters, 1 2 3 4 5, and make sure that according to your RAM, these parameters, and according to the parameters which are set in PostgreSQL, they are set. So we'll have a dedicated session on this shared buffer, so we'll see in that. So what about the default shared memory? So if you are having a system with only one instance, and if it is just the basic kind of system, then you will say the default shared memory is more than enough. In case you have to change your settings, because let's say I have 24 GB of RAM available on my system and I wanted to allocate let's say 16 GB to my operating system, so that they will be given back to the shared buffer. In that case, we will say set the SHM max and SHM all to these values. So you can, the moment you change the 16 GB to other value, you make the approval. So this is 16 GB and this is 16 GB divided by 2048, and we will see how it is taken care. So this is divided by the huge page size. And if you have, once you have changed it, you need to either reboot your system or you need to recycle the sysctl.conf file. So sometimes for permanent settings, you need to reboot your server. So resource limit, this is another important parameter which you need to take care. If you have multiple instances running, then you sometimes you get the you might get the error that maximum number of open files exceeded for this particular user. And in our case, this is Postgre operating system user for Linux based system. In that case, you will see this kind of error. In that case, you need to adjust the parameters so that by default the parameters which are available, they are more than sufficient. But sometimes sometimes it may be you may be in a situation wherein you need to change it. So there is a limit for the entire kernel, and for each users also you will have to check it properly. So you can check for the maximum number of open files in this, or they can be changed in your sysctl.conf. Before we go down with the Linux memory overcommit, let me show you what is there. If you simply say sysctl-a, this will show you sysctl-a. Okay, I need to come out of Postgre as EC2 user. And if I say sysctl-a grep, what is the amount of SHM max which is present in my system, which is running an EC2, this is huge. This is huge. I haven't calculated it, but this is huge because it is an EC2 instance, so they would have given set it according to the best maximum possible value, but you always have the capability to change it, so you can change it according to your requirement. And you can check the other parameters whatever you wanted to check, and if there are any changes required, you can change it. And that's what I was talking about. SHM max and SHM all, they are same value, but sometimes they may be represented in terms of SHM max divided by the page size. So just don't be confused if sometimes you see it as a different value. It is the way they are stored. And there is an important thing which you might see, and sometimes it happens also, like you will see out of memory, and this is very common in Linux based system, where in operating system memory is exhausted, and your PostgreSQL process may get terminated due to this. So whatever processes are running, incoming connections were already available, they will continue to work, but it is not going to allow you the new connections because there is no memory available to cater those requests. So what you can do is there is swap space which you can increase at your operating system in case you feel that you have some shortage of RAM on your operating system. Then increasing this can sometimes help you to come out of this, and it is always a good practice to have the enough virtual memory available or swap enabled on your system, just in case your physical memory is exhausted, then it is going to be used from your swap. So what is the spatial consideration if you are seeing the over usage of, and this is going to be very important. We need to check if there are too much usage of memory. Then in that case you need to check the PostgreSQL.conf for some of the parameters which directly take the value from your RAM. So it is shared buffer, your work memory, hash memory multiplier. If you see they are not that much used, then you try to lower down their value just to avoid the issue which is coming out of memory, right? And the one of the problem with the Postgre is the maximum number of connections, because at the back end it is going to spin up one more process, and it is going to exhaust the memory on your system. If you see this kind of scenario is available in your environment, then you might test out the connection pooling, and you might try out some of the connection pooling software as well, like PG Bouncer. In that case, you will be able to manage the connection pooling, and you may adjust the value of the overcommit as well, which is more than sufficient in most of the cases. So this is something which occurs very frequently. So it is not just the operating system, RAM, swap. It is your PostgreSQL.conf parameters as well that you need to take care. What is the value you have assigned, and whether they are overused. They are oversized, and in that case you need to trim it off. Linux huge pages. So this is a great parameter if it is being used. In that case, what you have to do is you can start your Postgres without the Linux huge page. So we'll do a separate session on that. So let's see what is the current huge page. Let me switch to the Postgre user. And you simply say head minus $L $pg data Postgre master post.pid. Then it will show you the parameter, and then using this parameter you can calculate what is the requirement of let me paste it over here. Yes, this will show you what is your Linux use page requirement, and you can adjust it accordingly. So let me check out. This is the default huge page which is there. And if in case you wanted to change according to your requirement, you should be able to do it. So you have the formula available, and you can use it accordingly. So this is the formula which is available. In case you wanted to change it, you can change it according to your requirement. And we have already checked what is the current value set on our system. So what happens by default, if it is available, then it is going to use it, and when in case if it is not available, then it will go fall back to the non-available value of your huge pages. So this is going to be important, and just test it out if it works well for you. So just a recap of what are the important kernel parameters. So you should keep a check on SHM max, SHM all, SEM MNI, and SEM MNS. The formulas are also given, and you need to make sure that uh, you understand the different PostgreSQL parameters, because your kernel parameters are at the system level, and your PostgreSQL parameters, they are interrelated, and you have to make sure they are properly set. In case you wanted to change you wanted to assign a specific amount of memory for your kernel parameters, you set it accordingly, because your PostgreSQL shared buffer is going to pick the value from here. Resource limit, you have to specify it if it is you have too many Postgre system running, and in case you are facing some issues which is related to the maximum limit of maximum number of open files or something like that, then in that case you may need to sometimes, most of the times, not sometimes, most of the times, the default values are more than sufficient. Then you have Linux memory overcommit. This is a very what do you say, the regular kind of behavior in PostgreSQL, and in that case what you need to check out, what are the different memory based parameter in your PostgreSQL. If they are oversized, then you have to change it accordingly. Otherwise, you need to make sure that physical RAM and the swap, they are properly configured according to the best practices or not. And this is a very general problem, maximum number of connections in your PostgreSQL. If it is too much, then try to bring it down, and make sure, if you are not using the connection pooling like PG bouncer, in that case you may try to use it, and you may find it very useful. Linux huge pages, if it is enabled, that gives you the best performance in your Postgre, and just try and see what is the value which is required based on the formula which is given, and you can set it accordingly. I hope this. In this session, we are going to have an introduction to Postgre default user. So as a general info, when you install the PostgreSQL on a Linux-based system, let's say I have just installed the Postgre on my EC2 instance, and uh, this is how it looks like. So I'm already connected to PuTTY, and this is the shell. And the commands which I have used is sudo dnf, and these commands are available on the PostgreSQL website. And if you go there and you are just select RHEL8, it will show you all the commands. So this is just a list of 6 commands which you have to execute on the server, and this will install PostgreSQL database on your operating system, which is Linux in my case. So once this is installed, what is the next step which we have to do, and what are the default Postgre user in PostgreSQL instance that we are going to see? So Postgre is the default OS user, and it gets created when you install Postgre on the Linux or the Linux-based system. And there is a database user also created, which is Postgre, and this is the super user, admin user, which is going to be the owner of all the objects inside the PostgreSQL database. So you can check the authentication mode of the Postgre. There is a file which is called as pg_hba.conf, and by default, post installation, the authentication method is set to peer for all the users which are by default created. In this case, it is Postgre, and it can be MD5 in case you wanted it to make it to be password authenticated forcefully, right? So let's see how it happens. So I have just installed Postgre binary on my system using DNF. These are the commands which you can find it out, and if you just check the status, sudo systemctl status, this will show you that this has been done. So see, using sudo systemctl command, we have been able to see the status is active and running. Let's come out of this shell, and when this binary is installed, the database is up and running. We need to make sure there will be a service account who will be able to make it up and running, and that will be the owner of the PostgreSQL instance. So in this case, how to find out those details? So if you know some basics about the Postgre, so at the operating system, if you just grab etc passwd and grab for Postgre, that will show you that an OS user called Postgre has been created when you are doing the installation. And this is the home directory where the binaries are installed, and this is the bash profile. And how does the authentication happens in that case? So Postgre is the service account owner in this case. So we will switch to that sudo su space minus Postgres. And if you say PSQL, and if you locate the data directory, show data directory, there will be two important files which decides like how the authentication are going to happen. So you can see this is the location of the data directory, and inside the data directory there is a file which is called as hba pg_hba.conf. This file is responsible for host-based authentication. If you see the first line which says anything which is coming from the local, so let's say all the users or all the databases, they will have the by default authentication method peer. So in this case, I'm logged in as operating system user Postgre, who is the service account owner of Postgre instance. And how is the identification is going to happen? So there is a file which is called as, if you navigate to that particular location, there is a file which is called as pghba. Where is that another file? pg underscore ident.conf. If you see this file, it will show you how the mapping is going to happen for the particular user. So it refers to the Postgre. This file controls Postgre user name mapping. So it maps external usernames to their corresponding PostgreSQL username. For example, we have just created, or an OS user Postgre has already been created, and there is a database user which is already there. So they are mapped with each other. Right, so that's way in basic forms this works. So if you simply say sudo su space minus Postgre, which we have already done, and if you simply say PSQL, and if you see the list of the users, that will show you post installation what are the users which are created by default. So if you say /du, this will show you there is an database user which is Postgre created. It is super user. It has the create role. It has create database, replication, and the other details it has. You can find out the details using select username from pg underscore user command as well. So you can see that there is just one user which is created by default. And how can we check the privileges assigned to particular user? So you just mention the username and it will show you what all details it has. So this is the command. This is good, helpful command. Select table name as a schema and table name as table. Privilege type as privilege from information underscore schema dot table privilege. So this will show you what all it has privileges, what all this particular user Postgre database user can do, and where all it can do the things like insert, update, delete, truncate, those things. So I think there are 1,300 and something still it is going on. Since this is the database super user, so this will have so many things. All right, and let's create one user which is called as test user, and if we say /du, this will show you how many users are there in that particular PostgreSQL instance. So we have just two users. One is the default admin user, and the other is the user which we just created. And after that, if you simply say select username from pg underscore user, this will show you that test user and Postgre user, these are the only two users. We can see the information related to the test user as well. And since there are no privileges, it will show you over here. So just a recap of the default Postgre user. So when you install the Postgre on Linux based system using yum or DNF, by default it is going to create a Postgre OS user. That Postgre OS user is mapped to Postgre database user, which is created at the database level, and there is a database also created by default whose name is Postgre. So just you need to make sure that there are three names which are available when you work on Linux based system. Postgre OS user by default, which is created, and that can be verified using the command etc/passwd, and if you graph for Postgre, that will show you the information over there. And there are few more files which maintains like how the authentication is going to happen. So there is pg_hba.conf, which controls the host based access authentication. So in this case it is our local host only, wherein this authentication is going to happen at the peer level. And there is something called as one more file is there. Yeah, let me show you once again. This particular file name is called as pg_ident.conf. This particular file, this helps in mapping the OS user with the database user. So in our case, there was an OS user Postgre, and there was a database user Postgre. So that way it has automatically got mapped. I think it is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgres all about and its architecture. So the first slide is about the introduction. So what is Postgre and why it is so famous over a period of time? And this is one of the most sought database nowadays. So one of the most important feature of your Postgre database is it is an enterprise class open source relational databases. It can support SQL, which is a structured query language, and JSON, both format for querying, and it is there in for more than 20 years with the community development. If we talk about the usage, it can be used for the data store. You can use it for data warehouse, you can use it for geospatial application, you can use it for analytics. You talk about anything and it is available. It is good for all the data types, and it is well suited for all the advanced data types. And in terms of the performance, it is good like any other database which is licensed and which is very costly. If we talk about the features, Postgre is having the MVCC architecture, which is multi-version concurrency control. That means, let's say if I have fired a select statement from EMP table at one particular point of time, in a particular row I wanted to fetch, and at that same time the row has been updated, then there will be some inconsistency if I try to read data. But what happens when such operations happen, there will be a snapshot available of the previous data so that the data don't get messed up. Although this is not the feature which is only available in Postgre, but all the relational databases like Oracle and others, they do have this features inbuilt. And the important thing is this is free of cost. This is open source. And you have the granular access controls. You can give the access to the particular database to the role, or you can give access to the tables, views, or the procedures, triggers, a particular column. You can give the access. So those things, you have the granular access control. You have the concept of table spaces, or the other than your default table space, you can create a separate table space. You can keep all your data over there, and that will be useful when you are trying to take the backup. So it is just a logical kind of separation from other databases. There's a feature of asynchronous app replication, which is very good in terms of Postgre. The backup features that is tremendous in Postgre. You have the online backup. What you can do is at one particular point of time, if you wanted to restore your database, you can use the hot backup using uh, PG base backup, wherein something called as the log files, which is known as the write ahead logging, that will be enabled. If you take a backup of your base backup and all the files which are there in val, which is write ahead logging, if you take those backup, you can restore at one particular point of time, and that is useful when you create the standby database or the replication environment. It has the support for the international character set, so that is one of the other important feature. No wonder whatever the size of your database, it is going to support that. And when we talk about the fault tolerance, the write ahead logging features make it perfect suited for any particular disaster recovery when you have to recover your database at one particular point of time. Licensing, this is always bothering the organizations. If you talk about the famous RDBMS, you pay the cost in terms of the codes which you are going to use. Let's say talk about the Oracle, then you have to pay a lot of license cost. And if we are talking about Postgre, there is no license cost. And uh, more if you're going to use it on a compute where the number of CPU cores are more, then we always fear of paying more license cost to the proprietor, that is the organization from which we have purchased, let's say the Oracle Corporation. What in case of this Postgre, that if it is open sources, who's going to support it? So there is a dedicated team of contributors and those who continuously work on it. If there are any bugs, they are fixed, and the new versions are released over a period of time. So licensing, it is open source, and you have the code. You can use it, and you can use it any way you want it to. If we talk about the history of the Postgre, so PostgreSQL project was initially launched by Michael Stonebreaker at Berkeley University, which is University of California, I believe. And the original name was Postgre, which refers to the older version of the Ingress database, which was famous at one point of time. And I believe this project was kicked off in 1985, and after 10 years of development, this project was renamed to PostgreSQL because of its support for the structured query language. So who supports or who works on the development of this product? If there are any bugs or fixes, who does all so this is done by the PostgreSQL global development team. If we talk about the language support, that is awesome. It has support for Python, Java, Perl, .NET, Ruby, uh, C++, and ODBC. Everything is there. Let's talk about the architecture of Postgre. So it is a client server model. So the client sends a request to the Postgre environment. So Postgre, we have something called as memory parameters. So we have memory in the center. Then we have outside we have the background processes. So the main process when the server starts, there is something called as postmaster. So when an application, when there is a request from the client, it comes directly to the postmaster. The postmaster will check if it has all the required permissions to log in into the database. If it passes that, then there is a Postgre process spawned, and then the actual work begins. So let's say a select statement has been fired and that is stored in the data file. Then first of all, those values come to the shared buffer, and the Postgre is going to read it from there, and then the value is returned back to the client. So the application connects to the Postgre process, the postmaster process. The postmaster checks the application write, and if it is successful, then it connects the client application. The instance doesn't write or read the application directly to the data files. It puts it there in the shared buffer. And the Postgre process acts on shared buffer and val buffers. Val buffers is if let's say some data modification has happened, then this particular buffer area will be dirty, and using the write ahead log background process, those will be returned to the val files, which are kind of log files wherein all the information will be returned, and then that piece of information will be permanently saved to the data files when there is a commit. So it is awesome in terms of the kind of work it does. Then there is a checkpointer process as well, which checks checkpoints, and at one particular point of time your database will be in consistent mode, so that the data in the data files and memory that will be flushed to the data files. So this is just a basic. So we have the memory area, we have shared buffer, wherein the red value of from the data files are there. Then you have val buffers, wherein any data which is supposed to be, which is changed, it has to come into this area, and using the val, it is returned to the data files. Then you have work memory and maintenance work memory. If you have enabled the archiver, then the val files are moved to the archived val files. So this is just the same diagram. So we have the postmaster process, which is the main process. Then we have Postgre process. Then these are some of the important memory areas: shared buffer, val buffer, work memory, maintenance work memory, and then you have some of the very important background writer, which writes the dirty buffer to the data files. Val background process, what it does, it picks up uh, the uh, the the changed value from val buffers and write it to the val files. If you have enabled the archiving, then it will be finally returned to the archived val files. Uh, the next one, it is just a description of the different. So when you say systemctl status and PostgreSQL, then it displays you these processes. We'll see it on the demo. So the first process, which is spawned after the postmaster, is the logger. So what it does, it writes the error log file to the log file. Then we have the checkpointer. When a checkpoint happens, so there are some predefined interval wherein the checkpoint happens, and all the dirty buffers, the data which has changed, it is returned to the data files. Then you have writer. Writer again, this is the background writer, which it periodically writes the dirty buffers to a file, otherwise the checkpoint happens. Then you have the val writer, which is a background process which picks up the information from the val buffers and write to the val files. Then you have one of the very good feature, which is called as auto vacuum launcher. So it is kind of releasing the unused space when there are a lot of inserts, update and deletes, and a lot of space has been released in the tables. Then it does a maintenance work on that. So we'll have a separate discussion on that. Then we have archiver. So when you have the val enabled, so write ahead logging enabled, and you wanted to keep all the transaction logs, so you have to enable this so that you can safely recover your database at a one particular point of time. Then you have a stats collector. Uh, it will tell you about the table usage, statistical information. So these are the background processes which are spawned when you start your uh, uh, Postgre instance. Memory area, you have shared memory wherein database caching and the transaction log caching happens. Then you have shared buffer. So this term you can see in almost all the versions, all the engines of the database. So what it does, it minimizes the disk I/O, and what it does, it puts all the bigger tables into the buffer, and it minimizes the access time when it has to pick the data from the data file. So it puts it into the shared buffer. Then you have the wall buffers. What it does, it temporarily stores changes to the database, and when it has to write to the wall files, the wall background process picks up picks it up from the wall buffers and write it to wall. It is useful for backup and recovery. Then you have the postmaster process. So what is the postmaster process? The postmaster process is the first process which is started when you start your PostgreSQL instance, and it performs the recovery. It initializes the memory area. It runs the background processes, and the last, which is last but not the least, which is your work memory space, maintenance, work memory, and temporary buffers. These are the different memory areas which are used for sorting. So when you say work memory space, this is used for sorting and temporary bitmap operations and hash join. So the default value is 4 MB, and maintenance work memory if you have the auto vacuum enabled. So and this is used for mainly for your create index and vacuuming. Temporary buffers, this is used for the temporary tables in case you use the temporary tables. And that's it. So we'll see a very small demo which says systemctl status. So let me fire this. Systems ctl status PostgreSQL 12. So when you fire this, you will say that the status is running, and you will see all this. So you have the process ID. The main PID is 1115 postmaster, and this is what we had spoken about in the architecture. This is the first process, background process, which starts, and then the other processes are started. Logger, which logs all the error message file in error log. Then you have the checkpointer. Then you have background writer, which writes the dirty buffers. Then you have wall writer, which picks up the information from wall buffer and write it to wall files. Then you have auto vacuum launcher. It writes it does the auto vacuuming work, like when you there is a create index happening, or when it has to release the space, unused space in a table. Then you have the stats collector, and then you have logical replication launcher. So this is basic of the architecture of your uh, of your Postgre environment, and we'll quickly do a recap of what we have done. So we talked about the introduction of Postgre environment, why this is so famous. Then we talked about different features. We talked about the licensing, which is free, open source. Then history of Postgre. Then the architecture, memory architecture, background processes, and different physical data files where it is written. And then we discussed about how the data is flown when a client requests the information, and the, the definition of different background processes, and memory areas, and the work memory, area related components, and that's all. Then we checked the system CTL status Postgre SQL 12. Then we saw different background processes. Then we saw one more thing. You can see the PS3-P1115. So this shows like what is the relationship. So postmaster is the base. From here, rest of the background processes are spawned. And if you see 1271, it corresponds to the logger. I hope this is going to help, and thanks for watching. Welcome. In this session, we are going to learn some basics about the logical and physical PostgreSQL architecture. So I have placed everything in a notepad, and we are going to continue from there. So this particular topic is all about the logical and physical architecture of PostgreSQL. So the first thing is PostgreSQL has been popular from so many years because of this is one of the most famous open source relational database. And if we say in terms of its position, it is considered as number one position in terms of the open source relational database. So just talking about the few of the concepts, the first thing in this PostgreSQL is what is a PostgreSQL cluster? So if we say PostgreSQL cluster, this cluster doesn't mean the cluster which we know about in the clustering world. It doesn't mean the n number of nodes which are joined together to form as a unit. In case of PostgreSQL, a cluster is a collection of databases which is hosted on a Postgre server. So that's all about that's all about the PostgreSQL cluster. So in one cluster there may be many databases. In one database there may be many objects, and a data object is it can store the object at the same place, or it can refer to some remote location as well. So in PostgreSQL world, we'll say a database is also called as the database objects. So just to show you a small bit of the demo, a bit of demo. Uh, so it's all about so when you install the cluster PostgreSQL, when you install it, let's say on Linux, then one of the final step which you perform is you execute PostgreSQL version number setup and initdb. That means you initialize the database. Once you do that in the particular location, it is going to create a number of directories and subdirectories, which stores the information directories of and files. So we discussed about PostgreSQL cluster. Then we are going to discuss about what is OID, which is object identifier, right? So in PostgreSQL, the object identifier or OID is called as the objects inside the PostgreSQL. They are stored as object identifier. So they are just 4-byte integers, and that holds some kinds of relationship. So let me quickly show you how it works. So let us create one database, and then we will see what is an OID of that particular database. So let's say PSQL. We have these many databases, and if I simply say select dat name comma OID from PG underscore database, and we created a database with the name testdb. So this is the object identifier. This is unique inside the PostgreSQL cluster. And you can find the relative name as well using this command, which is for PG underscore class. So here also, oh, okay, I should have given the table name over here. Again, we will have this thing in going forward. So let's talk about the physical structure of PostgreSQL. So when you install the PostgreSQL cluster, so the one thing which comes is the base directory, right? So I'll show you how it looks like. So this is my data directory. If you simply say PSQL show data underscore directory, then it will show you this location where all the database related files are stored. So this creates all the directories and files when you initialize your database. And when we are talking about the base directory, it is created at this location. So if you see, there will be a directory called as base over here. Can you see this? This is base directory. Coming out to discuss about some of the files and subdirectories under the base directory. So let me show you over here ls-r ls-ltr grep conf. We just wanted to see what are the different configuration files. So one of the important file over here is pg underscore version. So where is that pg underscore version? Here it is. So if you view this, you will be able to see the version of the database. That's the major version of this PostgreSQL cluster. Along with that, there are n number of configuration file. One is postgresql.conf, which consists all the configuration related parameters of PostgreSQL cluster. And there is another file which is relevant to this, which is postgresql.auto.conf. That means if you have executed any alter system, and if there is a dynamic parameter which can be changed while the database is running and it doesn't require a restart, then it will be stored over there, and your instance, PostgreSQL instance or cluster, is going to read it from here. It will be overwritten by the alter system command. So there is another file which is very, very important. It is pg underscore host based authentication dot configuration file. That means the client authentication happens through this file. So all the information related to the client, like how they are getting authenticated, what should be the database name, what should be the IP, and what kind of authentication it has to go through. That all is mentioned in pg underscore hba.conf file. So if you just view this, it will look something like this. So this has the host name and let's say what is the database name, what is the username, what is the IP, and what kind of authentication method it has to go through. So that is there in hba.conf file. There is another important file which is called as pg underscore identity.conf. This file contains the information related to user mapping. So that information is stored over here. So we discussed 5 important files, and then moving on to the directories and subdirectories. So I will not uh, from here we will not try to navigate, but that will be confusing. So I'll show you base. So when you initialize your cluster, this is my location, you will see something called as base over here. If you cd to base, you will be able to see these files which contains the OIDs of the different databases which are created in your PG PostgreSQL cluster. So base, it is having per database subdirectory. So these are the OIDs of the different databases which are created inside this PostgreSQL cluster. Second one is global. This particular directory contains the information related to the cluster-wide tables. So if you just go through that pg this global, you will be able to see these files. We will discuss what are these FSM and VM related names. We have something called as pg underscore commit underscore ts. That means it contains the information related to the transaction commit timestamp data, and this is present from 9.5 and the later version. PG underscore clock, this is obsolete. You have something called as PG underscore DY and SCHEM. So this contains, if you see, dynamic, this stands for dynamic shared memory. So DYN is dynamic, SHM is shared, MEM is memory. So this contains the information about the dynamic shared memory. We have something called as PG underscore logical. It contains the data related to the logical decoding, and most of these features are available from 9.4 onwards. We have something called as PG underscore multi-exec. It contains the information related to multi-transactional status data. You have something called as PG underscore notify, which contains the information about the listen and notify related data. You have something called as PG underscore wrap slot. So this particular directory is required, or this particular configuration is required when you perform the replication from one node to another in PostgreSQL. You have something called as PG underscore serial. It contains the committed serializable transaction. You have something called as PG underscore snapshot. It contains the exported snapshot, and this has been available from a version, I believe, 9.0 onwards. You have PG underscore stat, which contains the information related to the statistics. You have something called as PG underscore stat underscore temp, which is related to temporary files for the statistics subsystem. You have something called as PD subtrans. It contains the information related to subtransaction status data. We're not going to discuss the detail because this is going to be very, very lengthy, and we'll try to see it in some other session. So we have something called as PG table space. It contains the symbolic link to the table space wherein you are going to store your data. You have something called as PG underscore two phase, which contains the information related to the prepared transaction. You have the next one is PG underscore wall, which is write ahead logging, and you have something called as PG underscore exec and xlog. These are the different directories which are available over here. So you simply say ls and you will be able to see it. It is not important you learn about these, but you should be knowing most of these. Then we have files layout structure in database. So a database is available in the subdirectory under the base directory. So if you cd to base, you will be able to see a few directories over here. So these are the OIDs of the different databases which you have created. So you can see one demo database and one test DB, and there is 1, 2, 3, 4, 5, total 5, and you will be able to see total of 5 directories over here. So these are related to the different databases, which are some of the system databases, and remaining are user created databases. So if you wanted to relate it, you can just execute this. Select dat name, OID from PG underscore database. So you can see 16390. It is the OID of test DB. If you try to find out the OID of the default database, which is Postgre database, you will be able to see it. It is 14172. 14172. So this is how it is related. And if you wanted to know how is the layout of the different tables and indexes which is stored inside the particular Postgre database, then you can do it like that. So let's say let's switch to some table, connect to one of the database, which is testdb. And let's create a table. So we'll create a table called as course. We'll select data. Table is created. Let's verify the rows. There's nothing. Let's insert some rows. You can see there are 3 rows inserted, and if you simply say find out the OID and other information related to that particular table, you can execute this, and you can see that OID of this particular table is 16397. And let us go where we have created it. We have created it inside the test DB, and let's come out of this, and let's go to test DB. Test DB is 16390. 16390. This is the OID of the database, and we created 2 tables over one table over here, uh, uh, um, and the OID is 16397. That should be available 16397. So this is the OID of the table which is created. So this is how it is related. And if you simply wanted to see the relevant path, it will be available inside the base. So I hope you are already aware what is pg_data, which is a global variable for displaying the location of the data_directory. You can find out the complete location using this command as well. So we'll say psql/l. Let's connect to test DB and execute this command. So you will be able to see the complete relational file path name of the table which we have created. And inside that we have seen in that particular OID, we have seen some of the files with the name FSM and VM that contains the information related to the table. So that data is stored over there. So if the file size of the table and index it goes beyond 1 GB, then it is going to create a new file with the relative file node, and .1, .2, and this way it goes on. So if you wanted to change the size, you can do it. You can make the change using the hyphen with the segment size name, and it is going to work. So that's all about the physical and logical structure. So just to recap, PostgreSQL cluster, it's not the cluster, it is just the instance which you create on one of the node. So it is cluster only, right? In one cluster there will be several databases, and one database can have many objects. The simple things like any relational database. So you have OIDs. This is the important thing in PostgreSQL. So all the objects, including your database also, they are identified with the object IDs, and this information is stored inside the database, inside the some of the important catalog tables. Then talking about the physical structure, you have some of the important file. There are 4 important configuration file. One is PostgreSQL.conf, which contains the information related to the PostgreSQL cluster. You have something called as auto.conf, PostgreSQL auto.conf. So if any dynamic changes are made and that doesn't require a restart, so those information will be stored over here. So you have PG_HBA, which is host based authentication relation details are there. Then you have identity related details are stored over here. These are the subdirectory details, and this is available inside your data_directory. And we have seen some of these important directories and subdirectories which are available. Files layout, we have seen how the OIDs are displayed on the operating system, and that's the way it is mapped to the database. And inside the particular database, you can find the different tables which are stored as the OIDs. And finally, we saw how the tables are stored inside the database directory, and how their relative relational file path name we can locate using some commands. And the data is actually stored in these 2 formats, _FSM and _VM. and you can check the size, or you can control the size till what size it can grow, and it has to create a new file, and that's how it works. I hope this is going to help. Thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use PostgreSQL .conf on Postgre in Linux environment. So the first thing is, what is PostgreSQL.conf file? So PostgreSQL.conf file is a parameter file which is available on Postgre server when the Postgre server is installed, and the parameters are read when the server starts. So when the server restarts, it means when the Postgre server restarts, and most of the parameters are global parameters, and they are read when the server is starting up. And let's see some of the facts about the server parameter file, which is PostgreSQL.conf, like what is the location of PostgreSQL.conf on Linux environment, and how do we change it, how do we check. So let's see a small demo. This is my PostgreSQL server. So I'll just say systemctl status PostgreSQL. Uh, the version is PostgreSQL 12, so you can see the status is active and running. So what I'll say is pSQL, and I'll be connected to the Postgre prompt. So by default, PostgreSQL.conf is located in data directory. So if you say show data underscore directory, it will be available at this location. Or if you wanted to see the exact location, you will have to say uh, show config underscore file. So you can write show config underscore file. So this will give you the complete location of PostgreSQL.conf file, and you can view it using the view command, or if you wanted to modify some of its parameter, you can uh, save the changes using vi, and some of the parameters require server reboot, some of them may not require the server reboot. So that is a very interesting point, like how to check which one is requiring the. Okay, this is my PostgreSQL.conf, and how do we check the parameters? So it is the parameters are listed in pg underscore settings. So if you say select name comma settings from pg underscore settings, you will be able to see all the parameters. So you can see allow system modes. So it is in alphabetical order. So I think it is close to some 300 parameters. So 314 parameters are there, and you can see the values on the right side, the parameter name on the left side. Let's see how many distinct parameters are there. So we'll say select distinct context, context from pg underscore settings. So if there is a context as postmaster against any parameter, that means when you try to modify that parameter, at that time you need to restart your PostgreSQL instance so that the changes are reflected. So we discussed about postmaster context. Okay, let's move on to the next slide. How to modify PostgreSQL.conf parameter. So we checked how to check the parameter, and then we will see how to modify it. So let's see some of very basic parameter. Like if I say show port, it will show me at what port this Postgre is listening. So it is listening at 5432 port number, or or there is a very basic parameter which is max underscore connection. So if I say show max underscore connection, so there are 100 connections allowed at one particular point of time, and if you go beyond this you will not be allowed to connect it. So let's see how do we uh, make changes to this parameter from 100 to 200. There are two ways. One way is either you edit the parameter file using BI editor and you restart the instance, or you can use there is something called as alter system. You just say alter system set max connection equal to new value. So in this case, we are trying to increase it from 100 to 200. So I'll say alter system set max connection equal to 200. So let's do that. So it has changed to 200, but this requires a reboot, so this will not be reflected as of now. So if I say show max connections, it will still show 100. So where do we find like it has gone to? So let's go to the data directory and show data directory. I think we already executed it, and so this is the location of PostgreSQL.conf cd, one step back, and this is the data directory. So if I say ls-lrt, so there is a file which is called as postgresql.auto.conf. So if you view this file, you will be able to see the alter command which you just fired. So max connection equal to 200. So what happens when you restart your instance? When you restart your instance, this value is picked up from here. First of all, your PostgreSQL.conf is read, and then this PostgreSQL.auto.conf parameter will be read. So let us restart the instance. Sudo systemctl restart PostgreSQL 12. So instance is restarted. Just check the status. It is in the running mode, and now let's uh, log into the command prompt PSQL, and we'll say show uh, max underscore connections, which we updated using set parameter alter system. So you can set the parameter globally using alter there. So there are some parameters which are applicable for global. There are some which are at what do you say, the session level. There are some at your user level, so you need to classify them. Okay, moving on to the next one. So there are different components which are available in PostgreSQL.conf. So there is something called so when you open it or when you view it using the view command or edit it using the VI, you will be able to see something called as connections and authentication, which will have listen address equal to localhost. That means um, this particular tutorial is not about defining what are the different parameters like, but this will give you a kind of glimpse of what is PostgreSQL.conf, how to modify it, where it exists, and what all can be done with this. So there is, in this particular section, connection and authentication, you have listen underscore address equal to localhost. By default, Postgre do not allow the remote connections, so it is equal to localhost. So if you have to allow remote connection, you need to change this value from localhost to the IP address of the server. In my case, the IP address of my system is 71.192.168.1.71. So in case I have to allow the remote IP address connection, so I will have to add the IP address of the server itself, where server is running, Postgre server is running. Port is 5432. Max connection is equal to 100 at this present time. So you can see on the right hand side of each parameter there is change requires restarts. If you try to restart, change the value of max connection from 100 to 200, you need to restart the server, sorry, the my Postgre instance. And let's move on to the next one, connection and authentication. Then you have something called as a resource usage. So how much of resource you wanted to give to Postgre server. So by default, for our system where I have 2 GB of RAM, I have given 128 MB. So when you are tuning such parameters, shared buffer, you need to set to some minimum value, let's say 15 to 20% of the RAM. Then you need to gradually increase till the time you find the optimum usage of the RAM. So if you try to update any of the parameter like huge pages or shared buffer, it says the change requires restart. So you need to restart the change. But there are some parameters you will not see, like change requires restart, like work underscore mem is equal to 4 MB. So uh, uh, this is work area when some temporary rearrangement has to happen in the memory. So you can see it is some 64 KB, and as of now it is 4 MB. And if you have to increase the value, you do not need to. I think this can be done on the fly. The next one is val, which is write ahead log. That means whenever any change is made to the database, so before writing to the database, it has to be written to a file, which is a val log. So you have these replication parameters also mentioned in PostgreSQL.conf. So you have sending servers, you have master server, you have standby server. We'll have a separate session for replication. In PostgreSQL.conf, you have something called as query tuning also. You can enable the hash join or index scan. So by default, they are on. If you wanted to turn it off, you can do that as well. So you have a lot of parameters, some 312 parameters we saw in PostgreSQL.conf. So based on your requirement, you can turn it on or off. Reporting and logging, like let's say where I wanted to record all what is happening, so you can put it into where to log. Then you have when to log and what to log. So you have all the flexibility available. Auto vacuum is one of the greatest feature in Postgre. So any unused space or any kind of maintenance activity happens by in this auto vacuum. So by default, it is enabled. So we have a separate session on auto vacuum. Client connection or defaults are available. Then you have lock management is also available, like what happens when the deadlock is the instance faces the deadlock situation. How many locks per transaction it can support in particular point of time. Then you have version and platform compatibility. So this is somewhat related to your backward compatibility. Error handling. So when your instance suffers some kind of error, what it's supposed to do, it is supposed to exit or restart or what it has to do. Config file includes, so this will give you the location. So this option allows settings to be loaded from file other than the default PostgreSQL.conf. In case you wanted some non-default PostgreSQL.conf, so you can do it in config file includes. And that is it. So just a recap, what we saw is we did a small demo, like how to find the location of PostgreSQL.conf, and then we saw if the context is postmaster, then in that case you have to restart your instance, and if you there are parameters which can be changed globally using alter system set command, and there are some parameters which requires restart, And when you say older system set, and if it requires a restart, it goes to PostgreSQL.conf auto file, and it is read when your instance is coming up. So the first one is to be read is PostgreSQL.conf, and that is the second one in that. And there are several other parameters which are available in PostgreSQL.conf. Let us see how it looks. So let's go to the data directory, ls-lrt, and this is PostgreSQL.conf. If I just say vi, if I wanted to add it, I'll have to do this. So this is PostgreSQL.conf. So the file consists of lines in the form name equal to value. So there is a parameter, and on the right hand side there will be a value. So it is mentioned over here that this file is read on server startup, and when the server receives a sign up signal, if you added the file on a running system, you have to sign up the server for the changes to take place. Run pg underscore ctl reload or execute select pg underscore reload underscore conf. Some parameters which are marked below requires a server shutdown and restart to take place. So you can see there is one parameter section which is file location, like what should be the location of data directory, HBA file, ident file, external PID. Then you have connection and authentications. Listen address is very important if you have to enable remote connection. So I have mentioned the IP address. Port is by default this one. Max connection is 100. Super user reserved connection is 3. So this is under connection and authentication. Then you have the second parameter section, which is resource usage. Like you can mention the amount of the RAM which can be dedicated to shared buffer or work memory, and so on. And so there are a lot of parameters which you can do. Then you have val log parameter. So a lot of things are there in each section. Then you have replication section, wherein you can uh, once you have the replication set up, you can enable the parameters. So we'll have a separate session for this. Then you have something called as query tuning. So it is there is a great scope available in PostgreSQL.conf. Then you have reporting and logging, like where to log, what to log, and like rotation also is available. What, when, and where. So everything is available for your this thing. Then you have process title, like what should be the Postgre cluster name. Then you have statistics section, auto vacuum is there. Then you have client connection defaults. We are not discussing the individual components. Then you have log management. You have version and platform compatibility. Then you have error handling component. I'm just going through the different components which we have. So there are 312 parameters which are available. So, and uh, and it depends, like if parameter has postmaster attached to it, that means underscore pg underscore settings, then you have to restart the instance. Otherwise, you don't need to do so. So I hope it is going to help, and thanks for watching. Welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use pg_hba.conf. So I have done some pre-work, so I have listed all the steps which we are going to perform for this particular pg_hba.conf. So first of all, let's understand what is pg_hba.conf. So it is a file which is available in the data directory on Postgre server, and it is known as Postgre host-based authentication file. And this is responsible for four things, like which host or which IP address are allowed to connect through a particular role. How the clients are authenticated, like they will be using some password or MD5 or some crypt, or and then which PostgreSQL username they can use, or with which role they will be able to log in, and which databases they can access. So all this information is mentioned in pg_hba.conf file. To demonstrate this, let's perform a small demo, and then we will go through all this theoretical part. So the demo which I have is I have two server. One is will be acting as a server where PostgreSQL 12 is running with the IP address 192.168.1.71, and another is 61, which is a client. So let me quickly log into the server, and what we are going to do in this demo is we'll log into the Postgre server. We will create a role with the name user2_remote. We'll give it a login access, and then with this role, we will try to log in from the remote server, and we will see what all steps we have to take care when the this particular role is trying to connect from the remote server. So we will be doing two things. Since by default the Postgre do not allow remote access, so we will enable that access, and then we will mention the IP address of the remote server in our Postgre server so that it allows the access. So let's start. So I'm already logged in through the mobile external, which is a GUI tool, and this can store your IP address, user ID, and password. Since this is a demo environment, so this is good to have it. So I'll just say sudo systemctl status PostgreSQL -12. So you can see the status is active and running. So just switch to PSQL. So I'm onto the command prompt. I'm going to create a user with this particular command. Create role, role name with login and then password. So just say /du and you can see the role. User2_role is created, which is having the uh, login access. It is not having cannot login, so it will be able to log in. Let's quit out of this prompt and then log into the remote server. From remote server, we will try to log in with the details. So the command to log in from the remote server is this one. So I'll just have to say psql-u, which is username. The user which we have created is user2_remote -w postgre, and this is the IP address of the server. The server is running on 1.71. Just press enter and feed in the password. So password is password. So this is saying that it is not going to accept the connection, and once the connection is accepted, you will have to, it will prompt for another one. So we will make two changes. One is uh, there is a file which is called as postgresql.conf. So this particular file, there is a parameter which we need to tweak, and the parameter name is local_address. By default, Postgre do not allow remote connection. So just to allow the remote connection, what we have to do is we have to remove the local host entry with the IP address of the server itself. So this will be removed with the IP address of the server itself, which is 192.168.1.71. When you make this change, you have to restart your service. So just make sure that you do that. So we'll save this. And then there is another file which is pg_hba.conf file. So what you have to do is in this we will mention the rule, like how the remote server will be able to access. So if you open this file, which is owned by Postgre and Postgre, so you scroll down and there is a section called as IPv4 local connection. So there are 5 entries which you have to mention. There is type, like we will say it is host based. Which databases you wanted to use, so we'll say all databases. Which user you wanted to connect with, so I'll say user2 underscore remote. With which IP it is coming from? It is coming from 192.168.1.61. And then what authentication method it is using. So there are several. In our case, we will be using MD5 so that the password doesn't come in plain text. It will be encrypted, and we'll just add this line. So I have already added that line and just uncommented. The detail is first is host, all, then the user ID, all, this is the database, all the databases, this is the user ID, this is the IP address, and this is the authentication method. So just save this. So we have made two changes, one in PostgreSQL.conf, where in the local host is replaced with the IP address. In pg_hba.conf, we added the details of the remote host. And we need to restart the service of PostgreSQL because we have changed our parameter. So just restart it. Just check the status. The service is active and running. Now let's try to connect it from the remote host. You can see you are able to log in. You can see all the databases because you have mentioned all. You need access on all the databases. So now let's come back to the theoretical portion of this since we have done this demo. So the first thing is, what is pg_hba.conf? The pg_hba.conf is a Postgre host-based authentication which takes several parameters. So mainly it is 5 parameters. One is the host, another is the IP address of that host, then which databases you wanted to access, and then the method like using the password, peer, or trust, or reject. Now, if let's ask few questions and answer it ourselves. What is the usage of pg_hba.conf file? So this file is used for client authentication, which is available on the Postgre server, and this is for the client IP, username, and the database name authentication. It has a number of entries. Mainly there are 5 columns, which defines like which host, what IP address, which database, which user can access. What are the contents of the file? So it has a number of parameters, mainly 5 parameters. So it is all related to the particular host, user ID, and the database. And when is the pg_hba.conf file is read? So whenever an application requests a connection, the request will mention a Postgre user ID and password. In our case, it was test2_remote. So when PostgreSQL receives a connection request, first of all, what it will do is it will check the pg_hba.conf file, which is Postgre host-based authentication file, and it will verify that the machine details are available in that or not. So as soon as it finds the detail, it will either accept the connection or reject it. So it is just the connection. It will not give. It is not related to giving the access to the tables or other stuff. So next question is, do I need to restart the PostgreSQL post a role creation and access connection? So whenever you create a new role on a PostgreSQL server and a new connection is requested based on that created user ID or the role, you mention a matching entry in pg_hba.conf, then it checks whether that entry is available or not. And once it is verified, the access is granted. So you do not need to restart the PostgreSQL server, Postgre server every time you add an entry in pg_hba.conf. So what is the sequence of reading the elements in pg_hba.conf file? So So it is like when a connection is requested, the Postgre will read one entry at a time from top to bottom. So if I show you this, this is my server, and uh, if you view this HBA pg underscore hba.conf file, if we scroll down top to bottom, so it will be coming top to bottom. So in this case, as soon as it finds an entry, let's say I'm trying to connect through this IP address, if there is an entry available, so the access is granted. So you can give the host and then database, either it is all or the particular database name, or let's say there are 5 databases, so you can give let's say the 5 databases are A, B, C, D, and E. So I can mention A, comma B, comma C, comma D, or comma E. Or if there are n number of databases, you can put all the database names in a file, and you can mention the file location over here at the rate and the file location, so it will read from there. And you can mention the user ID over here. If it is more than one, then I think also that is possible. I have not tested, but this should be possible. Again, the concept of more user ID, uh, keeping in a file, you can use that. And then the IP address or the range of the IP address. In this case, /24, that means only first 3 will be constant, and this can be anything between 1 to 254, I believe. And this is the authentication way. The next one, which is very, very important, if you haven't, if you do not know like how to find the location of pg underscore hba.conf file onto the Postgre server. So you log into sudo su space hyphen Postgre. Let me clear this screen. And what I will say is PSQL, and then you have to mention show HBA underscore file. So this will tell you the location of HBA file. If you do not know this parameter name, then by default this is available in your data directory. If you have changed the data directory, you need to check this. So data underscore directory. So most of the time I keep it handy so that I can copy and paste. So this will be available in this particular location. If you don't know much about these commands, if you do not know if it is this is the first time, then you can use the Unix based as well. Or there is a direct command, so you can say psql-t-p format is equal to unaligned, and then you can say show hba underscore file. So it is like it will directly connect to PSQL and then give you the output. This is the file name. Or you can use the find command, which is the Unix command, and this will show you. It takes some time, so let it come out. Till that time, what we will do is we will go further. So this is a sample pg underscore hba.conf file. So there is one local section wherein the concept of Unix socket connection comes. So all the local users, they can be put over here and they will be able to connect. So by default it is all users which are created which try to connect from locally from the server. If it is remote, you have to put the entry in IPv4 local connections. Make sure that your PostgreSQL.conf file has the listen underscore addresses replaced from localhost to the IP address or the star in the previous version. And then you have to mention this particular entry, local host all the IP address, and then the subnet, and then the authentication method. If you wanted to enable all connections using IPv6, you have to mention this. And if you wanted to reject also, so there you can mention the IP address and mention reject. All right, so let's see an example of single host entry. So it is host, which we have mentioned in our case. Either you mention the database name or all the databases, you mention the username, the IP address, then the subnet, if it is like this, or let's say the first three will be constant and this can change. So let's make 8 3s are 24, and this is trust, not good, but let's make it MD5. This should not be suggested even. If there is a rejection entry, then you mention the details and particular IP address, fixed subnet, and then you mention reject. If it is script, then also it will look like this. If you wanted to mention about a small network, so just mention host. This is the database or the list of databases. Let's say template 1, 2, 3, 4, or at the rate file name, which consists of n number of databases, or username, or n number of users, and then 192.168.1.0. So 1 to 254 IP address, so they can access, or you can, or let's say you these two will remain constant, and anything in here in between 1 to 254 and here also, so you have a bigger network. And if it is like this, only this will be constant and this will keep on changing. So this is how, so small networking part, but most of the time you will have something like this, only these two might change. So just a recap of what we have done. We did a demo where there were two server, one was server and another was client. We created a user with the name user2 underscore remote. Then we try to log in from the remote server using this particular command. This is my remote server. So initially when we tried connecting psql-u username w database name -h, the IP address of the server where Postgre is running, we got this connection refused because initially it was allowing only the local connection. So you have to remove that local connection with the IP address of the server itself. Make sure you are not adding the entry of the client in PostgreSQL.conf, which is the server parameter file. And then we made two changes in two files. One is PostgreSQL.conf and another was pg_hba.conf, wherein we added the details of the server, the client where it is running. So we mentioned it like uh, host name. So let me quickly show you this. So the entry which we added is like this. Host, I wanted to access all databases with this particular user ID and this IP address range, and the authentication method is MD5. So this is how this, so this is very important file, because every time you try to make some changes, you create a new user, you create a new role, and it is trying to connect from a particular IP address, then you need to mention those details over here. And so PostgreSQL.conf and pg_hba.conf, they go hand by hand. So the first file which you need, if it is your first time, the PostgreSQL.conf, you change it from localhost to the IP address of the server, or replace it with a star if it is 9 or the older versions. And then you work on hba.conf file, wherein you need to mention all the details related to the remote environment, role, which databases, and the IP address. I hope this is more than enough, and in another tutorial you can see more about PostgreSQL.conf. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to enable remote access to Postgre server. So I have listed all the steps in a notepad, and we are going to walk through that followed by a demo. So when you install a PostgreSQL, so by default connection to the Postgre are 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 not enabled. So if you try to access the Postgre SQL server from remote server, you will not be able to access. You will get the message that PSQL could not connect to server connection refused. This is because this is the behavior by default. So if you have to enable the connection to the remote server, you need to make some changes, and in this demo we will see how to make those changes. So in this demo setup we have two server. One is 192.168.1.61, which is my server where Postgre service is running, and the Postgre 12 is running over there. And we have a client with the IP address 1.71. From the client side, we will try to access the Postgre. So let me show you the setup which we have. So this is mobile Xterm. So I'm logged in to mobile Xterm to both the IP addresses. One is 192.168.1.61 and another is 71. So what we are going to do is, in the first step, let us check the status of the service which is running as of now. So we'll say systemctl is status PostgreSQL 12. So you can see that a status is running, and if I have to log into the server, I'll just say sudo su hyphen postgre, and we'll just say PSQL. So this will take me to the prompt on to the local server. So if I say /l, this will list down all the database. So there is a database with the name node 61. So what we will do in this demo is we will try to access all the databases from the remote server. From the remote client. So the client IP address is 192.168.1.71. So how do we connect from the remote server is using PSQL-U. Username is the Postgre -h is, and the host name of the server where Postgre service is running. So we will run this command from the client side. So let me run this. So PSQL-U Postgre-h and the server where Postgre service is running. You can see that could not connect to the server, connection refused. But if I try to ping, this is pingable. The port is open, so everything is fine with that. But there are some settings which are not enabled, so we are not able to access it. So what we will do in this demo is we'll go through the steps. So there are 3 steps which we need to perform. In the first step, there is a file called as pg_hba.conf where we need to add the client authentication record. And once we open this file using the editor, I will be using VI editor, and this is the location in my case. And there is a section which is IPv4 local connections, and there I will mention host, all, and the IP address of the client /subnet and the authentication method. This is the first step which we will do on to the Postgre server. In the second step, we will add it Postgre SQL.conf, and we will search for a parameter called as listen_addresses. By default, this is mentioned as localhost. So only the connection from the localhost is allowed. When we have to enable the connection from the remote environment, we have to mention the IP address of the server itself. If you have more IP addresses assigned, so you have to mention all those. So whatever NIC card it is listening, you have to mention the IP address of that. Please make sure that you mention the IP address of the server, not the client. The client IP address is to be mentioned only on pg_hba.conf. In the third step, we'll restart the service. In the fourth step, we will access it using the command prompt. So let's go to the first step. In the first step, let's log into PSQL and say show data underscore directory, and we will find the location where this hba.conf file is located. So you can see I have navigated to that step, and then what we will do is we have to edit that file pg_hba.conf. I'm using the VI editor, and then what you have to do is scroll down till you find IPv4 connections. And here you mention the IP address of your client. So I'll be mentioning it as host all IP address of the client and authentication using MD5. So let me give some spacing. And you can mention like which client it is, or you can mention the list of the IP address or the conditions also, like which all are eligible to connect. So we have added the IP address of the client. Then in the next step, what we will do is we will edit Postgre SQL.conf file, and it is in the same location, data directory. And here what we will do is there is a parameter called as listen addresses, which is by default localhost. So you have to replace localhost with the IP address of the server. The IP address of the server where this is running is 192.168.1.61. The IP address of this server itself. Where I'm typing the command, this is the server only. Just save it. And in the third step, what we will do is we have made two changes. We have mentioned the details IP address of the client in hba.conf. And what in the second step, what we have done is we have edited the PostgreSQL.conf, and we have replaced uh, localhost with the IP address of the server. It is not the address of the client, it is address of the server itself. The service is restarted. It is running as expected. Now we will try to uh, fire this command on remote server. So it is psql-u postgre-h. There's prompting for the password. I have mentioned the password for the Postgre user as password only. So you can see that I'm able to log in. And if I say /l, I can see that it is connected to the remote server and a node 61 database we created, and it is available here now. Or we can try one more step. We can create one more database. So we'll say create a database test now. And this should be visible here, /l. So test now is visible from the remote server. So this is the way we access the Postgre from a remote server. So just to recap, um, we edited pg_hba.conf, and in IPv4 local connections, we mentioned the IP address of the client. And then in step 2, we edited PostgreSQL.conf, and we replaced localhost with the IP address of the server. And then in the third step, we started the Postgre service. And in the fourth step, we tested the remote connections. So this is how we access the Postgre remotely. I hope this is going to help. Stay tuned for another video. Thank you. E-MultiSkills video tutorial. In this video tutorial, we will learn how to install Postgre on Windows. So this is the list of steps which we will be performing on installing the PostgreSQL on Windows. First step is downloading the executable. Second, we will install the PostgreSQL from the binary or the executable that we have downloaded. And in the third step, we will access PostgreSQL using command prompt and pgadmin4. So let us start with the first step. So what we are going to do is we are going to download PostgreSQL. So in your browser, just search for download PostgreSQL, and you will see the first option, downloads hyphen PostgreSQL. Just click that, and we have to do it for Windows. So just click Windows, and then the first option, Windows Installer, Interactive Installer by Enterprise DB. So just download the installer. So here you can see that table which says the first one is PostgreSQL version, then which operating system it is, and that's it. So we are going to go with the latest version, which is 12.3. The other versions are 11.8, 10, 9, 9.5, 9.4, etc. 9.3 is not supported. So most of the time when we download the binary, or when we download some software, we get in touch with the application owner who instruct us like which version of PostgreSQL has to be installed. Since this is a demo environment, so I'm going with the latest version, which is 12.3. So just click, so you can see this download for Windows x86-64. Just click that, downloads, and the download will start. So I'm not going to do this because I've already downloaded the binary on my system. So I'm just going to start with the installation. So I have downloaded PostgreSQL 12, and we are going to install this on my system. So it is a Windows laptop, so we are going to install on that. The installation is very, very easy. There is nothing great like any other software which we install on Windows. It is like that only. So the tricky part will be when we are going to make some changes on it. So I'm waiting for the first screen to appear. So you can see that setup PostgreSQL, welcome to PostgreSQL setup wizard. So just say next. And the first screen which comes up, it says the installation directory, the location where all the data files will be located. So we'll go with the default location, which is C program files, PostgreSQL/12. Just say next. And there will be 4 options which will be installed by default. The first is PostgreSQL database server. We are going with that. The second is pgadmin4, which is a graphical tool for managing and accessing your Postgre SQL database and the server. Then we have something called as Stack Builder. If you download and install this, this will help you in installing additional tools, drivers, and applications. So this is good to have this. The fourth default option, which will be downloaded, is the command line tool, like your pg base backup, pg dump, or pg restore. So these will be installed by default. So let's go with all the default options. First is the database server, then pgadmin tool, which is a GUI tool. Then is a stack builder, which we should include in case we wanted to have something extra downloaded later on. So this is required. So command line tools, this will have all the command lines tools installed. So just go with the next. And please provide a password for database super user. So this you have to remember. This is the database user, which is Postgre, and this is a super user. So I'm just giving some password. Make sure that you remember this, because when after the installation for the first time when you access your database, you will need this password. Please select the port number. So by default, Postgre SQL works on 5432 port number. We'll go with the default locale, so this is fine. Just go next, and you can see that there are a lot of things like installation directory. By default, all the data files will be here, and C colon program files PostgreSQL 12. This is your installation directory, and data directory is also same. Database is on port 5432. It is listing on this port, and database super user is Postgre, and rest of and I think that that's more than sufficient. Just go with the next, and this is going to install Postgre on the system. This is going to take at least 20 minutes for that time being. I'm just going to pause this video. So once it is installed, I'll resume it, and then we will see how to access PostgreSQL database using command line and pgadmin 4. Welcome back. The installation has just finished. Now you can see the final screen which says completing the Postgre SQL setup wizard. So I'll just press finish as the installation is finished now. So this is the stack builder screen which will appear in case you wanted to add some more drivers or features, so you can use that. So just I'm saying cancel, and my installation is done. So now the next step is just go to your Windows screen and look for Postgre. So this was PostgreSQL 12, so we are here, and you need to look for SQL shell. Just click that, and you will see a screen which says server localhost. Yes, we wanted to log into the same host, so it will be localhost. Just press enter. Database is Postgre, which we wanted to log in. Port is 5432, the default one. Username is Postgre, that is fine. And now it will prompt for the password. This is the same password which you have feed in earlier. So just provide the password, and you are on to the Postgre SQL command prompt. So just say /l, and this will list down all the databases, or /du. This will list down all the databases, the roles which have been created. And now let's do one more thing. This is how do we access using the command prompt. In case you wanted to access it using the pgadmin 4, just go to PostgreSQL folder, and look for pgadmin 4. This is the GUI tool which is used to access your PostgreSQL. The management is very easy. Everything is there in the GUI mode, so it is good to have this handy. And so I have just clicked the pgadmin 4, and this is coming up. So this is management tool for PostgreSQL. And now you can see on the screen as a saying starting pgadmin 4 server. So this should come up any moment. So it is appearing in the browser, localhost colon 57414/browser, and let me reset the master password for pgadmin 4. So I've set in the password for pgadmin master, and now you will have to connect to the PostgreSQL 12, which is installed on your local system. So it is saying please enter the password for the user Postgre to connect to the server PostgreSQL 12. So just feed in the password and say OK. If everything is fine, then it will connect. You can see that there are some things populated downwards. If you click the database, this will show that by default there is a Postgre database which is installed and owned by Postgre role. So this is created. And there are a lot of things in some other tutorial we will see how to use it, but this is how do we connect to Postgre SQL using command prompt and pgadmin GUI tool. So just a recap of what we have done. We have installed PostgreSQL on Windows. We downloaded the executable from Enterprise DB. We went with the latest version, which is 12. Then we installed using the PostgreSQL installer, and then we access the PostgreSQL using the command prompt and pgadmin 4. Just you need to remember that the Postgre password which you have provided during the installation, that you need to remember so that you can connect using the command prompt and pgadmin 4. So this is the basic of how do we install it on Windows, but there are a lot of things apart from this. So in some other tutorial, we'll see how to work on those. For now, it is bye from me, and see you in the next tutorial. I hope this is going to help, and thanks for watching this. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to move data directory on Postgres in Linux 7.5. So these are the list of steps which we will be performing on a Postgres 12 database which is installed on Linux 7.5. So first of all, let's understand what is Postgres data directory in Postgres 12, which is installed on a Linux environment. So all the data files related to the Postgres instance is stored in a location which is known as a data directory. And over a period of time, the storage allocated to that gets exhausted, and either you need to extend the storage or you need to move the data files or all the files which are related to the database to a new location. So in this demo, what we are going to do is we are going to move all the data files to a new location. So the setup which I have is having the OS 7.5. I do have the access of root and Postgres OS user. The Postgres instance which is installed is 12. So I have already logged into to the instance to the server using the MoveXterm, which is a GUI tool. You can store the IP address, user ID, and password. You just click and you will be able to log in. So I have already logged in with two terminals, one with root and another with Postgres. So let me walk you through the steps which we are going to perform. In the first step, we will log into PostgreSQL like sudo-u postgres psql, and we will check show data directory. That will show us the current location. As of now, the current location is the default location, which is /var-lib pgsql/12/data. So in this demo, we are going to move all the data files which are located on this current or default location to a new location, which is postgres/data. So in the first step, we will identify the existing location and the new location. In second step, we will shut down the services using systemctl stop Postgres 12. In the third step, we will prepare a new file system. I'll change the ownership of the new file system, which is Postgres/12 to Postgres: and the ownership will be given 750. And we will navigate to the existing data file location and copy everything to new location. In the step number 4, we will update the configuration file. We will added the PostgreSQL.conf, which is located as /var live pgsql/12/data PostgreSQL.conf, and we will update data directory location with new location, which is /postgres/data. In the step number 5, we will start the Postgres, and step number 6, we will verify that the new location is updated or not. So let's start with the step number 1. In the step number 1, we are going to log in as a Postgres user. So I'm logged in as root, so let me say sudo -u Postgres PSQL. So I'm logged into Postgres command prompt. Now here you have to type show data underscore directory. So this will display the current location of the data directory. So this is the current location, and this is the same location which exists when you install the new version of PGSQL PostgreSQL. This is the default location, so this has not been updated. So we are going to change this location to a new location. In the step number 2, we will check the status of Postgres. Let me log in. So you can see on this terminal I'm logged in as Postgres. So you just need to say sudo systemctl status Postgres 12. So you can see that the status is running. What you need to do is you need to stop the service using sudo. I'm assuming we don't have the root access, although I have shown the first step as root. In the second step, what we will say is stop the service. Sudo systemctl stop system Postgres 12. Check the status once again. The status is inactive. It has been shut down. In the third step, what we will do is we will give the ownership on new file system. So let me quit out of this, and I'm logged in as root. So these should be done in advance. So what I'm going to do is I'm going to change the ownership of Postgres/data to Postgres: and the permission which we will be giving it to is logged in as Postgres. We will change the permission as chmod -r 750 Postgres/data. So let me see if there is any data, because I have done this demo earlier. So I need to make sure there is nothing. Yeah, so there is nothing in that. In the third step, we have verified the new location. We changed the permissions accordingly. Now we will navigate to the old location, or the existing location, which is var live pgsql/12/data, and we will copy everything from this location to Postgres/data. So we'll say cp -r star Postgres/data. So this is very small, so it is copied immediately. Let's navigate to Postgres/data and say ls-lrt. So you can see that the files are copied to the new location. Now in the step number 4, what we have to do is we will take a backup of Postgres configuration file, which is located at var live pgsql12/data postgres_sql.conf. So let's take a backup of the configuration file. We have taken a backup. Now add it the postgres_sql.conf. So you can see we are inside the Postgres configuration file, and what I need to do is I need to update the data directory with the new location. So just uncomment and give the new location. In our case, it is Postgres/data. So I have already added that, and you just need to uncomment and save it. This is saved. And in the next step, what we are going to do is we are going to start the Postgres service. Just start the Postgres service. And one more thing, you need to make sure that you can check the alert in case there is any issue. So just tail-10f/var log messages. So this will show if the system has come up perfectly or not. So it is saying started PostgreSQL 12 database server. Check the status as well. So it will say sudo systemctl status Postgres 12. You can see that the status is active and running. So this is perfectly fine. And the last step is we will log in to Postgres command, and we'll say sudo-u Postgres PSQL, and we are on the command prompt. And here you just say show data directory, and you are done. So our new location is updated Postgres. So now onwards, whatever data comes into the database, it will go to Postgres/data. So we have successfully moved our data from existing location to new location. So what you can do, you can leave it as it for some time and delete the unwanted data later on. But it is a very small amount of data, so we can leave it like this. Just to recap, what we have done is we checked the current location of data directory, then we stopped the PostgreSQL, then in the step 3 we moved all the content from existing to new location. In the 4th step, we updated the configuration file. In 5th step, we started the PostgreSQL, and the 6th step we checked the new location, and it was done properly. I hope this is going to help, and stay tuned for next tutorial. Thanks for watching this. In this session, we will learn how to stop and start Postgre services or Postgre server on Windows system. So we'll directly start with the demo, which is very easy. And here we go. So I have listed all the steps on a text pad. So there are two ways we can stop and start the Postgre services or the server on Windows. Both of them are very easy. The first one is using the pg_ctl, and the other one is using the Windows services. So in the first way, when we say pg_ctl, the first thing which you check is you check the data directory location. So you log into PSQL command prompt, and then you say show data directory, or you simply say select settings from pg_settings, where name is equal to data_directory. In our case, the location is at this place. C drive program files PostgreSQL 13/data. So once you find this, you have to execute pgctl utility. So you say pgctl_d, which stands for data directory. You mention the complete location of the data directory. Then you say either stop or start. So let's go with the both the way. So I have logged into two command prompt, so they are open. The first one, what we are going to do is we are going to log in as PSQL. Just wanted to see if it is working fine or not. I'll say /l, it will list down all the databases. Now if we say show data_directory, show data_directory, this should show you the location of the data directory. So there's data directory location. There are a couple more methods you can find, but let's stick with this. Then what we will do is we will execute the pgctl command. So we will go with the pgctl-d C drive program files and either use say let's say status. It is saying server is running, and you can confirm from here as well that I'm able to log into the database and we are able to see the databases, or we have just queried the location of the data directory. Now, the next thing which we are going on to the left one is we'll say pgctl -d complete location of the data directory, and then we will say stop. We wanted to stop it. The server is stopped. Now, if we say /l connecting to PGSQL, this should show some error. Yes, it is showing the connection to the server was lost, and that is fine. We'll quit out of this, and then we will try to start it. So the way to start it is simply same. We'll say pgctl -d complete location of the data directory, and then start. Server started. You can check the status, so that should show you the status, and server is running. Now let's try to connect using pgsql-u Postgre and fill in the password. If everything is fine, you will be able to log in. Yes, you're able to log in. You can list down the databases, so everything is fine. This is how we do stop and start. You can do the reload as well if it is required, if it doesn't require the bounce of the database. The other way to do is you can use Windows services. So press Windows sign and R, go to run, just say services.msc. This will open services.msc, and you will be able to see the Windows services, something like this. So you can see PostgreSQL -64 -13. So this is Postgre 13, and it is in the running status. You simply there seems to be some issue with this. PostgreSQL, right? Yeah, we just stopped it. Let's start. Oops, there seems to be some issue. Okay, I think I have two. So I'll try to do it separately, but as of now, let's stick to this one, wherein we say that's you use the pgctl, and you will be able to see the status. Okay, this is not running. Just say start, and this should be started. Still running. I think the refresh was not proper, so it was not showing the correct details. Sometimes it takes longer than what is required. You can check the log files for more details. But this should be fine anytime. Did not start in time. Let's start it again. It just take a couple of seconds only. You can cross-check. Oh, system is shutting down. Examine the log output. Let's try to start it once again. You can go to the logs also to find more details. Server started. You can try this one, and this will show you over here. Yes, you are able to log in. Yeah, sometimes it is my system problem. As of now, everything is okay. You can go to services.msc also and PostgreSQL, and once either you stop it or start whatever service you wanted to do, you can do it. I hope it is going to be helpful, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a user role and a group in PostgreSQL. So the agenda of this tutorial is what is a user or a role in Postgre, what is public schema, what is a search path, and how do we revoke public from a role, how do we create a read-only role or read-write role, and how do we create a role, and then how do we grant privileges to the user which is created. The first one is the users and roles. So what is a user and role in Postgre? When we say create user in Postgre, that means it is equivalent to create role plus login permission. That means the only difference between user and the role is user is able to log in, but the role will not be able to log in. And the role has its own advantage. So if I say a SQL statement to create the PostgreSQL user, so I'll just say create user, username, then with password, and I'll give the password. If I have to create the same user with the create role SQL statement, I'll say create role, role name, and the only additional thing which I have to add is with login, and then we need to give the password, and that's it. So in Postgre, create user is equal to create role plus login permissions. So by default, all the new users and roles, they inherit the permission from the public role, and we'll see how it plays an important role. So what is a public schema and public role? So whenever you create a new database, let's say you created a new database, DB1, then by default, when you check the schemas which are available in that particular database, so you will see a schema with the name public. That means a user who has access to this particular database will be able to select or create the objects in that particular schema. So it is by default, the design is like that. So all the new users and roles, they have the default access to the public role, and they can create the objects in the public schema, which is not good. Then what is the search path? If I'm connected to a database, let's say, which is called as DVD rental, and if I say select a star from actor, actor is one of the table, and if I don't give the fully qualified name, then how Postgre will come to know like from which schema it has to pick the information. So that information is mentioned in something which is called as a parameter search path. If you log into Postgre prompt and say search path, show search path, it will show you two values. One is $user, another is public. Let's say if I'm connected to Postgre user on Postgre server, then by default, when you fire any query, it will search for a schema which is equivalent to the name of the user which is logged in. Let's say then it will look for that particular user. So by default, a schema with the same name will not be present. What is present is a public schema. So any user who is connected to that particular database will be able to see the objects or create the objects in the public schema. So as I mentioned, a DVD rental database, if I am just saying select a star from actor, then it will search, and I'm logged in through the Postgre. So it will try to look for the schema, which is equivalent to the database username, which is not the case. So it will look the information in public schema. So instead of saying select a star from public dot dot actor, I'll simply say select star from actor. So it is going to search from the public. If you have a schema with the name, let's say Postgre, and your object is lying over there, then it will look into that and it will display the result. This value can be changed. You can change the schema name so that by default it will look into this. So that's the importance of the search path. And it plays a very important role. What you should do about the public schema, you should revoke any creation of object onto the public schema, because if a number of users are using that particular database, and then it may be a messy task. So you should remove the create on schema public from the public, and you should also revoke all on database from public so that anybody cannot use that particular one. How do we create a role? Create role is, it's very simple. It's, you say create role, role name, and to that particular role, what you can do is, let's say I have an application, I wanted to create a read-only a role for some of the tables. So I can create the role, then I can say grant connect on that particular database. So my database in this case is DVD rental, then I can give access to this particular role, and that particular role can use the app schema if I have created a schema with the name. So you can do a lot of things with the role, and finally this role can be granted to the application user or the user which you have created. Also, what we can do is we can grant any kind of, let's say, select, insert, update, delete, whatever you wanted to do. But as the name suggests, it is a read-only schema. So I'm just going to give select on all the tables, or a table like actor or film to that particular role. Or what also you can do is you can give all table access on that particular schema to that particular role. So you created a blank role, you gave it connect access to the particular database, then you said like you use particular schema, then you gave select access on a number of tables, and this way it is very, very useful. So you create a role, and then how do we create a database user? So you simply say create user, username, then with password and password name. And finally, you can grant the role to the user. So any user who is joining that application, so any user in that application group, you can grant the role. So it is very convenient. So any changes which is happening to the app underscore read only will be applicable to all the users. They will be impacted. Any table which is added or removed, the impact will be on the role, and the role is finally granted to the user. And now there is a demo which is following up. So this is the demo. So let me close this presentation. And this is the demo. I have listed all the steps in the notepad, and we'll perform this either on the, so I'm connected through MobiXRAM on my server, which is on a Linux server 192.168.1.61, and I'm connected through the Postgre user, which is having the sudo access on this. So what I'm going to do is, so what we saw earlier is um, we are going to create a user, and we'll see how it is different from the role. So we say create user is equal to create role plus the login permission. So I'm just going to create a user. Let's name it as create user app user one with password, which is equal to the password. Not a good practice, but this is a demo, so we are using this. This is the wrong password. The role is created. You can see the user is created, app user. So where is the app user one? So this is the app user one, and there is no attributes cannot log in. That means it is able to log in, and that is the only difference between user and the role. Roles cannot connect to the it's not able to log in, but uh, uh, user is able to do that. If I create a role, let's say app user role 1, and if I say with login, then it is equivalent to the create user statement. So that is what we discussed in the first slide. Create user is it's already existing. So let's create another one, app role 2. So if I say /du, you will be able to see app role 2, and it is able to log in. Next one is what is a public schema and public role. They just to showcase this, I'll log into the pgadmin GUI tool, and I'll connect to my database, which is on Linux environment, and I'll connect to the database, which is DVD rental. So here we go with the DVD rental. And what happens? Let me delete the role which I have created. Okay, so I have a database with the name DVD rental, and when I created it, it was a blank database. So whenever you create a database, you get a schema which is called as the name public. That means any user who is having the access on this particular database will be able to use public schema. That means any object which is created will go into this. Let's say if I say I'm connected through the Postgre user in DVD rental database, and if I say create table A, so that table will be created in public schema. So that's the way. If you wanted to use a specific schema for the particular user, you need to create using the create schema command. So we'll see right away how to use that. Search path. So I'm connected as Postgre user, and let's see how many databases we have. Let's go to DVD rental, and I'm switched on to the DVD rental database. If I say let me see the data tables we have. We have actor table, and it is there in the public schema. If I say select star from actor, or select count star from actor, I don't want to display the entire details onto the screen. I'll be able to get the details. But how Postgre is knowing, how the server is knowing from which schema it has to pick it up. So I'm connected to the DVD rental database, and there is only one schema, which is public schema. And there is something called as search path. If I say show search path, I'll be able to see two things. One is $user and another is public. So by default, if a user is connected, let's say my username is app user, then it will look for the schema whose name is equivalent to the user which is connected. If that is not present, it will look for the object in the public schema. So either I say select count star from actor, or if I give fully qualified name, which is schema name dot the table name, it will display the same item. So if I just wanted to omit using the schema name, I need to mention the value in search path, and that can be set. All right. What we will do is we will do a small demo. We will, as a best practice, we will revoke privileges from the public role. So let's do that. So we'll say revoke create on schema public from public, and revoke all on database DVD rental from. Just in this demo, what we are doing is we are using DVD rental as the database. I'll go to the PG admin, and we will do it over there. So let me connect to DVD rental. Then I say query tool, so it will open a query editor, and we will execute all the statements from there. All right. So what I'm saying is we will revoke creator. So by default, nobody will be able to use that schema. And on all the database DVD rental, so that will also be revoked. So just execute this, either F5 or execute. Both will work. Okay. This is done. Now what we are going to do is we are going to create a role which is app read only. Then create role name. Then we are going to say uh, it is going to connect to the database DVD rental. Then we are going to create a schema, app schema. Then we are saying just use that particular schema, and then we are going to select all tables in that particular schema, and that will be granted to that particular role. Let us create this particular role. We use the command prompt or the GUI tool, but it is good to watch it over here. So create role, then connect privilege, then create a schema, then grant usage on the schema, and then all the tables in that particular schema will be given the select access to that particular role, and that's it. Role already exists, so let me drop the role. So let's drop it, and then we'll execute it. Okay, so there are, let me change it instead of, so we'll say, we'll create a new role, which is app read and only underscore one. We'll say replace all, and we are going to use this. And we are using PG admin 4. I'm just clearing the screen, and we are creating a new role. It's very, very easy. There is nothing tricky in this. So it is displaying the last message. So this is completed. Now we are going to create a read write role. Here what we are saying is in read only role we gave only the select access. Here what we are going to say, we are going to give insert update delete on all the tables in that particular schema. So let's create role read write. Let me see if that role is available or it is not. Okay. So read write. Okay, it is not. So let's execute this. So we are going to create a role read write, then it is giving the connect access on DVD rental. Then we are going to create a schema, app schema, which is already created. And you can use the name according to your requirement, and we'll execute all this statement. Read write already exists, so let me create, instead of read write, we'll say app underscore read write 1. Let's create the role. It's very, very easy. It is done. The next one is we'll create a user which is called as app reporting user 1. We'll give some password. Then we will create another user app reporting 2. Then um, then what we are going to do is we are going to grant the privileges. So this we have seen earlier also. There is nothing special. It is just the user and the role. The only difference is they have login access. This is done. And finally, the roles which we have created can be assigned to the user. So we had app read only, and we have app read write one. So let's grant all this. So this object level things are very useful when you work for the application team and you have to grant some kind of access on the tables or a schema to the roles, and that role has to be assigned to the user. So just to recap what we have done, we have seen what is a user. User is nothing, just a create role plus login permission. Then we saw what is public schema. Public schema is something which is available by default in our database, which is newly created, and the user has the access on that, which is connected to that particular database, and then they can create the objects into that. That is not a good practice to have that in place, but it is by design, so you should remove the access over there. Then we saw something as search path. If you say show search path, it will show you two value $user, comma public. That means a user which is connected to a particular database by default. It will look into the schema with the same name as the user connected. If that is not available, it will search for the objects, or it will create the objects which is there in the public schema. So instead of saying select star from table, uh, or instead of giving the fully qualified name, select star from schema.table, you simply say select star from table. Then it will check this criteria, and if it is validated, it will display the results. Then we saw how to create the user. Then we created a role, read-only role. Then we created a read-write role, and then we created two users, and then we assigned the roles to the user. I hope this is going to work, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn about Postgre cluster. So okay, so what is a Postgre cluster? So when we say cluster, it means n number of nodes which are connected together and they are serving as one unit, or multiple database instance which are connected together and called as a cluster. But this is not that cluster in PostgreSQL. When we say Postgre cluster, it means it is a collection of databases which are managed by a single Postgre instance. So that instance will have its own background process, and it will have its own PG data. So what are the different components of the term cluster in Postgres? So we have something called as data directory. So let's say when you install Postgre on Linux system, or on let's say Windows system, there is something called as data directory, wherein all the files which is related to the database, tables, and other logical entities are created, and they are specific to that particular instance. By default, we create only one instance if there is no need to create another instance. So that data directory is being managed by the Postgre processes. So it manages all the data directory files and interfaces of those contents. So when we say cluster, it means two things: combination of data directory and Postgre process. What is the use of having one more cluster when you already have one instance? So you can say it as it is a temporary database which you can create outside of the existing instance. You can make any changes in the new PG data directory, let's say PostgreSQL.conf or pg_hba.conf file, and that is separate from the default instance which you have installed. Or there is another purpose. You can have a different version of the Postgre at the same time. So you create one more instance, you test the environment, or you can have multiple versions, or you can create the database in the new instance, or in layman language we'll say having one more instance with its own data and the background process. So how can we create a new instance? So to create a new instance, you have to create a new data directory for the cluster. So you log into your existing cluster. Let's say in my case, it is a Linux system. So I'll say sudo su hyphen Postgre. You can check the current location of PG data, create a new location, and then you initialize that particular location using initdb and the new data directory location. Once the instance is instantiated, you have to configure the cluster. By default, in the existing cluster, you will have the port 5432 active. So you cannot use the same port for the new instance. So you have to change the port to a new number. So instead of 5432, let's say I'm going to use 5433 or any other. I need to change the Unix socket directory from existing. The current one will be your var run PostgreSQL, and let's say create a new location, and your Unix socket, which is required for connection from the same host, that will be used. Then you start the Postgre server once the initialization, and you have changed the parameter port and Unix socket underscore directory in PostgreSQL.conf. You initialize it using pgctl-d, give the location of new data directory, and log file, that is optional, or you just say start. Then you can check whether your new instance has come up with the new processes or not using ps-xf. So that will show you the tree structure with the postmaster at the base and other processes following that. Then once your new instance is instantiated, you can connect to that using psql-h localhost, new port, and the super user, which is Postgre. If you have to stop it, you just say pgctl-d, the location of the data directory, and if you have to give the log file name, you give it, then stop. If you have to reload, if let's say you have done some changes, which then you have to reload it, just say pgctl-d, the location of new directory, and reload. So it's very simple. Pgctl location of new directory, either you say start, stop, or reload. Then we are going to perform a demo on a Linux environment. So let me take you through that. So I've listed all the steps. So I have a IP address 192. So the IP address of my host is 192.168.1.61. Operating system is 7.5 Linux, and Postgre, which is already installed with one instance, is Postgre 12. So we are going to log into that. So this is I'm logged in as root. So let's say the first step, let's say just switch the user to Postgre. So now I'm logged in as Postgre. Now just say for the existing setup, just say where is my existing data files. So echo pg data. Just go to this location and you will see these many files. And it has its own background processes as well. So you can just say psxf. So this is my current setup with one instance. So you can see postmaster is there, then these are the rest of the background processes. Now what we are going to do, we are going to create a new cluster with the new location of the data file. So what I'm going to do is I'm going to create a new file uh, wherein wherein we will keep all the data files. So let's create it in this location. Let me log in as root, and we will say mkdir, and we will create a data directory instance 2. I think I sudo su space minus postgre. This data directory is already owned by postgre user ls-ld, and let's say check the permission. So it is already owned by Postgre. Let's create this directory instance 2, wherein we are going to keep our data files. So this is created, and along with that, what we will do to keep the what do you say um, the the socket file, we will keep will create one location. So we'll create one location like um, mkdir-p home instance 2. Just give the ownership to Postgre to this particular file wherein the socket file can be created. So we have done that. Now let's start the first thing which we will do is we have created the directory, then we will say initialize db and the directory location, and everything we are going to do as Postgre user. So initdb and the new data directory location. So you can see the file belonging to this database will be owned by the user. Postgre database cluster is getting created. The user will also own the server processes and fixing permission on existing directory, creating subdirectory. So it is going to create all the files which were there in the existing cluster. Now it is saying if you have to start the cluster, you have to use postgre-d or pgctl-d command, directory location and the log file name, and followed by either start, stop or reload. That three things you have it. Now let's create the Postgre cluster. Configuring that means we have to change the two entries. One is the port number and another is the socket directory location. So we'll say vi slash postgresql.conf, and we have to change two parameters. One is the port, because we cannot use the same port. This is already in used by the existing instance. So let's change it to 54333, and we will give the Unix socket directory as the new directory wherein the socket file will be created, and this was /home/ uh, and we created with the name /home instance 2. So let's put this. We have done this. Now we have to restart. First of all, we have to start the instance for the first time. So we'll say starting Postgre server. So we'll say pgctl-d and followed by the directory location, then log file, that's optional, and you can say just start. So starting, so this will start within a couple of seconds, and we will check using ps space xf. So if you execute this, you will see one is with my new location, new data directory. So this is my new data directory, and this was the old data directory. So these set of background processes for old instance, and this is for my new instance. So we have created one more instance. Now how to connect with that? So we will say psql-h localhost-p, port number is 5433, and the user is Postgre. Just execute this, and we are logged in to the new instance. Just quit out of this, and we will see one more command, how to stop the server. To stop the server, everything remains same. You just have to replace your so we'll say pgctl-d directory location where all the data files are there, then -l log file name if you want to give, then stop. Just say stop, and it is going to you can see that server is stopped. If you say ps if you try to connect to new instance, it is showing that there is some problem. The problem is it has been down. And if you just say psxf, it will show you that the background processes are obviously down for new instance. This is the old instance. And in case you have to start it again, just say start bgctl-d directory location and start. You start it, it is starting. And then finally, if you have to reload, uh, you made some changes, and if you have to reload it, then just say pgctl-d directory name -l log name, then reload. So signaled, and it is done. You can see our background processes for new Postgre is available now. So this is how we create a new instance. So just a recap, we create a new directory where the data file will go. The data file will go to this location. Then you just say initdb and the new location. Then you modify port number and Unix socket directory. Then you start the instance using pgctl-d directory location, and then you have to check the process has came up or not, psxf. Then you can try to log in psql-h localhost-p port number and the username. And this is how we create a new instance on Postgre. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PostgreSQL schema. So in this slide, we will learn what is Postgre schema. So if you have already installed Postgre SQL software either on Linux or Windows system, you will know that by default, there will be one instance. If you wanted to have more than one instance, you can do that. So at the top label, you have instance, and in the instance, you have databases. So you can say that a PostgreSQL database cluster contains one or more named databases. And in turn, a database can have one or more objects which are called as schemas. What is a schema? Schemas in turn can have tables or different types of objects, or it is just a container which can have different types of objects in it. So if I say in a particular database, if I am connected to, I can create multiple schema. Let's say I create a schema 1, I can create a schema 2, or n number of schemas I can contain. So what will happen have over there? Let's say I have created a table which is called as actor in schema 1, and another table with the same name in another schema. So let's say the name is again actor in schema, so schema 2. So two schemas with with different name, schema 1 and schema 2, but same table name, which is actor. So it is good to organize the tables in different schemas. And so if you talk about a schema, is it synonymous to anything? So it is something like directory or folder at the operating system level. There is nothing more than that. In that folder, there will be different objects like tables or views, or what do you say, the functions, etc. So this is a brief introduction of a schema. Schema is nothing, just a logical container which can have different tables and data types. So why do we need to use a schema? Is it something new? So no, it is not something new. So a schema allows you to organize database objects. Let's say I have a database with the name DVD rental, and if I have two schemas, let's say schema 1 and schema 2, and I have a one table which is known as actor. If I wanted to access it through two different schemas, I can do that. So it is easier to organize the objects in the schema. And if I wanted to take a backup of the particular schema, if I have to restore it, then it is very easy to do that. And organization in particular schema will be easier. What I can do is I can restrict the user to work onto a particular schema, and I can say you don't have access on other schema. So it is good to have schemas in place. It is something like mandatory. You should use it. There is something called as public schema when we talk about Postgre. Public doesn't mean that it is available for entire public or all the users which are connected to the database. Sorry, I mean to the mean to the instance. So when you create a database in Postgre, by default there will be a schema, which is the only schema present, which is known as public. That means if you have not created any user-defined schema, then all the objects which you create will be there in the public schema. So any uh, role which has access to the database, or user which has access to the database, can create the table in public schema. And public schema is available by default in all the databases which you create, and that is the only schema which is available. So there is something called as search path. What happens if I say, if I'm connected to uh, DVD rental, let's say my database name is DVD rental, and if I say select star from actor, so in which schema it is going to look for? So there is something called as public schema. So by default, it is going to look into the public schema. If you say show search path, then it will search either in user dollar. There is something called as user dollar, and the other one is public. So if the schema name is equal to the username, then the uh, s- object will be searched in that particular schema. If not, then it will be searched in the public schema. So what is the building block of Postgre? So we have a PostgreSQL cluster. That means there will be one set of software. Let's say Postgre 12 I have installed. So by default, there will be one instance. If I wanted to create another instance, then I can do that. So each instance in Postgre will have its own set of background processes plus memory area, and in each instance you can create different databases, and each database will have the container which is called as schema, and schema can contain different types of objects. So this is the hierarchy. So you have Postgre instance or the cluster, you have inside the cluster or instance you have databases, inside databases you have schemas, under schemas you have objects. It is just like folders. That's it. So let's come back to the demo. So I'll show you I'm already connected to uh, pgadmin 4. This is the IP address of my server 192.168.1.61. I have 6 databases. I'm going to use DVD rental. So if you uh, click this, you will be able to see different options. And by default, there is one schema which is with the name public. It doesn't mean that it is available for the entire users. No, it is not like that. So by default, when you create or select the object, it comes from the public schema. So what we will do is, um, so as of now, there is only one schema. Let's create 2 more schemas. I'll create 2 schema with the name schema 1 and other again with the same schema 2 name. Schema 2. Okay, and what I'm going to do is now um, either you can use the command prompt or pgadmin4 and let's do, okay, I'm already connected over here. So I created 2 schema, schema 1 and schema 2, and in my public schema there is a table called as actor. So if I simply fire one statement like select star from actor, okay, let me do one thing. This is my command prompt of 192.168.1.61. So I'm connected as mobile xterm. So what I will do is I'm connected as Postgres user. So I just say PSQL. I'm connected to Postgre prompt. So if I say uh, switch to database, the databases which I have is these many. So I wanted to connect to DVD rental. I'm connected to DVD rental. And if I say select star from actor, so I'll be able to see the data, right? So this is my actor table, which is available in public schema, and I have created 2 more schema, schema 1 and schema 2. So what I'm going to do is I'm going to create the structure in these 2 schemas for our demo. By default, I click this icon. So okay, let's go to the query editor. I'll go to schema 1. Uh, expand this. You can see the public schema. Just go to schema 1 and say um, query tool, and I will create a blank table with the name actor. Just execute this. So this is a blank table. All right. Create another table in the schema 2. Let's create that as well. All right. So if I have to select the data from individual tables, so what I will have to do is I will say, if I say select star from actor, by default it comes from the it comes from your public schema. And if I have to say the specific schema, I have to say schema 1 dot actor. So I'll say select star from schema 1 dot actor. So you can see that we created just a blank table and there is no row. And similarly, we did it for the schema 2 also. If I say schema 2 dot actor, so it is coming as again blank. There is no data because we created the structure only. And if I say select a star from actor, it it displays the data from public schema with the table actor. So how this all is happening, we will see. And if you wanted to drop a schema, just say drop schema name, and if there is any object, you will have to say drop schema name and cascade. There is something called as schema search path. So when I'm saying select star from actor or select star from schema1 dot actor, how it is actually doing, or if I'm just saying select star from actor, is there any parameter which is deciding like from where it has to pick the information? So there is something called as search path. So if we go to PSQL and say show search path, it will show the two output. One is $user and another is public. That means the user which is connected. So by I'm connected through the Postgre user. So when I am going to create any object or select any object inside this particular user, by default it will look for Postgre user schema. If it is present, it is going to create object or select object from there. If that particular schema is not present, then it will go to public. So if I, oops, again I clicked this. So this is my DVD rental database. So I have three schemas. By default, I'm connected through the Postgre user. If if the schema is not present with that name, it will look for public. Why? Because that thing has been mentioned in search path. Either the schema should available with the username, or the second option is public. So if the first option is not available, it is going to look for the public schema. What if I wanted to say select star from actor and it picks the information from schema dot actor? So what we have to do is we have to tell to the instance, you go and look into schema 1. So we will have to change the settings. How do we do that? We can, if I say show search path, we have user public. So instead of user, by default, I wanted it to come from schema 1. So I have to set that. So we'll say set search path to schema 1, comma public. So that means it will first look for schema 1. If that is available, it is going to show the data from there. Let's verify it. Yes. And if I say select star from actor, so I have a blank table available in schema 1, so it should show that. So you can see that. And if I have to search from the public schema, I have to explicitly mention select star from public dot actor. So you can see that. So how everything is being controlled? Everything is being controlled through search path. And you have some schema and privileges as well. So by default, uh, users do not have access into the schemas which they do not own. That is true. You have to give the permission. So what is the usage pattern? You should issue revoke create on public schema from public. That means you should not allow any user to create or select the object from there. Selection is fine, that's not a problem. If you wanted them to create the object inside that, that should not be allowed. What if there are multiple users and they wanted to create the object with the same name? So it is going to be a problem. So what you should do is you should remove the public schema from default search path. So what we did right now is we changed it to from user dollar comma public to schema 1 comma public. So you should do similar for the application user, right? Remove the public schema from default search path by issuing alter role all set search path equal to. So it is a good practice to have the schema name with the same name so that they can create the objects over there. So the conclusion of this is you should not use the public schema. So just a recap of what we did is we learned what is a schema. Schema is just a kind of folder or container which contains objects which you can see in. Um, Sorry, I clicked again. So I have a database which. Oops. Where is the screen? Okay. So I have a database DVD rental. Inside DVD rental, I created by default there is one public schema, so everyone will be able to. So those who have access to this particular DVD rental database can select from public schema, and they will be able to create the objects over there. What you should do is you should create the named schema where in the application owner can create their objects, or they are the owner of this schema. And how to modify that, you should change the search path so that by default it doesn't go if that user dollar is not available. That means if the schema name which is not equal to the connected user is available, that will go to public. So you should remove that. In that way you can organize your objects better. And if you just right click on one of the schema, then you can see you can do a lot of things. You can create the script, you can backup, you can restore, you can grant the wizard, you can search objects. There are a lot of things you can do with that. So schema is a great object in your Postgre, and you should use it wisely. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgre table space. So this is an introduction to the Postgre table space. So if we say in the layman language, we'll say table space is a space or a storage location where all the tables or objects occupying the storage are stored. So what is table space? So it is a location on the disk, whether we are talking about the file system on the Linux or drive on Windows system. So this is the location where Postgre stores data files, and how Postgre is letting the instance know where it has to store the file, that is referred in the table space. So what table space actually does, it map a logical name to a physical location on the disk. So in the demo, we will see the logical name and where does it corresponds to. So you would already be knowing that there is something called as $PG data, which denotes to the data directory location in Postgre, where by default all the data files or objects occupying the storage are stored. So when we talk about the table spaces are nothing. They are just a logical name which corresponds to a physical location on the disk. Let's say you have installed your Postgre instance on the on database in Windows system. Then in your C drive at a particular location, you will have the data files located. So by default, there are two kinds of table spaces mentioned in Postgre. One is known as the PG default, which stores all the user's data will be stored over there, and PG underscore global, where all the global data is stored. So when an instance is created, you have two table spaces. One is PG default and another is PG global. Default means the one where user data is stored, and global means where all the global data is stored. So it's good to ask, what is the advantage of using table spaces? Let's say I wanted to create a new table space. So does it mean something? So by default Linux, the data files are located in slash var lib postgre. Let's say the version is 12 and slash data at this particular location. But the storage in slash var, which is the default location data directory, is not unlimited. And if you wanted to create a new file system, if you are unable to create extend this storage, and if you wanted to use a new file system, and in that case you have to create a new table space, and you have to point that particular location to the new file system or drive. Or there may be a possibility that you have high performing storage and you create a new table space and you put your high performing objects which requires the high performance in that table space, and it is good for the performance of PostgreSQL instance. So what is the default storage in PostgreSQL? So when you install your Postgre, let's say on RHEL or Windows. So in Windows, everything will be done automatically by the run installer. But in Linux system, when you install the binary, then it asks you to initialize the database. So you initialize the database using pg underscore ctl hyphen d, the data directory location if it is non-default, and initdb. So you start the instance following the initialization. And what happens during this course of action, there is a location which is created, which is called $pg data, wherein all the data or data files related to PostgreSQL is stored. So by default, there are two table spaces which are created when you install a new instance. One is pg underscore global, which refers to the global system catalog uh, catalog files, or what do you say, uh, the shared system catalogs. Or there is something called as pg underscore default, where your user data is created. So we are more interested in pg underscore default because your user data will be stored over here. And how do we create a new table space? For creating a new table space, you will have to log in into Postgre command prompt and just say create table space name, location, and this is the physical location on your Linux system or your Windows system. And on the Postgre prompt, if you say slash db plus, so this will show you all the table spaces available. So how do we create the object in a new table space? So you simply say, let's create a new database, create database db1. And if you don't want to mention the default table space, and if you mention a new table space which you have created, you simply say create database name, which is more than sufficient. And if you wanted to have these database created in a new table space, you just say table space and table space name. So you switch to the new database, and then any table which you create inside that database will be automatically created in the new table space. That means it will go to the new file system or the location which you have mentioned. Otherwise, what you can do when you create the tables using create table command, you can mention the table space name. So either you say table space, new table space, or table space, the existing table space, which is pg underscore default. So it works this way. So now we'll see the demo, how it works. So we will initialize instance, and once the initialization is done, we will check what is pg data, which we have already discussed in the previous tutorial. And then we will see what is postgre table space, what is the default table space, and then we will see the location of the default table space. We will create a new table space, the objects in the new table space, then we'll move objects from one table space to another, and then we will see on the instance label how to change the default table space. So this is what we are going to do on Postgre demo. So this is the list of steps which we are going to perform. And let me close the PowerPoint presentation. And this is my Linux box. I'm already logged in as MOBA Xterm tool. So I'll just say sudo su hyphen Postgre. Sorry. Let's clear the screen. And what we are going to do is either you create a new instance or you initialize the existing one. So we are going to initialize the existing one. We will say pgctl hyphen d data init dv. So let's do this. So, okay, let me do one thing. Let me stop the instance, or let's create a new instance. I'll just say mkdir-p and create this location. And then let's instantiate it. pgctl-d, the directory location, so that a new instance is created in a particular data directory, and initdb. Oops. It is also not empty. Let's create another one. Let's say 2. Create this directory. Done. Then start do the initialization. This is also existing, so let me see what all I have done. Instance 1, instance 2 is also available. Let's create instance 3. mkdir and then initialize the database. You can see that fixing permission on existing directory. This is data directory. So this is how you create a new instance. So let's initiate or start this particular instance. This is starting. This is how do you start the instance. So what I will do is I'm not going to use this. This is just how do you create a new instance. I'm going to the existing one, sudo systemctl status PostgreSQL -12, and you can see there is something called as PG data for the default instance. So I'll go to cd $PG data. If I say ls-lrt, you can see n number of files are over here. And then what I'm going to do is inside, if you see the content of the files or the folders or the subdirectories under this, you will be able to see these many number of files in PG data, right? So by default, when you create the objects, where does it go? It goes into PG data. So this will go in this particular location. So over a period of time, this particular location will keep on occupying more and more storage as the user data is inserted, created, or it is done. So how it happens? So it happens due to what do you say, the table spaces. So let me log into um, to the browser using the uh, pgadmin4 tool. This is the IP address of my server 192.168.1.61. So just click it and you will be able to see something called as table spaces. So by default, these are the two table spaces which are created, pg underscore default. So you can see that I have a database DVD rental. So DVD rental will find the storage in pg underscore default, whether it is sequences, indexes, or there will be the tables also. So these are the tables. So you can see that these are existing in pg underscore default, and when you see the pg underscore global table space, you will see the catalog related tables or the indexes. And table space in actual uh, uh, corresponds to what you say as the pg data location. So PG data, PG underscore global table space is used for shared system catalogs, and PG underscore default is for default table space. So this is how it works. Let's create a new table space. I'll say TBS2 MKD. The first step which we have to do is we have to create a directory location or folder location in Windows. So mkdir-p, I have created that. Then what we have to do, we'll have to log in as pSQL, and then we have to fire the command. So by default, when you say /db plus, this shows you all the table spaces which are existing as of now. So I already have two more table spaces which I created in another demo. So these are the two table spaces which are created by default. And if the location is not mentioned, that means it is corresponding to PG data, which is the default data directory location. If you have changed the data directory location, it must show it over here. So the next step is we have to create a new table space. So the command is create table space name, and the physical location on the file system. So you can see there is a relationship between the location and the table space name. Table space created, just say /db plus, and this will show you the new table space which we have created. So this is the new table space tbs2, and this is corresponding to this physical location. So what we will do next is there is something called as pg underscore table space location. uh, pwd, I'm inside cd data. This is your default data directory, and there is something called as pg underscore table space. If you go inside that and say ls-ltr, this will show you a symbolic link. In our case, this is the object ID, OID, unique object ID for the new table space. The Whenever you create a new object in a new table space, it goes to Postgre /data/tbs2. So all the information is still there in pg data and in pg underscore table space. So it has created the link automatically. So now let's create the object. So we'll say create, we have already created the table space, uh, and now let's create a database. Create database db2 table space tbs2, which is already we have it. Oops, I entered the wrong password. All right, just say create database name and table space name. So that means this particular database will be created in new table space. So any object which is created inside this one will be automatically uh, created in new table space. So that's obvious. So let's switch to the new database, which is DB2. And now let's create the table. When we say create table, tab 1, so it is going to create that particular table in your new table space. Let's say create table tab 2, and if you mention the table space name, then also it is going to create in the new table space. Or if you wanted to mention the table space name, it will. So there is nothing great in this. You just mention where you wanted to create it. Let's say I wanted to create a new table space in default new table in default table space, so I can do that. So the problematic part is when you have to mention the table space name. So how can we do that? Can we move the objects from one table space to another? We can do that. Or can we alter the uh, change the table space from one to another? We can do all of that. So if I just say alter table all in table space, and we set it to default table space, it is possible. We can do that. But whenever you do all this operation, there will be a lock on the table and nobody will be able to use that. What if I wanted to utilize the new table space? So any new user who comes in wanted to use the new table space. So let's do a demo for that. So let's create a new location, mkdir-p postgre/data new table space 2, and we'll say the table space name is tbs2, and this is the location, and we are going to create a table in new table space. So this is this is the time taking process, right? We create a folder. This is an administrator part, so that has to be done without any you cannot skip this step. The second is when you create, you have to create the location. You have to create the table space with the new location. And if the application team wanted to create the table inside the new table space, they have to mention the table space name. So create table, table name, table space. But this is problematic. Let's create a new table because this table already exists. Oh, this is also existing. So it is create table, table name, table space, new table space name. Yes. So this is done. But it is always very problematic when you have to mention this. So can we do something so that the default table space is changed? So we can say set default table space to uh, the new table space name. So we can set this. Let's just say show default table space. So there is one default table space. And let's change the default table space to the one which we have just created. You can see the default table space is changed from pg underscore default to so any user now who is going to create the data, uh, either table indexes or anything, so it is going to find the storage in new location, which is this location, and which is corresponding to this particular table space. Since we have already mentioned it that default table space is this, so any object which is created will be created in this particular table space. So if I simply say uh, create table foo3, then it is going to create the table into new table space. And if you wanted to cross verify, what you can do is just refresh it. You will be able to see the new table space and the objects will be here. So still it is showing fetching dependent information from the server. So this is the foo 2 and the 3 which we have created. So this time we have created foo3. So by default it has gone to the new table space. So is there a way we can so the problem will be when you have to take the backup. So the command is already mentioned, pg underscore base backup, which we have already seen in previous tutorial. You just mentioned the format, and you have to mention the location of your new table space which you have, the additional table space which you have to create. So you have to just make a note of that. And finally, why is table space used for? So table space just used so when your database is growing, so you wanted to go to a new location, so you mention it using the new table space. Or it may be possible that you have a high IOPS or SSD disk which you wanted to use for your objects, so you create a new table space and move your all objects over there. So just a recap what we have done. We initialized an instance, and then we saw what is PG data. PG data is nothing but all the data in your instance goes to this particular location, which corresponds to the default table space. Default table space has two components. So by default, when an instance is created, you have two table spaces, pg underscore default, pg underscore global. Pg underscore default is a table space wherein user data is stored, and pg underscore global where global data is stored, which is related to the instance. And then we have seen what is the default table space location. Default table space location is pg data, and then we created a new table space. So you create a new physical location using mkdir, then you create the table space, then you mention the location, so it will be linked. Then you say /db plus, so this will show you the all the table spaces. And when you go to cd2 data and pg underscore table space, this will show you the symbolic link. That means all the information is still in pg data, pg underscore table space, and new location will be mentioned over there. And that is a kind of symbolic link. So you can see we created this particular tbs2. This is the unique object id, and this is the new location, and it is available in uh, pg data inside pg underscore table space directory. Then we created a new table space, and you can create the table ending with the table space name. Either it is pg underscore default or the new table spaces, or if you wanted to set the table space parameter at the instance level, you just say set default table space and table space name, so that the new objects which are created, they will be created inside the new table space. And how do we back up the additional table spaces? You can use pg underscore base backup. You provide the table space mapping, and that is it. And finally, why is table space used for? Uh, Table space is actually used when your database is growing and you wanted to go to a new location, new physical location on the server. And so you bind the logical name with the physical name. The logical name is your table space, and physical name is the location on the server. And there may be a scenario also wherein you wanted to keep the frequently accessed indexes or the tables into that particular high performing disk, and you create a new table space and you move all the objects over there. So this is all about the table spaces in general. So I think this is more than enough. I hope you have learned a lot about table spaces in Postgre, and see you in another video. And thanks for watching. And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to perform the routine maintenance task in PostgreSQL using pgadmin for graphical tool. So what is the requirement of doing the routine maintenance task in PostgreSQL or any other RDBMS? So uh, it is very, very important to perform the routine maintenance tasks so that whatever uh, uh, degeneration of the file system or fragmentation has happened on the table or index level or the file system label, that can be reclaimed. We will not be talking about the file system. We will talking about only the table and the index fragmentation and some of the other commands. So there are the certain tasks which we have to perform to attain the optimum performance in PostgreSQL. Some of them is here, like vacuuming. We have a separate tutorial, detailed tutorial on vacuuming. What is vacuuming? And vacuuming is nothing like whenever there is an update or delete in Postgre tables, the rows which has to be deleted or updated do not go out of the table. They remain there in that particular table as the dead tuples. And if there are too many updates or deletes, then the size of those dead tuples, dead rows, will keep on increasing. That leads to the uh, degeneration in the table performance, so that whenever any query is using those tables or the indexes where vacuuming has where dataples has happened, then it is going to degrade the performance of the query. So using the vacuum, what we do is we try to remove those dat tuples. If you are doing the standard vacuuming, what it will do, the dat tuples will be removed and it will be available as free storage in that particular table. When you do full vacuum, what it does, it creates a new table and it removes all the dead tuples from there. And there is another routine re-indexing. If the table has what do you say, the fragmented, and then it is surely going to depend the impact the index as well. So what do we do in database maintenance? We do the defragmentation of the tables or the indexes or the data files using some of the methods which is given by default in the pgadmin tool. And why those fragmentation happen? It is due to it is happening due to the insert or the delete operations on the tables, which is causing or leading to the dead tuples or bloating as well. So when we do the maintenance, it helps in reorganizing the table and the indexes and enhance the performance of the database. So we'll be talking about the four maintenance process. One is vacuum, wherein the data tuples will be removed from the table. If we are doing a standard vacuuming, then those data tuples will be available as free rows and they storage, and they can be used later on. When we say analyze, analyze is going to analyze the tables, and that will be used by the query optimizer so that it can pick up the latest uh, statistics of the table. When you say re-indexing, re-indexing is going to what do you say, create the new index wherein there will not be any fragmentation. And last is the clustering of the tables. So vacuum, we have already discussed like what is vacuuming. Then we have discussed about what is the use of analyze. Analyze, what it does, it tells the query planner to update the statistics, and it is going to generate a good plan when those tables are getting involved in the query. And how do you generate the statistics on those tables using the analyze command? It is one of the optional step in vacuum. By default, it is disabled, but you can enable it. Reindexing can be done to remove the fragmentation from the index. So we will see how to do that. And the last one in this is the demo. We'll see how to perform the demo. Let's and the and I'm logged into to pgadmin 4 GUI tool, and I have some of the database which I had imported. One of them is DVD rental. So what I'm going to do, just right click and say maintenance, and a window will be popping up, and you can see there are four things: vacuum, analyze, index, and cluster. Vacuum by default it is no, because when you say full, Full vacuuming, that means it is going to lock all the tables, it is going to freeze all the updates, and this that means you cannot do any kind of update on the table. And if you say analyze, you can do the analyze. So by default, full is no, freeze is no, analyze is no. And if you just say verbose, you can run this analyze vacuum command. Just say okay, and it will show you the progress. So more details, we will see how it is going to do. It's just a vacuum verbose command on the particular database. So it is a standard uh, vacuuming happening onto the database, but it is not going to log the tables, or it is not going to run the analyze command. If we have to do it, you can see that it is successfully completed. You just go and just say maintenance, and if you are sure that it is a complete downtime, you just say full vacuuming, and depending upon the size of the tables, it is going to take its own time. So you will have to do some kind of testing how long it is going to take. And if you wanted to analyze, which should be done if you believe that the table statistics have changed, then you need to, let's say, the insert or the update and the deletes have changed at least 10 or 20% of the data, and it is going to impact the performance of your database. Then you can run this. Just say okay, and you will see that maintenance job is created, and it will pop up. Yeah, so more detail. So what it is doing is vacuum full, freeze, verbose, and it is going to run this command. So in the first, we saw that vacuum verbose only. Now it is doing the full vacuum. It is freezing the tables also, and it is showing you the output as well. Successfully completed. Since it is a database which is just in KB, that's why it is taking lesser time. Going to maintenance again and just doing the analyze. If you just do analyze, it is going to analyze all the tables in this particular database. Just say okay, and you will be able to see what it is going to do. So the maintenance job is created. It will pop up. Just say more details, and it is saying analyze verbose. That means it is going to analyze all the tables which are there in this particular database. So if you see, the data tables over here are these. So it is going to analyze all these tables. So you can see here also analyzing public dot address, that is one of the table. And if you see, it should be somewhere here. Yep. So it is going to analyze all the tables. So analyze increases the performance of your uh, uh, database, because the query planner updates the statistics, and that is used during the execution execution of the SQL query. We can check one more thing, and just right click onto the database, just say maintenance, and you can do the reindex. Just say okay, and you just have to tap on that particular tab, whatever you wanted to do. Just say more detail, reindex, reindex database name, and it is going to reindex the entire database. So reindexing is completed. The final in this is the last one, which is maintenance, and you just say cluster. And if you just say OK, and this is not the task which we have automated. This is just we are doing an ad hoc. If you wanted to do it in a scheduled way, either you do it, put it into a cron job, or you do it using the PG agent as well. So we are doing the cluster verbose, so it is going to run it. It is showing successfully completed. So this is how do we do the routine maintenance in Postgre using the pgadmin 4, and it is very easy. You just right click onto the database, just do maintenance, and all the 4 options will be available. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is vacuum and auto vacuum in PostgreSQL. So first of all, let's see what is vacuum in PostgreSQL. So uh, Let's consider a situation wherein you have a table with over 1 million of rows, and your application continuously updates and deletes the rows into the tables. Let's say thousands of rows are getting updated or deleted every hour. So just to maintain the MVCC architecture in PostgreSQL, what it does, let's say the 1,000 records has to be deleted due to the nature of the application. Then those 1,000 rows are not getting deleted. What is done by the Postgre is they are marked as the dead tuples. That means they still occupy the space into your table, and the table size keeps on growing. That particular row is not usable and it has no dependency. So those are marked as dead tuples. So every hour, let's say thousands of rows are getting, let's say, piled up in your table, and within 24 hours, let's say you have 24,000 rows which keeps on accumulating. So Postgre came up with the process which is called as vacuum, wherein those dead tuples, they will be cleaned up by a process which is called as vacuum. So what is vacuum? Vacuum is used to free up the dead tuples into the tables, and these rows can be reused. So you can use that rows later on. There may be an option also wherein that row can be returned back to the operating system. So let's see what is vacuum at a glance. So what happens? When you do the vacuum, which is a command on your Postgre. So Postgre vacuum command will remove those dead tuples, or those rows which accumulated when they have been deleted or updated from the table, and they are valid both for table and the indexes, because when you update your table or delete the data in your table, the corresponding indexes are also altered. When you do the vacuum, it is not going to return the unused storage to the operating system, but those particular storage area, let's say this is marked as the tuple, which is has been deleted. This is no more usable. When you do the vacuum, this will be returned back to the table, and this can be used. So when you do the vacuum, it takes the compute from your system. It is going to take CPU, it is going to use the IO. So this has to be done only when your application activity is low and you have enough storage on your operating system. You can do something called as vacuum full. When you say vacuum full, it is a process which takes lots of compute, which is CPU and memory, and it is going to return back the storage to the operating system. So only when you say vacuum full, this is going to return the unusable storage to your operating system. But this is a very challenging task, because when you do the vacuum full, it is going to log the table. That means it is a kind of complete downtime for your application. You cannot do any operations. Even select operations are not allowed. When you do the vacuum full, it is going to create a new copy of the table, so that those data tuples will be completely removed. So you need to have double the storage, which is a kind of challenging task in your production environment. This can be only done when you are going to refresh your entire system, and consider this only if you have enough storage. So most of the time this is not possible. So what happens when a table with millions of rows in a day, and 24,000 rows are updated or deleted? The statistics of the table also gets changed. So instead of 1 million rows, there will be a minus 24,000 rows lesser in that table. So when the query execution happens and that table is part of the query, then it is not going to have the current statistics. So what you need to do after such activity wherein the table is heavily updated, then what you need to do, once you have to do the vacuum so that the unused the dead tuples are removed, and once the dead tuples are removed, you have to update the statistics of the table using the analyze command. So this will update the statistics, and the latest statistics or updated statistics are used for the query during the execution plan, and your query will be able to execute in in a lesser time. So when you do the analyze, you can do it for the entire database if you think the fragmentation has the updation has happened so much. So you do two things: you do the vacuuming and you do the analyzing. Vacuum we do because a lot of dead tuples has accumulated. Analyze you do because the corresponding tables and indexes, what do you say, the stats has also changed. Uh, Postgre came up with the with what do you say, the process which is called as auto vacuum. So instead of you doing it manually vacuum, Postgre will do it on your behalf. So by default, auto vacuum, the vacuuming and analyze is happening automatically at the database level. So by default, this is on in Postgre. So you need to remember some of the important parameters of the auto vacuuming. So auto vacuuming is when the vacuum is done automatically by the database. So by default, it is on. So in PostgreSQL.conf, if you say see auto vacuum, this should be on. That means your auto vacuuming is working. Then there is another parameter which is known as log auto vacuum minimum duration. As the name suggests, log. So it is going to log the auto vacuuming activity when the value has been mentioned. If it is -1, that means it is not going to log the activities. If you mention the value greater than 0, then it is going to mention capture what all auto vacuuming it has done. Then another parameter is auto vacuum max workers. That means by default there will be one auto vacuum process. So that is uh, uh, in case you have n number of tables where this vacuuming has to be done, then one worker will not be sufficient. So you need to increase the number of auto vacuuming workers. So by default, it is 3. So along with your auto vacuum process, there will be 3 more sub workers which will do the vacuuming process. There is something called as auto vacuum nap time. So once the auto vacuum has launched for the first time and it has finished its task, then after what time, after sleeping for how many minutes, it is going to execute again. So it is going to execute again after 1 minute. Then we have another important parameter, which is auto vacuum threshold is equal to 50. If 50 rows have been updated on a particular table, then auto vacuuming is going to happen on that particular table. So vacuuming and analyzing, they work together. So once the vacuum has happened and there is a updation of 50 rows on a table, then it is going to launch auto vacuum. So vacuum and analyze is going to happen on that. There is something called as auto vacuum scale factor equal to, by default it is 0.2. That means if a table which has 100 rows and if 20% of the rows have modified or there is a change, then auto vacuum is going to launch and it is going to remove the dead tuples and it is going to update the statistics. So vacuum and analyze is going to happen. So auto vacuum analyze scale factor equal to 0.1. That means if a table which has 100 rows and if 10%, that means 10 rows have modified, then the analyze command is going to execute on that. And similarly, you have auto vacuum, vacuum cost delay. That means the default cost value for the auto vacuum. This is 20 milliseconds, and default vacuum cost limit. This is by default -1. So now let's proceed with the demo. So So I'm going to put this in the comment section. So what is vacuum? Then what is a manual vacuum command? Then what is vacuum full command? And how do we check whether vacuuming is enabled in my system or not? And then we'll see some of the parameters. So let's close this first. I'm going to close this out. Okay. I'm logged into the MovaXterm tool, and I'm connected to my database server, which is 192.168.1.61, and I'm on the command prompt. So I'll just say select name comma setting from pg underscore settings, where name equal to auto vacuum. So by default this is on, so this will show that auto vacuum is on. And we discussed about the auto vacuum parameters, like auto vacuum on, this is by default. When auto vacuum has to log all the activities. If it is -1, it is disabled. What is the maximum number of workers that should launch along with the master auto vacuum process? Then you have auto vacuum nap time, for how many minutes it's going to sleep between the second execution. Then you have auto vacuum threshold. That means if 50 tuples have accumulated, or 50 rows have updates minimum, then it is going to execute. Then you have the analyze command is going to execute when there are changes in 50 rows. Then there is vacuum scale factor 20%, 0.2. That means if there is a change in 20% of the data, then vacuuming is going to happen on the table. And similarly, analyze is going to happen if there is a change in just 10% of that. Those were the important ones. And again, that why Postgre creates vacuum, it is just to maintain the MVCC architecture, that those dead tuples keeps on accumulating after deletes or update. And finally, we'll see. Let's list out the databases. If I switch to DVD rental database, it will be like this. And if I do a vacuum process, vacuum verbose analyze, this is how do we do it. So you can see that it is doing, although there are no dat tuples, so it is going to do it on the indexes and the tables both. So you can see if I fire this command, so this will show how many. So it is select rel name comma n underscore dat tuples from pg underscore states underscore user underscore table. So this will show the tables in my current database, which is DVD rental. So how many dat tuples are there? If there are dat tuples, then you can vacuum it. Otherwise, auto vacuum is going to happen automatically. You can check this storage utilized by all the tables. Let me do it this way. Let's see the size of all the tables. So rental table has this much of size, and so on and so forth. So if you are doing vacuum full, it is going to take this much of storage again, and this is like creating a new copy and deleting the old one. And you can see when the vacuum has last happened on this particular list of tables, since we did it right away. So this is the current timing, and you can check. This is the way you check it. So just a recap of what we have done is We checked what is vacuum in PostgreSQL. A vacuum means it is just like that tuples keeps on accumulating in a table when those are deleted or updated, and you have to either manually remove it or it is removed by something which is called as auto vacuum process. So vacuum is nothing. It is like the dat tuples keeps on accumulating in your tables and indexes when the related data is updated or deleted, and it accumulates uh, in your table. And this keeps on growing the size of the table unnecessarily, and the performance get decreased. So you have to remove those dat tuples from the index and table using the vacuum command, or auto vacuum does it itself. If you say vacuum full, then it is going to lock all the tables, and it is going to use the double storage. It is going to create a new table as well. So we discussed about the plan, updating the planner. So it is like in auto stats, in auto vacuum, your vacuum and analyze work together. So once vacuum happens, the corresponding statistics of the table also changed. Let's say in a table with the 1 million rows, 100,000 are updated daily, then you have to update the statistics of the table as well using the analyze command, or auto vacuum does it automatically. Then we discussed about what is auto vacuum. So when vacuum happens automatically by the database, it is known as auto vacuum, and by default it is on, and there are some corresponding parameters, and the important ones are like auto vacuum max workers and the nap time, etc. What is vacuum threshold, vacuum analyze, um, like 50%, 50 rows are updated, then this auto vacuum is going to launched, or if 20% of the rows are updated or 10% of the rows are updated, then analyze is going to kick off. And finally, we saw a very small demo. You do the vacuuming manually, and it works that way. So I hope this is going to give you a brief idea of how this auto vacuum is working, and we'll see new property of Postgre in some other tutorial. I hope it is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is bloat or bloating in PostgreSQL. So let us see what is bloat in PostgreSQL. So let's take a scenario wherein an application is trying to update an existing record in a table of a particular database. So when a update happens, it does two actions. First, it creates a new record, which is a result of the update, and the previous value of that particular record is still existing in the database or in that particular table as a dead tuple. So let's say in that table, due to the application behavior, the rate of generation of those dead tuples is more than those tuples are getting removed. It is known as bloating. So you must have gone through the auto vacuum process, wherein the dead tuples in the tables are removed due to auto vacuum. And if the rate of accumulation of the tuples in the database is more than the rate of the removal, it results in the existence of those dead tuples that they keep on accumulating. So that is known as bloat. Let us see a bloating scenario, how actually it happens. So I'm just taking the same example again. Our application is trying to update or delete the records in the database, let's say particular table. In a minute, there are about hundreds of records. They are updated or deleted. And due to the behavior of Postgre, when 100 records are updated or let's say deleted, it results I it results in two action. If it is an update, 100 new records are generated as a result of update, and exact 100 records are accumulated as the dead tuples, which has the previous value. And if my auto clean process is running, which is used to remove the tuples, and let's say my auto clean, which is known as the auto clean process, is trying to remove those tuples, which is known as the auto vacuum process. It is removing 90 records per minute. So every minute 10 records are getting generated or accumulated as dead tuples. So this is leading to bloating. So in 1 minute, where 100 records are updated, 10 records are keep on accumulating. So you can understand how many dead tuples will generate in an hour or in a day if those dead tuples are not removed. So what is the problem they may cause to the PostgreSQL? First of all, the number of records, they will be more, although they will not be visible, but in terms of the size of the table, it increases. So what it does, it decreases the performance of overall query execution, wherein that particular table is involved, where bloating has happened. And when the bloating is there in a particular table, let's say there are 100 records, 1000 records in a particular table, and due to bloating, this has become 2000 or 3000. I'm assuming that those dead tuples are not uh, uh, removed, or due to let's say we are not knowing, or due to any reason, so we have not removed those dead tuples. So it leads into the inaccurate statistics of the table. So when the query having that particular table is executed, it gives the wrong statistics of the table. Instead of having the actual 1000 rows, it has more than 3000 rows. It has to traverse. So it gives the inaccurate statistics when the execution happens for that particular query wherein that table is involved. So when a query executes there, it generates an execution plan, and if the table statistics are not correct, then the execution plan will also not be optimum, and instead of giving the best results on a best time period, it will give you the result in an appropriate time. Let us suppose the execution time should be 10 seconds. Then due to this bloating, and it depends upon the number of bloated rows, it may be more than that. So it is causing a lot of problems. So it causes the performance degradation of overall database, where bloating has happened in those tables. So what are the options for removal of those? It has to be removed. So you can go for the vacuum full, which is a manual process. When you do the vacuum full for the entire database, let us suppose we are going to do the vacuum full for the entire database. It is a kind of complete downtime for the database. You cannot do anything in that particular time. So it is just like it is going to create a new copy, and the tables will be logged during that time, and you need to have double the space. Let's say your table is of 10 GB, then you need additional 10 GB so that it can create a new copy and can delete the older copy later. So this removes the bloat. Second is PG repack. So this is an online option to rebuild your tables where bloating has happened. And when this is not available by default, so you need to install this package. And once it is installed, you can do the online repacking of your database or the table. So what it does, it creates a fresh copy of the table without those dead tuples, and it is as good as your full vacuum, but this is not going to lock your table for like your vacuum process is doing. And last in this is the demo how to remove the bloat. So I have listed the step over here, and I'm logged in as a Postgre user. Let's log into pSQL prompt, and let us see the number of tables which I have. Let's say the databases I have. Let's go to DVD rental. So what we are going to do is we are going to do two things. One is, let us assume, although there is no bloating, I have not deleted or updated anything. So I'm going to run a vacuum verbose analyze. So what it is going to do, it is going to do, uh, let's say, vacuum full, and we can give the table name, or let's do it for the entire database. I'm not okay. Let me switch to DVD rental database. Yes, and now execute the vacuum command for the entire database. So you can see all the tables in that particular database are getting vacuumed. Although there is uh, no dat tuple, but it has done everything. So you can see uh, vacuuming this particular table and the index. Let's say here also public.film. This is the table name, this is the index name. So it will remove, since this is a very small sized database, but in large database it can take its own time, and this takes a lot of CPU and the compute resources, so you need to plan it during the complete downtime. And second is PG repack. So what I can do is my PG underscore repack binary is available at this. We can do some kind of dry run for the database. So let's do this. So PG repack hyphen dry hyphen run DVD rental. So we are going to do a dry run. Oh, okay, this is, I have to come out of this, clear the screen, and let's do the dry run. So you can see repacking is happening. So it is going to repack the table again, so that all the bloating is removed. This is a dry run, and when you do it, actually you will be doing it like this. Uh, PG underscore repack hyphen D, then the database name, or you can give the table name also. So you can give hyphen hyphen table and the table name. I'm doing it for the entire database. So let's see how it is happening. So repacking table. So this has done. The first one was dry run, how it is going to happen. Then there is the next one is the actual run. So just a recap of what we have seen is what is bloating. Bloating is nothing, just the dat tuples which keeps on accumulating into the database, and when your auto vacuum process is not able to remove it, the number of data tuples keep on accumulating. That is known as the bloat. Bloating scenario we have taken wherein an application is generating a number of it is going to update a number of records, and few records keep on accumulating as dat tuples, resulting in the bloating and leads to the poor performance of the database due to the size of the table which has increased enormously, and the indexes go as well. The statistics of the table change because the actual records are named not same as the records which are present because of the dat tuples. The query execution plan go haywire because of the wrong statistics. And then we saw how to remove the bloating. We saw vacuum full, which locks all the table. Uh, and it requires downtime. Then another is PG underscore repack, wherein the repacking for the individual table happens, or for the entire database, and this is an online activity. And this is good. And I have installed it separately, and once I have repacked all the tables, I'm going to remove this particular package. So then we saw how to remove the bloat using both the process uh, vacuum full and then PG repack. I hope a removal of bloating process is going to help, and thanks for watching. Welcome. In this session, we are going to learn what is vacuuming fundamentals in PostgreSQL. As the name says, vacuuming, it is actually going to do the vacuum of PostgreSQL. So as usual, everything is there in a notepad, and we will walk through this. So one of the fundamental thing about the databases or any software product is if you do the regular maintenance of those products, which is the suggested one, the performance will be good. The same goes with the PostgreSQL. PostgreSQL suggests you should do the periodic maintenance so as to avoid any kind of overhead which comes when you don't do the maintenance activity. One of them is the auto vacuum. As the name says, auto vacuum is a vacuum process which removes the dead spaces, which is in the form of the tuples from the table, and it improves the storage utilization, and it removes the dead rows, which are also known as the tuples. One of the thing which is for the Postgre is to maintain the MVCC, which is multi-version concurrency control. Whenever a row from a particular table is updated or it is deleted, it is, and if the same row is being used by some other concurrent session which is going to read, and the other session which is going to update or delete that particular row, in that case, just to maintain the lower category of the locking mechanism, what it does, it retains the previous version of the data in the table in the form of the tuples, and that will be visible to your SQL query, the active transaction till the time they are in use. The moment the data or that particular row is updated, and the concurrent session which is reading the data of the older one, it is marked as the frozen one, and it is called as the tuples. What happens over a period of time, that particular the number of such dead rows, or they are known as the tuples, they will keep on increasing. Fundamentally or basically, they are not going to get removed automatically. Somebody has to remove this, and there is a process which is called as auto vacuum, which is available as a background process in PostgreSQL. It is going to do all the stuff which is known as the vacuuming. So what vacuum does, it reclaims the storage by removing uh, the unused, or the not the unused, I'll say the dead tuples or the unwanted rows which have been actually marked as deleted or removed or updated from the table. So if you don't remove those rows, what it will do is over a period of time, it will keep on accumulating the size in your table, and the performance of the table will go slow. If you are doing the vacuuming, which is a background process known as the auto vacuum, then what it will do is it will periodically check the tables. It will check if there are unwanted dead rows which are not supposed to be there, and it is going to clean them. And it is a very frequent activity. It will check for some conditions. Say, for example, if there are 50 tuples, or if 20% of the total rows of the tables are changed, and that means there will be so many numbers of the dead tuples in your table, and through some way you are supposed to remove it. Postgre very strongly suggests you should not disable the auto vacuum process unless or until you have done some deep research which says some of the tables which are very large in size, it is very volatile in nature. The number of the rows which are updated, they are very high, and they are not able to keep up with the kind of auto vacuum thresholds which are there. So in that case, to particular table, you can do the vacuuming according to your requirement. So that's the basic. So why is the vacuum required? A vacuum is required to remove the tuples from your table, and it is going to release that space back to the table so that the new rows can utilize that. And there is other way also in some of the scenarios. If you use the full vacuum, with in that case it is going to release the storage back to the operating system. In that case you can use that. This is one of the reason why vacuum is required. This is removing the tuples. The second is the data in your table. If the statistics is not properly generated, in that case the query planner, which plans the execution plan of your query, in that case it will not have the enough data. It will not able to generate the proper SQL plan for your query. In that case the performance of the SQL query can go down. The third one is known as the visibility map. In that case, if the visibility map is not properly updated, then it is going to impact your query as well. The last but not the least, it is about the transaction ID wraparound, which says if your transactions in your database they cross 200 millions, then you need to perform the vacuum. Now we'll talk about what are the different types of vacuum. There are two types of vacuum. One is called as the full vacuum and another is called as the standard vacuum. By default, the vacuum which runs using the auto vacuum launcher, it does the standard vacuum. What it does, it removes the dead rows, and those dead tuples, they are given back to your tables, which can be used for the rows which are being inserted or the new rows. But this will not be given back to the operating system so that you will not see the any space which is released at the operating system. But for the production environment or any environment wherein Postgre is very active, you are supposed to use the standard vacuum, because it is not going to interfere with the normal operation of the table, because it is a recurring activity. Every time it is going to check whether, if we go with the default setting, which says that 20% of the table data must have changed, or 50 tuples would have generated since the last execution of the auto vacuum process. In that case it is going to execute, and also it is not going to interfere with your normal application which is interacting with the database. Any sort of insert, update, delete, whatever operations it is not going to interfere. Only there is just one case. In case your database table definition changes, in that case the when the definition is changing, it is going to put a exclusive lock, and in that case the standard go vacuum is not going to work. But in case if you go with the another type of the vacuum which is known as the full vacuum, in that case it is going to create another copy, temporary copy of the table. And one of the thing is you might already be suffering with the storage scarcity, and if you try to do full vacuum, that means it is going to be a kind of complete downtime for the application. You don't have the storage, and it is going to pick up all your CPUs. So it's not suggested to do unless or until you have a very strong reason which says we should be doing this because of our auto vacuuming is not able to suffice our requirement. And one of the observation is whenever the vacuum process is running, the IO on your subsystem is going to be high, and this what it does, it slows down your application. So how the disk storage is getting released? One is, if it is a standard vacuum, the storage will be given to the table, and the free spaces can be utilized by the new rows. The other one is full vacuum, which is like creating a new copy of the table, but it is going to completely lock your table, and in that case the application cannot use that particular table for the activity, so it is considered as a complete downtime. But full vacuum, it is going to recreate a fresh copy of the table wherein all dead tuples will be removed. But the suggestion is not to use the full vacuum. You go with the auto vacuum, which is suggested, and you can tweak around the different parameters which are available. And one of the thing is, what is the difficulty with doing the vacuum according to the fixed schedule? If you try to do vacuuming according to a fixed schedule and your application is again active, let's say I disabled the auto vacuum, I enabled the manual vacuum, I put the vacuum command in cron job. Every night at 2200 hours it is executing, but because of the lot of application activity, it is I'm not able to perform the complete vacuum process in that, and the window is over. That means the number of data tuples will keep on increasing, and this may lead to a scenario wherein you have to do the full vacuum. That will be the only case, because you have already lost the chance to reclaim the storage using auto vacuum process. When to schedule it? If you are not using the auto vacuum, and if you wanted to use the manual vacuum process, in that case it is advised to use it when your application activity is low. And in that case, you have to ensure that the table is not being utilized. So if you are going with the full vacuum, in that case, you have to make sure that the you have enough storage to perform the vacuuming processes. And one other thing is, if there are some tables which are going for very high deletes, or let's say all the contents of the table will be deleted. So it is recommended, though this may not be a very usual scenario, but it may be possible that the entire table content is deleted. So the entire content will go back to the dead tuples, and they will occupy the space, and you will see the increasing number, the size increase, because the dead tuples relies over there. The second important function of your auto vacuum process is it updates the planner statistics. So planner statistics is updated when you perform the auto vacuum. So when you perform the auto vacuum process, it executes the analyze command on the tables in the database. So it means when the analyze commands happen, so your planner will be knowing that what is the statistics of my table, and that leads to the good performance, because the execution plan will be according to the statistics which is generated on the table. And it is highly recommended your table should be analyzed properly, and it is more important when your database is highly volatile, the tables are highly utilized in insert, update, or delete kind of operations. So you have something called as the visibility map, VM, which is like it is going to each heap relation has a visibility map which keeps tracks of which pages contains only the tuples which are known to be visible for all the active transactions. So it is stored along the main relational data in a separate fork. So what visibility map actually stores it stores the heap page information. That means if it has the frozen what do you say, the tuple, so it is not going to be visible, because the query which was using the active transaction or the table, it's had already completed. And you can check it using the pz underscore visibility module, and it can show you the required information. And the last most important thing about the vacuuming is it helps in preventing the transaction ID wraparound failure. So because of the MVCC transaction, what happens is in case of PostgreSQL, if you believe the transactions in your Postgre is going to be more than 4 million transactions, then you have to be very careful, and you have to set some of couple of the parameters to avoid any kind of loss of the data. So this is very important. So just to recap, there are four important functions in PostgreSQL for vacuum. We'll go them one by one again. So one is you can recover the storage using the vacuum command. If you're doing it manually, which is not suggested, you should go for the auto vacuum. Second is it helps in generation of the statistics on the table. The third is the visibility map, which helps in speeding of the index only scanning. And the last, which is related to the loss of the data due to the multi-exact ID wrap around. So this is just a basic about the vacuum, why we should prefer doing it. In another session, we will see some more details about it and how to tune it further. I hope this is going to help, and thank you. Welcome. In this session, we are going to learn what is max connection. If we increase it, what is the impact on the performance, and why it is always increased to use the connection pool in Postgre. So as usual, everything is mentioned in this notepad, and we'll start the steps one by one. The first thing is, what is max connection? So when you go to PostgreSQL and you just search for, if you say show config underscore file, that will show you the, okay, this is typo. This is the location of my configuration file, which is postgresql.conf. In case you directly wanted to see what is max underscore connection, you simply say show max underscore connection. So as of now, it is 101, and the default value is 100. So we will talk what is max connection. So max connection is maximum number of concurrent connection that is allowed to PostgreSQL. By default, it is 100, and it depends upon the kernel parameter which your operating system is going to support. And this is set when your server is started. If you have a standby server which is attached to your primary server, in that case, this parameter max underscore connection should be slightly on the higher side, just as to allow the extra connections to be executed on your standby server. If you talk about 100 concurrent sessions, that is not always allowed for the client connections. There are few which are reserved by the super user also, and that is this is called as super user reserved connection. That means there are three sessions which are three concurrent connections. They can be used by the Postgre super user in case they have to do some maintenance, and all of the users concurrent connections, they are utilized. So one of the question which arises is, if the max number of connections has already achieved, and what action do you need to take? Do you need to increase the number of max underscore connections? Definitely not. This is going to impact your entire system. What happens if all the 100 connections, that is 97, which is used by the application, if they all concurrently access your environment, then they are going to take all of your CPU of the system, or IO subsystems will be burdened. And more the number of connections, you are going to have more issues with the RAM which is allotted to your Postgre. So in general, it has been observed that each connections which is connected to your PostgreSQL in general consumes something between 5 to 15 MB, even if it is not doing anything. So the resource requirement for the database connection. So on your host where your PostgreSQL is running, you have the limited RAM, and if you increase the number of connections, then the RAM which will be allocated, not exactly the RAM, the memory which will be allocated to each session will keep on decreasing. And there may be a situation wherein your system will run out of memory because there will be not enough memory to cater the application requirement. And there is something called as work underscore memory. By default, if you check, this is going to be show work memory. This is going to be just 4 MB. So if you, in case you wanted to, there is some mathematical calculation which you can try. This is difficult to achieve. So if you can see over here, max connection, this should be within lesser than your maximum number of cores which are there on your operating system. Then parallel IO limit, which is divided by the session busy ratio multiplied by average parallelism. So number of cores, parallel IO limits, that is number of concurrent IO requests. Session busy ratio, this is a fraction of the time when the connection is active. And average parallelism is average number of blocked processes working in a single query. Difficult to calculate, but this is a formula which is provided, which this can be used. But in general, the max number of connections should not be increased without having a detailed analysis why there are more number of connections coming out, because this is going to bring your system on knee. One of the way to tackle this is you should have a connection pool. So connection pool is a kind of software that retains n number of the database connections open, so that once your connection is done, it is not going to lose that. It will be given back to the pool, and some other session which is trying to access it, it will be given to that. So there are two types of connection. One is application side pooling, which is called as the connection pool at the application server, and another is the database level. In application pool, the pool takes care of the concurrent session, so it doesn't close actually. What it does, if a new connection is coming from the application and the previous one has already closed doing it, then it goes back to the pool, and once a new request is coming, that will be given to the new connection. That's the way it works in application layer. And it is good to have, because every time you open a new connection, that means you are going to exhaust the resources from your PostgreSQL server. The another way is you can use some of the connection pool at the Postgre level. You have PG bouncer and PG pool. They can be used to minimize the number of connections, and it creates the pool. The pool will be optimally used for making the connections. These are some of the decision making stuff which you can do, but there are more than that. If you have to increase the max connections, then what is that you need to check? So is there any application which is connecting to your Postgre, and it is not getting closed, or it is getting leaked? Are you using the PG bouncer or PG pool for in use? So it is like, it is questioning, are you using the connection pooling? Yes or no? If you are not using, is there any reason why you are not using? Because you are increasing the number of connections. And the other thing is, if nothing works, you have to decide on increasing the number of max connection. There is no way left out. So max connection depends internally on the shared buffer, which internally depends upon the kernel SHM X, which is at the operating system level. So when I say max connection, it is the maximum number of concurrent connections. In general, it is 100 when you do it, when you install your software, and it has to be shared with it actually depends on shared buffer and kernel dot shm max. So we'll see what is that. So kernel.shm max is the maximum size of shared memory segment. Let's say my system has, this is my current setting, max connection is 100, shared buffer is 128. I wanted to make it double. So um, let's say I make it 200, then you have to increase the shared buffer as well, so that the shared buffer which is allocated to your Postgre, that should also increase accordingly. So we say max connection and shared buffer. Shared buffer is how much memory you are going to allocate to the PostgreSQL for caching the data, and SHM max is the maximum size of shared memory segment. A shared memory, SHM max is how much of RAM you wanted to allocate so that it will be reserved and it should not be given back anywhere. So if you have 1 GB of RAM and if you check the SHM max, let's say 30 GB, 30% of that you have given to your system, then you have to convert it into to bytes. So let's say 300 MB, you convert into bytes and you set it to your kernel.shm max. So you can convert 300 bytes. In normal traditional servers, the normal cloud servers where virtual machines are allocated, the higher value is always more than sufficient. But in case if it is not, then you have to change it. The other thing which you have to change is the shared buffer. By default, it will be 128 MB. You need to increase it in case you are going to increase the max number of connection. And this is the and you can check how many connections are being thrown at your system. So these are the maximum connections reserved for the super users, three, and there are six which are in use. But you should check what is the active, inactive, and total number of connections which are being thrown to your PostgreSQL. So in short, max connection is not a straightforward parameter that can be increased without digging too much. If you are going to increase max underscore connection, you have to think about the shared buffer. You have to think about the SHM max because they are interrelated with each other. And above all, you need to make sure that connection pooling is enabled in PostgreSQL because PostgreSQL is, we say this is memory hunger system because it is going to take more memory. If you keep on increasing, your system will run out of memory. So in short, just check if there is connection pooling at the application layer or at the database layer, something like PG Bouncer or PG Pool, or if not, you have to make sure why there are so many connections which are coming out, they are not getting closed or they are getting leaked. In case if it is finally decided you need to increase the number of connections, just make sure you optimize the shared buffers and SHM max. There is a very good tool which is called as PG underscore tune. If you see this, there are details related to this. So if I make the version 13 OS type this web application, and if I say I have 4 GB of RAM on my system, there are two virtual CPUs, the number of connections are 200 if I'm increasing, the storage is SSD storage, and it will give you what is the optimal number of the shared buffer which you should keep. So I personally feel that this is a good tool to give you some sort of suggestion. These are the optimum suggestions which can be utilized. So in case you do not have any calculator which says how to calculate it, and if you have these things handy, the version, the Linux, the operating system type, memory, CPU, number of connections, then pgtune is going to help you. I hope this is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG repack, or what is the utility which is used to rebuild the tables online in PostgreSQL. So what is PG repack utility in PostgreSQL? So PG repack utility is a utility which is used to rebuild PostgreSQL database objects online. So this particular utility, PG underscore repack, is not available by default. This is available as an extension, and when you wanted to use it to remove the dead tuples or bloating in the tables or the indexes, you have to use this PG repack extension. You have to explicitly download it, use it as an extension for removing the dead tuples and bloating. So this is somewhat similar to the auto vacuum which we use to remove the bloating or dead tuples in the tables or the indexes. But what it does, apart from what auto vacuuming is doing, it is restoring the physical structure of the clustered indexes and and uh, uh, it actually removes the bloating, which is sometimes not possible by the auto vacuum process. What are the advantages of using PG Repack? PG Repack utility, it releases storage from the table to the file system. So the dead tuples which is occupying the storage in the tables or indexes, which is leading to the slower performance of those tables which are included in the query, it removes those storage back to the file system. And this can be used for rebuilding a table wherein bloating has occurred and auto vacuum process is not able to remove it. And when you rebuild a table, it of course reduces the IO because the size of the table becomes smaller in terms of the number of pages which it is going to use. And it actually releases the dead tuples which has accumulated as the bloat in the tables, which auto vacuum process is not able to release. So now we'll see the demo on PG Repack. So there are 3 steps. So we will see how to install PG underscore repack because this is not available by default. You need to explicitly download this utility. Then we'll see how to bind it to a particular database wherein we have to use this PG underscore repack utility. And then we will rebuild a couple of databases and we'll see how it works. So let's see the demo. And so I have a Linux system where the IP address is 192.168.1.56, and we will see how to perform it. The first step is how do we install the PG repack extension. So we'll say yum install PG underscore repack. I'm using the version 12, so I will be using this PG underscore repack 12. So this is going to take less than a minute or so, and I have the internet connectivity on this server. I'll just say yes, and this utility will be installed within no time. This is done. The next step is you switch to the Postgre user. We'll switch to the Postgre user. And once it is done, we'll just run PSQL. Just run PSQL. Okay, let me see if we have started server or not. Sudo systemctl start PostgreSQL 12. So let's fire PSQL. Okay, it was down, that's why we were not able to connect it. Then next what we will see, what we will do is we will say set shared underscore preload library is equal to PG underscore repack. You need to get this enabled, shared preload library, so that we will be able to use it. It is saying that shared preload library cannot be changed without restarting the server. So let's restart the server using the next step, wherein we will say pgctl-d $pgdata restart -mf. So let's restart it. This is restarted. Let's see PSQL. Yes, we are able to connect again. And then what we will do is we will create the extension wherein we are going to rebuild the tables online. So just let's see the number of databases we have. PSQL -l. You can see that we have DVD rental database, DVD rental underscore new now, and we are going to rebuild the tables in that particular database. So what we will do is just change to that particular table, switch to that particular user, table DVD rental. And now what we will do is, this is very, very important. Whatever database you wanted to use this PG repack to run the online utility to repack the table and the indexes, you have to run this. So if I say create extension PG underscore repack, and what we are doing it is in DVD rental database. So once the extension is created, then only you can use it. And the final step is we will rebuild the tables online. So just quit out of PSQL and what we will say is we will rebuild the tables online. So there is a table called as actor in this particular database. So first thing we can do is we can do a dry run. Let me clear the screen. And then we say pg repack hyphen hyphen dry hyphen run hyphen d database name hyphen hyphen table and the table name. And the table name is actor. Okay, I need to give the complete location because um, I have couple of instances running, so I need to tell the exact. Either I set the location using path, I set the path location, or I can use the complete binary location. So let's say pg repack hyphen hyphen dry run hyphen d database hyphen hyphen table table name. Okay, dry run enabled not executing repack. So just to, this was a dry run. So let's do the actual run now. And same thing without hyphen hyphen dry run. Okay, uh, I need to give, or I should have, let me export path equal to $path colon, let me give the binary location. Okay. pg repack hyphen d database. So you can see that repacking is done. Let's try it for the entire database. So first we will do the dry run and then we will do the actual run. pg repack hyphen hyphen dry run hyphen d database. So let's perform this. So dry run enabled, not executing repack. So let's do the actual run now. It's very simple. What we are saying is pg repack hyphen d, then database name hyphen j, the number of threads, and we are going to run it in parallel. So you can see that it has taken all the indexes, tables of that particular database. So this is done because there was no um, dat tuple and the what do you say, the bloating in the database tables or the indexes, so everything was fine. That's why it came out. Otherwise, depending upon how many dat tuples or bloating you have, it is going to take its own time. You can run this utility remotely as well. If you wanted to drop the extension, you just say drop extension, extension name, and you can remove that. If I try to run this command onto a database where this particular extension is not enabled, it will not work. So if there is a database with the name dvd rental underscore new, so let me show you that. PSQL -l, you can see that dvd rental underscore new database is there. So let us try to um, execute this dry run in that particular database. So dvd rental underscore new, we are trying the dry run. So dry run enable not executing repack. Let's try to actually run it. I'm not sure if I actually executed the extension command in that. If it is done, then it will work. I think I have already done it. That's why it is showing. Otherwise, it will throw you the error that first the extension is not enabled. So in that case, you have to enable it and then you have to execute it. So just to recap, what we have seen is PG repack utility is used to rebuild the Postgre databases objects online, and it removes the bloat from the tables and the indexes, and it restores the physical order of cluster indexes. So what you have to do is first you have to install this extension. So I have a Linux system, so I just mentioned yum install pg underscore repack 12 because I have the instance 12. then you have to set the shared preload library, which is equal to pg underscore repack. Then I have restarted the instance. Then the particular database wherein you have to enable this online activity, you just create the extension in that particular database. Then using the pg repack utility, we have done a dry run for the database. Then we actually removed that hyphen dry run. Then we actually did it for one table. Then for the entire database, we have tried it. And in case you wanted to drop the extension, you have to just say drop extension name, and then finally, if you, because once your activity is done, you can remove the pg repack utility. And this is all about the PG repack. I hope this is going to help, and thanks for watching. And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a password file in PostgreSQL. So this is all about the password file, which is occasionally used in PostgreSQL. So the password file is also known as, the name of the file is .pg pass, which is password file in Linux system. So and it is available in the home directory of the Linux user who is the owner of Postgre software. So when you try to log into Postgre, let's say I'm trying to log in to PSQL using Postgre user. So if I say PSQL-u Postgre, it will prompt for the password. In case I wanted to avoid using the password, I wanted to keep the password stored in a password file, and the password will be read from there. So the file name in Postgre is known as .pgpass. Dot stands for the hidden file, and the password is saved in this particular file in text format. And when you fire PSQL-u Postgre, then the password is going to be read from this. That's the password file in Postgre environment. So what is the location and ownership of password file? So location of password file in Linux system is in home directory, and the name of the file is .pgpass. In Windows, it is in app data PostgreSQL, and the name of the password file is pgpass.conf. What is the permission on the password file? The permission on the password file is 0600 in Linux, and in Windows, the user who is using that particular software should have the full permission on that. Then you have the permission to use the password file. Then what should be the kind of entry in the password file? When you added the pg password file, pg pass file, let's say in Linux, then you will see the format is with the 5 entries. First is the host name, colon port, colon database, colon user, colon password. And what is the usage of password file? The usage of password file is when you do some kind of automation and you do not want to feed in the password on the command prompt, then it is going to pick the password from the file. But it is sometimes so it is a kind of security breach as well. So what is the cons of using the password file? The pros is that you can store the password file in the text format, and your command is going to pick it from there. But when you put the entry in password file, it is visible in the text format, and anybody who has access to it can read it, and it is a kind of password breach. Now let's see the demo. So logged into Mova Xterm as let me close this session first. Okay, there's my Linux system, and if I try to log in normally with the PSQL command, so I'll be able to do it using PSQL. Okay, let me write it manually. So PSQL -u username. Let's say I'm trying to use Postgre user on the port 5432, which is the default port, and if I enter, it is asking for the password. So let me feed in the password, so I'm able to log in. If I wanted to avoid putting in the password on the command prompt and I wanted to save it somewhere, so that is what we say is the password file. The password file location is in the home directory. So let me create a password file. If I say ls-asl, then all the hidden file with dot extension with dot prefix will be visible. So if I say vi.pgpass, I'm just going to create a new one. So in the beginning, let's add some kind of instruction like with the commented line, like format is as below. The first is the host name, then port, database, username, and the password. So let me put this detail, so I'll explain what it is. So I'll be logging to localhost on the port number 5432 using the Postgre user, Postgre database, and I'll be using the Postgre user, and the password is password. So now when we tried earlier, it was asking for the password. So now this time it should display it without password. And now it is showing that permission should be 600. So this is mandatory. So what I will do again is, it is mentioned over here, so you need to mention the special permission as well. Otherwise it is not going to read it. I have given the 0600. So if I say ls-asl, you will be able to see the permission. It is read write permission of the owner, which is Postgre. Otherwise nobody is having any other permission. So let's execute it once again. PSQL-u username-p port name, and you can see that we are able to log in without password. So this is the usage of using the password file. So just a recap, so format is in the host name, port, database, username, and the password. So what is the usage? That it contains the password which is used in the connection which requires a password. And what is the location? In Linux, it is in your default home of the software of who's the owner of the software. In PostgreSQL, it is Postgre, so it is present in the default home directory, and the name of the file is .pgpass. In Windows, it is available in app data PostgreSQL, and the password file name is pgpass.conf. About the ownership, in Linux, it should be 0600. In Windows, it should have full permission so that the software owner can read and write over there. And about the security, this is not one of the best way, because it is available in the text format, and anybody who has access to that particular folder will be able to read it, and it's a kind of password breach. So I hope this is going to help, and thanks for watching. In this video tutorial, we will learn what is WAL in Postgre and how to enable archiving in Postgre instance. So first of all, we will learn what is WAL. So WAL is a short form of write ahead log. So whenever a transaction is performed onto the database, let's say insert, update, delete, or any other which is modifying the Postgre database, is first written out to into a file which is known as write ahead log file. Then it is actually saved onto the actual data files of Postgre database. And whatever changes are happening onto the Postgre, they are sequentially written into the WAL file. So it is a kind of if there is some kind of disaster, you have to recover your database, and if you have the WAL files, then you will be able to recover it. So you can replay the changes which has happened onto your database. So this is a short summary of WAL. WAL is nothing. It is write ahead log. So whatever changes are happening to the database, they will be returned to a file which is known as WAL file, which has a particular location in the database, and there it will be saved. So the next thing is what is the location of these val files? So val files are located under data directory. So let me quickly open a shell. So I have, so let me say sudo systemctl status PostgreSQL. Sudo systemctl status PostgreSQL 12. I have PostgreSQL 12 version installed on my Linux system, and I'm connected through Movaxstrom. So you can see that the status is active and it is in working manner. So the next thing is how do I check the location of val? So 9.6 onwards, it is into a particular file which is known as pg_val, which is under your data directory. So let's go to psql and just say show data underscore directory, and you will be able to see the data directory location. So just navigate to that location and just say ls-lpr, and you can see there is something called as pg_val. So just cd to that location, and you will be able to see a number of val files which are written over there. So this is the default location of your val in Postgre environment, and the version is 12. How can we control the val? Well, let's say how many val files should be there. Let's say at this point of time I have 1, 2, 3, 4, 5 files. Let's say, will it be an unlimited number of files? So what will be the size? What will be the maximum size of those files? So there are two parameters. One is val keep segments, like how many number of these log files you want to retain on your Postgre system, and what should be the maximum size of these max log max val size. So you can see the description in postgre.conf. So let me I'll just say cat postgre.conf, and we'll just grab the value which we are looking for. So we wanted to know about the val keep segment. So there is some kind of description also mentioned. Grab minus, let's say, -i. Let me see where, oh, I'm in the wrong location. That's why it is not working. Just say it again, cat postgresql.conf grep. So without entering, I just wanted to see. So you can see that val keep segments equal to 0. At this point of time, the it is disabled, and we can keep it according to our requirement. Let's say I wanted to keep 10, then I have to change this value, val keep segments equal to 10. Then there is another parameter which is max val size. So what is the maximum size which I wanted to keep? So just say, just search for this and you will see some kind of description over there. So as of now, the max val size is 1 GB. So in this particular file, the val file, you can see this particular file in scenarios, it can grow up to maximum of 1 GB, but if there are big transactions, then it can grow beyond the allocated value as well. So the next one is archiving vals. So what happens if this particular location, the number, let's say 10 numbers are already created, then what after that? So is it going to overwrite that? So in that case, what we have to do is we have to archive those val files to a safer location so that we can store it over there, and in case of requirement we can restore it from there. So we will see how to archive those val files in some other
directory or location, or so archive command can be used. So uh, there are some commands you can say archive command in single quotes CP, and then you can mention the destination. So from its default location, it will be copied to a new location, so that it is not getting overwrite. So you have always a copy available on your disk. So if you wanted to keep it in S3 bucket on AWS, you can do that. You can keep it on Google Cloud bucket. So those options you have, or if you wanted to just archive it to a particular location, you can do that. So let us see this particular archive underscore command. So cat, I just wanted, without entering it, I wanted to see archive command. So you can see that archive command to use to archive a log file segment. The next one is wall level. So there are 3 wall levels in Postgre 12. We have something called as minimal. This is required when your system goes down, and it contains the minimum information which is required to bring your system up. Then you have something called as archive or replica. So archive or replica, in earlier versions it was archive, now it is replica. By default it is as replica, and it has enough information which is required for your WAL files. Then replica is the information which is required to for read-only queries, in case you are building a standby server. And logical, that's the highest level, so you can extract the logical changes which have happened. And so to enable the archiving, if I have to enable the archive, the wall level should be greater than archive. In our case, it will be replica. Archive timeout, what is that? So let's say I am the archive logs, this WAL files are created when the application modifies the data, and in case let's say the application is not accessing the Postgre, and there is no activity happen, then is it like WAL file is not getting created? So you can mention archive timeout equal to n number of minutes or hours. So let's say when we say archive timeout equal to 1 hour, so after every 1 hour, when the counter starts, a new WAL file will be generated even though there is no activity onto the database. And the next one is how to control the size and number of the WAL file. So you can control the size by using max wall size. You can keep it up to the n number of GB. So in our case, we will keep it to 1 GB. And how many wall files you wanted to keep it? So let's say if I say wall keep segment equal to 10, then it will be retained to 10. Let's perform the settings. This is a demo which we are going to do, the archival setting. So the number of parameters which will be impacted is wall level. So let's vi this. Let's edit this file, PostgreSQL.conf, and search for the first parameter, which is wall level. So it has everything. So you can see that here wall level equal to replica is already set, and this is so you have 3 values: minimal, replica, or logical. So in our case, it is already set as a replica, so we already checked. And if you wanted to modify this particular parameter of PostgreSQL.conf, this requires the restart. So this is the first parameter. Then you have max wall size. What is the maximum wall size or WAL size? So as of now, it is set to 1 GB. how many segments of val you wanted to keep at one particular point of time into the mentioned location. So in our case, it is set to 0. That means it is disabled, but we will make it 10. Then you have archive mode. By default, this should be off. So archive mode, you can see here, archive mode equal to off. To enable archiving, we will have to set it on, and this also requires a restart. Then you have archive command. So archive command is, in our case, we will use the cp command, and we will copy it to a different location. And then we have archive timeout. I think timeout is also disabled, so it is 0 at this point of time. So what you can do is either you use VI editor, edit the value, save and restart the instance, or just for this demo we can use alter system so that these value will go into PostgreSQL.conf, and when you restart it, it will read it from there. So just for this demo we are going to perform this. So wall level is already set to replica. Then you have max val size, so we will set it to 1 GB. So what we have to do is, I'm already logged in as Postgres OS user. I'll say PSQL, and we'll say alter system set max val size equal to 1 GB. Perfect. Then we will, how many val files we need? So we wanted to keep 10 files, so we'll say alter system set val keep segments is equal to 10. So let's keep 10 val segments, and let's enable the archiving so that when from its default location, the val files will be copied to a new location when we give the cp command. So we have to, for that to happen, we have to set it on. The archive mode has to be set on, and then we will have, so what we wanted to do, we wanted to keep the archive logs to a particular location, which is Postgre /log. So what we will fire the command is alter system set archive command equal to, in single quotes we'll say cp %p, and the destination is Postgre /log, and the archives will be copied in the form of archive _ val and a unique value. So let's fire this command. Preferentially, you can use VI, make the changes there, and then restart the system. Ensure there is at least one val size for archive timeout duration. So what we will do is, even if there is no activity for this Postgre environment, let's say there is no data getting changed in 1 hour, there will be a switch happen, and the val file will be generated. So we have made all the changes. Now we will restart the instance. Let's come out of the pSQL prompt. Yes, and restart the Postgre 12, and now check out. The first parameter for archiving is show val levels. So it is set to replica by default. So you have minimum, you have replica, and you have logical. So for our case, for archiving, this is more than sufficient. Then what should be the maximum size of val files? So it is set to maximum of 1 GB. How many val files we can store at one particular point of time? So we have set it to 10. Have we enabled the archiving so that these can be copied to a new location? So archive mode is on. Then what is the archive command to copy the val files from their default location to a new location? So this will be copied to this particular location. So we will navigate to that and we'll see. And finally, archive timeout. So even after 1 hour, no activity happens, which generates a val file before the data gets returned to the data files. A switch will happen and an archive eval file will be generated. So if you would have worked in environment like Oracle where archive logs are there, and in there are transaction logs in MS SQL, then you have bin log in MySQL. So it is I believe synonymous to that. Just quit out of this prompt and we'll see if there are some logs generated or not. So we have given a dedicated storage file system for storing the archive logs of val. So you can see that this has happened and it is in the format of archive_val. So just a recap, what is val? Val is just a short form of write ahead log, and this is not a feature of this particular database. In fact, most of the RDMS has this. So before the data is modified data is actually returned to the data files, there is a file which is created so that you have that when there is some kind of restoration required, you can restore from those files. So in Postgre, it is known as write ahead log, and whatever changes are happening onto the database, they are first returned to the val files. So what is the location? Location is data underscore directory, and it is returned under pg underscore val. So how can we keep control the size of val? So you have two parameters. One is val keep segments. How many number of vals you wanted to keep, 10, 20, 30, or whatever you have according to your requirement, you can keep it. Max val size, what should be the maximum size of val? So it is 1G in our case. Archiving vals, so you can archive the vals when your archive mode is on, and you have to use some kind of CP command so that you can copy those files from default location to a new location. Then there are the val levels. You have minimum, replica, and logical in 12. Archive timeout is when there is no activity on the database, there will be a val file generated. And how to control the size and the number we have already seen. And finally, the archival settings. So we have to set val level equal to minimum to replica for archiving to happen. Max val size, which is the size required to keep the maximum size of val files. Then you have how many numbers you wanted to keep. So in our case, we wanted it 10. So val keep segments equal to 10. Then we have archive mode equal to on. This is mandatory. Then you have the archive command. In our case, we used cp %p and the destination. And finally, the archive timeout. These either you use a VI editor, since this was a demo, so I used outer system set, and I restarted the instance, and we checked all the values, so everything was reflecting as required. So archiving is happening as of now, and after 1 hour, when the timeout happens, there will be a switch also happening. So this is all about the val, what is val, how to control the different parameters, how to do the archiving. So I hope this is going to help, and stay tuned for the next tutorial. Thanks, and thanks for watching.
Hello and welcome. In this session, we are going to see how the connection in PostgreSQL can be monitored, and on top of everything, when the connections goes beyond a limit, then how we shall decide on cleaning up those unwanted connections. So this is lesson number 26, wherein we are going to see what is the connection in a PostgreSQL. So we know that in case of PostgreSQL, there is a client and server model. And based on that, whenever a client process requires a connection with the PostgreSQL, then one client process is resulted into one server process. So if there are many requests from the client side, it is going to lead several server processes. That means each time a new connection request is requested, then there is something called as Postgre in case of PostgreSQL, and that is going to spawn a new server process in PostgreSQL instance. So that master process, which is called as the Postgre, it allows all the incoming connections from the client, and it results into a new server process. That means a single client is going to result in a single server process. If there are 10 client requests, that means there are going to be 10 server process. So this keeps on increasing if there are many uh, connection requests from the client, and internally it is going to use your more shared memory and more of the semaphores. That means the memory and the process, it keeps on growing in terms of the consumption. So one of the thing will be you should have some capping, like if my connection goes beyond 80% or 70% or 85%, in that case we should get an alert according to your monitoring tool. So let's say the default connection is 100, and if you set some kind of monitoring which says if it grows beyond 70, then we should get an alert. The alert should be planned in such a way that it should bifurcate the idle connections and the active connections. So whenever the client requests for the connection, it is going to read or write the data to the PostgreSQL. The status of those connections may be in several formats. So it may be active. When I say active connection, that means it is the active transaction, and it is whatever it is, a read or write transaction is happening, and it is alive. The second one is idle connection. The connection idle means that it has connected sometimes back according to the requirement, and as of now it is not doing anything. It may be idle for a long time, and if there are several connections which are coming like this, and if the number of idle connections keep on increasing, that means it is adding up to the total number of the connections. That may lead up in a scenario wherein this may result in some sort of outage, resulting no new connections will be allowed. There is another category where we say idle in transaction. That means there is a bad job or something like that is happening, and as of now the transaction is in the idle format, and the last one in this status state is idle in transaction, which is in the aborted state. The idea is you need to identify what is that we need to take the action. So the first thing which you need to check out is show max underscore connection. You need to find out. So I have an EC2 instance where Postgre 13 is running, and I'm connected as PSQL. If you see, I have 100 default max connection settings, which is available over here. And I wanted to see, so you have a very good catalog view which is available, and its name is pg underscore stat underscore activity. That will show you how many idle connections are there in this particular database, in this PostgreSQL instance. So what I have done is I have connected this is my EC2 instance where Postgre is running. There was 7 DVD rental databases, and what I have done is just I did the right click and I say query tool, and similarly, so this is like I am just establishing a connection. Query tool again with DVD rental restore underscore 1, and similarly the last one I'll try to connect. So whenever I do this, and I check the status of the connection, you will see the number of connections has increased, and there is no activity happening when I connected through the pgadmin 4, and I just being silent over there, not doing anything. So my connection is in the idle state. But if I keep doing this 97 times, which is the maximum allowed connection, in that case, the new connections will not be allowed. Let's say that is a real connection which is coming from the application. So that will result in some kind of no connection which will be allowed to the application. So the thing is, what shall we do next? The first thing is you have to identify what are the connections whose state is idle. Either you can use I'm connected to the putty session, or I can go to here as well, and I'll just say select star from pg underscore stat underscore activity where state equal to idle. You can see that there are a lot of databases, DVD rental 1, 2, 3, and so on. And you can see the PID, process ID. They are not doing anything. And apart from this, it is going to show you a lot of things like the PID, which is for our requirement. It is going to show us the client IP address from where this connection is originating, and it is also going to show us at what time this transaction has started. So those information you will be able to see and fetch from here, and it will also show what kind of wait event it is waiting for. So you can see that it is waiting for the client read. It as this point of time, this is idle in the state. If you just remove the idle and just say select start from pg underscore stat underscore activity, you can fire and you will be able to see all the active and the idle connections. So what else we can see? We can see some more information in this format. I'm just filtering out some of the important, okay, you can see here. So I just filtered the username, application text, the PID, which will be required in case when we interact with the application owner and we say, hey, look, these are the idle connections and they don't seem to be doing anything. Can we go ahead and clean up those connections so that it will be available for another connections, the client request. So what we can do is, once you find it out what are those connections, and there is some more SQL statement which can be used, like either you go with the show connections, or you can fire this SQL query which will say there are 19 used connections, there are 3 super user connections which is allowed, and maximum number of connection allowed are 100. And finally, what you can do is you can find out the details of the idle connection the way we have found out over here. And I'm just finding out, let's say, this is our connection which we are supposed to kill, and the PID is 2753. And if it is decided that this is no more required, this is in the idle state, we can go ahead and we can kill it as well. So I'll go to here and I'll say the connection PID is 2753. So I will say this is 2753, 2753. And using PG terminate backend, you can kill this. This is done. And you can verify the number of the connections which are available, or I'm not sure if we kill the connection which we are connected as of yet. So let us see. This is just to show like what a script you can use. Okay, this is gone. The one which we had fired, so that's gone away. So its ID was 2753. So we are not able to see 2753, and yes, it's gone. So this is how do we manage. So we cannot increase the number of max connection because it results in other way. It is going to consume more resources. It is going to use your shared memory, the semaphores. So what you need to do is you need to find out the idle connections you need to share with the application or not, and then you need to decide whether they have to be terminated or application team needs to close it from their side so that it's gone from here. I hope this is going to help, and thanks for watching. Hello and welcome. In this session, we are going to learn the PostgreSQL backup strategy overview. So back behind the scene, we will see it actually for the Azure, but it is going to be unique for either you go for the on-premises or on infrastructure as a service on any of the cloud. So here we go. So the topic is all about the PostgreSQL backup strategies. So mainly there are three approaches to backup your PostgreSQL database. So the first one is using the SQL dump. The second one is file system level backup. The third one is continuous archiving. The popular of all these three is the basic one, which is SQL dump. So when we talk about this SQL dump, it is going to create a file with SQL commands, and when you restore it on your same host or the new host, it is going to recreate your database in the same state as it was when you have taken the dump. Just to show like how it is going to work, we will see a very small demo for the first item only, not all the three items, because they have been already shown the demo in some other sessions. So by default, PostgreSQL provides the utility program which is called as pg underscore dump, which is being used for backing up the particular database. So how do we use it? So this is used as pg underscore dump. You provide the DB name and then you redirect it to a particular location. Say for example, I have this is my uh, PG Postgre 12, and if I show you, I have DVD rental database over there that has 15 tables in it. And if I have to take the backup of this database, the easiest way is using the command using pg underscore dump. So how it works, pg underscore dump, the database name, hyphen v verbose if you wanted to see the output on the screen, redirect it to a particular file where it is going to store it. So you can see that it's been created, and if you wanted to see the content, you just go ahead and view the content using the VI or cat, whatever it is. So you can see that it is in the text format. PostgreSQL database dump, dumped from database version 12.5, started on this particular time, and it contains all the information for your database. Just to be remembering like this creates as soon as you fire it. So whatever the state of the database at that time, it is going to capture all that. So anything changing after that, it is not going to control. So pg underscore dump can create the files in other formats. You can increase the number of parallelism. You can have some more fine-grained control. If you wanted to see more, just say pg underscore dump hyphen hyphen help. It is going to show you all the details which you can do with this. The biggest part is what is the advantage when there are so many tools and technologies available for backing up the database, why pg underscore dump is still one of the best choice for backup and restoration. So the best part is it can be reloaded into newer version of PostgreSQL. Say for example, my current PostgreSQL is on 12.5, and the newer version, if you see it, it is on 13.51. And let us assume not really concerning to this environment, but what you can actually do is you can reload from a lower environment to the say for example lower version to the higher versions, or that is only possible using pg underscore dump. And while the file level backups, and there are two other, and which is the continuous archiving, they are specific to your server version specific. You cannot go beyond that. So This is the only choice when you have to transport your database across the version. You have to use pg underscore dump. And pg underscore dump is the only method which is going to work when you have to transfer a database from 32-bit to 64-bit operating systems. And the dumps which are created by pg dump are internally consistent. That means it is going to represent the snapshot at the data when the pg dump was started running. Anything which happened after that, it is not going to capture that. So you have to make sure that if you wanted a consistent snapshot, that means you have to stop the application interface facing it, so that nobody is able to access and modify it. There are pros and cons also. We are not going to discuss about that. But how to restore the dump which is being backed up using underscore, which is being backed up using pg underscore dump. The text files which are created by pg underscore dump, they can be only read by the program which is called as PSQL, and it is available in all the versions, and that is the way it is used for restoring the database in same host or different host. Say for example, we have uh, let's say we have taken a backup using like this, and if I wanted to restore it in our same host using some name, let's say if I say I wanted to restore dvd rental as dvd rental underscore restored one, what I should be doing is, and this is really related to the refreshes or the migrations. So you need to create that blank database and it is going to restore that. So it is going to give you the message that this database doesn't exist. So what you have to do is you just create this database. So you just say create a database and database name. Uh, If you just say /l, it is going to show you that database exists. And now you try importing using PSQL dvd rental underscore restored one, and it is going to be restored. So this is restored. So this is the simplest way of doing this. The pgdump and PSQL can be used to write or read from the pipes. That means in case I have two servers and if there is a connectivity, so that part is very, very important. If the two servers are connected, the ports are open for the connection, then in that case you can transfer the database from one host to another. That means you can restore the database from one host to another without transferring it using WinSCP or using the SCP command. So it will be done over the network. So you just say pg underscore dump. So this is a case. I have two servers. This is one which is PG11 EMS, and there is another server which is PG13 EMS. So if I wanted to transfer the data from one host to another, so what I will say is pg underscore dump hyphen h, the host name of the source server and the database name. Then you put it the pipe. Pgdump is this entire stuff is for backing up. Then there is a pipe that means redirect this output to PSQL-H. This is the target server and this is the target database. So once you do this, this is going to restore. We are not actually going to do it because the firewall ports are not open. The firewall is not open between source and the target. The moment you do this, this is going to be restored into the target environment. So this is going to be very, very easy and one of the convenient way of copying the database from one host to another. Or this is also used for refresh. You can put it in the cron job depending upon your requirement on the weekly basis. Whatever refresh requirement you have, you can use it using the pg underscore dump method. But this is only applicable when you have a single database or a specific database. In case you wanted to do it for the all the databases on the particular host on the cluster, so you will be using pg underscore dump all. So pg underscore dumps will be using for the one database. If you have to do it for all the database, you have to use pg underscore dump all. And one of the challenge with pg underscore dump is it is not going to dump the information about roles or table space because they are they are available on the cluster wise rather than the database. In case you have some roles and the table spaces for let's say for particular database, it is going, you have to use pg underscore dump all. So pg underscore dump all is used to back up all the databases. So if I simply say pg underscore dump all, and if I give the location and the name, it is going to dump all the information. So you can see all the cluster related information will be captured. So you can see that. So this is pg underscore dump all. It is going to dump all the informations which is related to. So it says PostgreSQL database cluster dump complete. It is not saying it is database dump only. It is whatever is there in the cluster wise, it is going to dump all of them. And to restore it, you have to use PSQL command. Program is used to read it and write it back to the database, so you can use it according to your requirement. The second in this case is the file system level backup, which is always considered to be one of the option when you talk about the relational database. So backup in this, what happens is you mention the location of the data directory. Let's say if my this is not going to be the practical one. If you say show data underscore directory, this is your data directory location. In case you wanted to do a file system backup, you can mention it like this: tar hyphen cvf. What we are saying, it is an impractical way of uh, doing the backup. This is not the practical way. It is never suggested, but this is one of the way. And in what scenario it can be tested, I'll tell you that as well. So the tar backup has been taken. What are the disadvantages of using it when you do this way, tar-cvf, or why it is supposed to be inferior as compared to pg underscore dump method? In this case, the database must be shut down in order to get a usable backup. Just if you say I have disconnected all the connections, it is not going to work, because in part because tar and the similar tools do not make an atomic snapshot of the state of the file system. So it also because of the internal buffering within the server. And you also cannot backup the restore only using certain individual tables or databases using the respective files or directory. So though it is going to happen in that way, but we cannot use it. An alternative file system backup approach is to make a consistent snapshot of the data directory. So this is not going to be practical, but this is a way available in case you can freeze your file system so that there are no changes, no buffering is available. In that case, you can try to use it. Make sure that you do the checksums so as to assure that it is a consistent cold sort of backup. You can use rsync as well in case you try this way. But this is not the suggested way, but this is an available option in case somehow you can freeze the file system for any type of read and write for the time being when you wanted to take a snapshot backup of that file system where the data is residing. The third one, which is the continuous archiving and point in time recovery, this is most famous one, and this is particularly for production environment. And back behind the scene, it is going to use your wall, which is write ahead logging, and it is the data will be available in the pg underscore wall, and this is available in your data directory. So this contains all the information which has changed in your database. So any insert, update, delete operations which is happening at the table level, they will be first stored in wall level wall files. And in case your database has crashed, you can restore your database using that. So when you take a continuous archiving and point in time recovery strategy, you do a file system level backup. When we say file system backup, it is this 1 second, but it is actually not that. There is an inbuilt tool which is given to take the base backup, which is called as pg underscore base backup tool. So what it does, it is going to read your entire data directory, assuming you have the table spaces also available over there. It is going to take a backup of the entire data directory in a format that can be restored using the untar way. So in layman language, we will say it is a tar backup, and when you restore it, you you restore it using the untar way in your data directory, and on top of that, whatever wall files they are available, you have to put it back. And when you are doing the restoration, you have to make sure that you restore all the wall archives so that you can restore it to a particular point in time, or whatever archives of walls are available, they you will be used for restoring the database. This is not straightforward. There are some parameters which are involved which you need to follow just to make sure that you restore it. So there is a complete session on that. You can follow that, and it is going to be very simple. So when you do the restoration using pg underscore base backup, and you use the restoration using point in time recovery, you have to make sure the permissions on the restored data directory is correct, and then you try to restore it, and then it is going to work. So this is one of the best way of backup strategy when you talk about the production environment, where you don't want to perform the pg underscore dump backup or pg underscore dump all, because whatever transactions are there in the database, you wanted to capture all of them. So you should be following pg underscore dump. You should be following pg underscore base backup, which is actually the third way of backing up your entire cluster, and that is called as continuous archiving and point in time recovery. So if you talk about all the three, so just a quick recap. So we have seen the quickest way of backing up the database, individual database, you have pg underscore dump. If you have to back up the entire cluster, pg underscore dump all is there. There is a provision for file system level backup also, in case you are able to freeze the data blocks or the bufferings that do not change. And for the production environment, wherein every transaction matters, you have to make sure that you archive all the transactions. So you have continuous point in time recovery method, wherein back behind the scene, you have to take the pg underscore base backup, and whatever the archives are there, you have to back up all of them. And during restoration, you have to use the base backup plus all the wall files which are available, and you have to restore your database up to a point in time. And this is going to be very important for your production environment. There are open source tool and techniques available, wherein third method will be available that can be used. So if you talk about pg underscore uh, a backcrash that can be used, you can use the barman. So they are really useful. So this is just about the basic concept of PostgreSQL backup strategy. I hope this is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will see how to backup and restore in PostgreSQL. So for backup in PostgreSQL, we have pg underscore dump, which used to take the backup of individual databases or tables. If you wanted to take backup of all the databases, you should use pg underscore dump all. For restoration, you have two utilities provided. One is pg underscore restore, which is used to restore the backup which has not been in text format. For restoration of the dumps which are in text format, you use pSQL. So let's see what are the different backup formats. You have the backup format in plain text, so you can restore it using PSQL. You can take the pg underscore dump backup either in custom archive, or you can use the tar archive, which is Linux format, or you can put it in the directory format so that you have individual tables separated. These are the different connection options. When you say simply pg underscore dump hyphen hyphen help, it will show you all the options. Hyphen f stands for the file name. You can mention the file name or the directory location. Hyphen f stands for the format, so you can mention the custom format, directory format, you have tar format, you have plain text. You can mention the number of the jobs in case you wanted to parallelize your backup, and your tar backup, you can compress it using the hyphen z option or hyphen hyphen compress, 0 to 9, 0 being none, and 9 being the highest compression level. You can mention the lock, wait, timeout as well. Then you have some more backup options. You can take the backup of data only. You can include blobs in your backup. You can exclude the blobs backup. And when you are creating the dump, you can mention hyphen c, small c. What it does, it cleans database objects recreating. So it puts the drop command. So hyphen c capital key puts the create command in the dump option. And hyphen n schema, you can mention the schema names which has to be backed up. And if you mention capital hyphen n, you mention the schema names which has not to be backed up. Then hyphen o, or no ownership, so you can skip the restoration of the objects in the plain text format. Hyphen s, you can mention the schema only, it takes the backup of the schema, no data. So hyphen a was just for the data, and it is for the schema only. Hyphen s, you can mention the super user username, which has to be used in plain text format. So you can dump the table name using the hyphen hyphen t table, and you can mention the table names or the pattern, whatever you like. And hyphen hyphen exclude also, if you wanted to uh, exclude the backup of some of the table or some of the table in particular pattern. Let's say they are starting with tab and something. You can exclude the privileges also when you backups. You just say hyphen x, it doesn't back up the grants and the revokes. There are different options. You mentioned hyphen d or hyphen db name. You mentioned the database name. Hyphen h, you mentioned the host name. You mentioned the IP address. Hyphen p is for the port name. If you have a non-default port, hyphen u stands for the username, which user is specified to take the backup. Hyphen w, when you mention, then your piece this backup command doesn't prompt for the password. Hyphen w, when you mention it, forcefully prompts for the password. Then hyphen hyphen role name, you mention the role name before the backup dump. Then you have the restoration command. What is pg underscore restore? It is used to restore the PostgreSQL database backup from the archive, which is created by the dump pg underscore dump. So pg underscore restore, these are the different options. Hyphen d, you mention the database name. Hyphen f, you mention the file name. Hyphen f in capital, you mention whether it is other than the text format, all will be picked up from here. So you have a custom format, you have D for directory format, T for tar format. Hyphen L, it mentioned the list. Hyphen V displays what is happening in the background when you take the backup or the restore. It is valid for both. If you wanted to restore just the data, you just say hyphen A. It restores the data and no schema. And hyphen clean, it creates the database objects. And if you mention hyphen index, hyphen hyphen index, it restores the named index which are mentioned. If you wanted to mention the number of parallel jobs, you can mention it. And hyphen L is either used to mention the file name, which is containing a number of tables. You can restore the database schema using -n command. If you want mention capital N, it skips the schema which has to be restored. Then you can restore the functions. You can, with small s, you can mention the schema only. With the capital S, you mention the super user name which has to be used. -t, you use it for the table name. Capital T, you mention for the trigger name. And let's see the demo. So I mentioned everything here on a notepad, and we are going to use it. So if you simply say pg underscore dump help, it will show you what are the different options available in pg dump. Or you simply say pg dump all help, it will show you all the options which are available. So let's quickly, it's very easy. So we are going with the first option, wherein we are going to create a PostgreSQL dump file, and we are saying pg underscore dump -v verbose, and the database which we are going to take backup is dvd rental, and this will be uh, dumped in this particular location. And we have mentioned -v verbose, so this will display what is happening in the background. So you can see that backup is getting created, and it is, if I go to cd slash postgre slash backup, you can see that backup file is created in this format. So let me remove everything. Okay, let me remove dvd stars, everything. Let me execute the backup once again. Pg dump -v dvd rental. So this is going to take the backup of dvd rental database. And if you wanted to see the content, you can see either use some editor, or you just say view command. So you can see that it is a Postgre database dump. Database version is this one, and this will create the database in the format. Let's try out the second command, where everything remains safe. Say instead of giving this arrow mark, we just give the -f, and we mention the complete location of the file which has to be created. You can see that it is getting created. It's very, very easy. And if I say pg, if you wanted to take the backup in the tar format, so I'll say pg dump -v verbose. So this will print on a screen. And if I say -u, who's the user who is going to take the backup? It is Postgre. -w in caps, it will prompt for the password. -f, this is a format, and it is in text format, plain format. And sorry, -f, then I am saying T, this is going to take the backup in the tar format. And for which database? It is for the dvd rental database, and this will be the tar file which will be created. And let's mention the password. So this is going to create the backup in tar format. So this is the tar file which is created. If I have to restore the backup which we have taken for the dvd rental, and first you have to create a database which is blank. So create dv-t, from which template 0 and 1 are available, and the database which we are going to create, blank database, it is restored underscore dvd rental. It already exists, so let me create dvd rental 1, dvd rental underscore new. Let's say dvd rental underscore new. So I'll say the database name is dvd rental underscore new, dvd rental underscore new. It also exists. Dvd rental now. So it is getting created. It is created. So dvd rental uh, we created DVD renter underscore now. And we are going to restore the backup in this particular database. So we'll simply say PSQL, new database name, inverts arrow, and the location of the dump file. And just mention the verbose if you wanted to see what's happening in the background. So this is happening. So it's very, very easy. If you wanted to take the backup of all the databases, we are going to use pgdump all. Pgdump all, and let's say verbose. I think it is going to work. So you can see in the verbose format in the screen, everything is getting displayed, and it is going to take the backup of all the database. And if you wanted to take a backup of a specific table, then also you can mention. So the format for that is pg underscore dump. I wanted to take a backup of payment table, which is there in uh, in DVD rental database. So pgdump hyphen f, which is the format. It is in custom format. Only we are taking the backup of data. Hyphen u is username. Hyphen w stands for it is going to prompt for the password. Then we have database name. Then hyphen t. Table name is payments. And just mention the password. DVD rental, I think, not rentals. Yes. Or let's remove it, and we will back it up using the verbose command. pgdump -v verbose, and enter the password. Then you can see that payment table has been backed up. If you have to restore the database of the particular table, what you have to do is you have to truncate the table, then restore the data only. It's very easy. Let's see some more example. To dump a database into a PL SQL script, we have seen that, and using the format also we have seen that. If you wanted to do it in a custom format, we can use this for the particular database. Let's try this one, although most of them has already been executed. So this is pgdump -v verbose -f format. C is -f is file, and C is the custom format, then the database name, and just execute it. To dump a database into a directory, we use -d command. So let's do that. And let's try this. Let's go to, I think it is executed. And you can see it has executed now. It's in the directory and subdirectory structure. To dump a database into a directory format in parallel with 5 worker jobs for worker jobs, let's try this one. pgdump -v -f is the format. Then we have the directory format, then this database name, and these are the number of workers. If it is more, then you can mention it, and you can compress it as well. So -f, it's executing. You just need to know what you are doing. Then to create an archive into a freshly created database, let's create a new database, restore database, DVD rental underscore new. Let's try this one, or let's say it as new one. I hope this doesn't exist. Yes, and then restore it from the backup which we have just taken. So it is pg underscore restore hyphen d database name and the dump name. This is done. I'm not going to check it because if it is not doing it, it will show you the error. To reload an archive file into the same database it was dumped from, then it is going to discard, it is going to clean and create it. A pg restore underscore hyphen d. Then let's try this one. We'll put the verbose. You can see that it is creating again. And if you have to dump a single table, which we have seen earlier as well, in the text format, we can use pg dump, and this is done. If you wanted to see the content, you can quickly see it. This is the text and readable format. So this is all about the different options available in Postgre backup and dump. And I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG underscore base backup and how to use it, and we will see some of the examples as well. So first of all, what is PG base backup? So we have a couple of backup utilities in Postgre. So we have PG underscore backup, then we have PG underscore backup all, and there is something called as PG underscore base backup as well. So when you wanted to take a backup of a running PostgreSQL cluster, you have to use PG base backup. If I wanted to take a backup of one database at one particular time, or n number of databases, or all the databases, I have to use PG underscore backup or PG underscore backup all. In case I wanted to take a backup which can be used for point in time recovery, that means I wanted to take a backup of the entire cluster of Postgre, then I have to use pg base underscore backup, so that all the files which are there in the cluster, they will be backed up. So this kind of backup is mainly useful for log shipping or streaming replication, or you have to create a standby database, or in case you wanted to restore your database at a one particular point of time. So when you take a PG underscore base backup, it is a binary backup of your database cluster files. This cannot be used for the single database. In fact, this is used for the entire cluster only. So who can take the PG base backup? So any user who is having the a super privilege, let's say the super user or the Postgre user who is having the super user privilege, can take the backup, or you have to create a user which have the permission to take the backup. And when you configure the PG base backup, you need to modify PG underscore HBA.conf as well, so that the replication connection can be allowed. Although there is, in case you just wanted to take a PG base backup, you don't need the replication, but this is required. And in the demo, we will see how to do that. So most of the time when you do it, you do it either for taking a point in time recovery purpose for the data entire cluster, or you have to create the standby databases. So what is the usage? The usage is PG underscore base backup, and then you have a number of options. So we'll see what are the different options. So you have something called as pg base backup underscore d. That means you define the directory or the location where the backup will be stored. So this receives base backup into the directory. Then you have -f, which says which format you want it to take. There is P and T. P stands for the plain text, that means you can read it, and T stands for the tar. The file will be tarred in the Unix format. So you have something called as -x, which means do you want the val files as well, which is required for your recovery. Val is so in one of the tutorial we have explained about it what is val. So this is required for your recovery and it has all the information. Val is nothing but it is write ahead log. So you have -x. -x small is whether you wanted to take a backup of val files, then in what mode you wanted to take it. Either you say fetch or the stream. When you say fetch, after the backup, all the files will be fetched of val and stream. When you wanted to take when you configure a standby database, that means continuously you wanted the val files to be shipped across. Uh, you can zip that as well. So -z is used to compress the tar output. So this will help you to save some storage. -z it tells to what extent you will be able to compress. So compression algorithm will be applied. The value lies between 0 to 9, 0 being not compressing and 9 is the highest. So most of the time when it is a big database, you want it to the database size is more, or the cluster overall cluster size is more, you wanted to use the compression level, but make sure that this compression is done during the off business hours, or it is going to take a lot of CPU from your system. Then you have -l, which will set the leveling for the database. Let's say I wanted to say daily uh, PG base backup or weekly or monthly. So you can level it and you can read it later. So -p stands for the progress. In case you wanted to see if it is a database size is more, you would like to see how it is progressing. So you can mention -p. So it will show how much it has been backed up and what is the way it is going. Then you have -verbose. So when you fire PG base backup and the backup, you don't see any kind of output. You just press enter and it will come out, and you don't know whether it has happened or what was the progress. So you can use -v, which is verbose. So on the screen it will show you how it is moving. Then you have -version that will show you the version information. Then if you wanted to take a BG base backup from remote server, then you have to mention where your instance is running. So you have to mention -- host equal to the IP address or the host name of the PostgreSQL server. Then the port, if it is a default port, it is fine. If it is non-default, then you have to mention the port number as well. And in case you wanted to see the time interval status packet which is sent to the server, you can mention -s. And if you are using if you are using a user other than Postgre, which should be used because Postgre is not supposed to be used for such operations. Once in a while you can use that, but if you have to configure a backup, then you have to use a different user. So in our demo we will see that. -w, it will now not prompt for the password, which is not good. We will use the password, so we have to use -w, which will forcefully allow us to input the password. And I think this is more than enough about the introduction, and now we will see how the demo is going to work. So I have a Postgre server which is running on 192.168.1.61 Linux system, and I have a Postgre 12 running on it. So let me show you that. sudo systemctl status PostgreSQL 12, and I'm logged in as Postgre. We'll see what are the different steps. So in the prerequisite, what we will do is we will create a role which will take the backup of the entire cluster. Then using create username with the password, and in the encrypted format we'll give the password. Then what we have to do is we have to add that particular user in pg_hba.conf file to allow the backup. So that will give the host replication, because there is no database with the name replication, but this will be used either for the replication or taking backup of the entire cluster, and the username followed by the IP address from where you wanted to take backup, and then subnet. Then we wanted to enforce a password prompt, so this will do that. Then we have to we will check that whether it is entered properly or not. Then we will reload the configuration. Then we will fire the backup. So let's log into pSQL prompt. So you can see I'm already logged in as to the prompt. Okay, I have already created a user with the name replication user. So let me drop that. Drop role replication_user. Yes. The first step is we'll create a user. So we will say create user replication_user with replication. With replication means this will have the replication privileges associated with that, and then we will give a password. So this is a demo, that's why I have given the password as password only, but that should not be the case. And just say du, and it will show you the role which is created. So we have created the role replication_user, and as a prerequisite, this should have the privilege of replication. So it is having that. In the next step, what we will do is we will add this role to pg_hba.conf, so that backup it has the ability to take the backup. So let me go to pg data. So I'll exit off this prompt, and we'll say vi and pg data, which is the base directory, then pg_hba.conf. Scroll down to the bottom, and we have something called as replication privilege. So you have to add in this section. So it should be like this: host, then database. You can see it is under the section database, but there is nothing like replication database. This is required because this should have the replication privilege. Then the username. The username is replication_user. Then the IP address. IP address is localhost only, but if you wanted to have it from many other servers, then you have to give the range of the IP address, and then I'll give MD5. And I added this earlier as well, but just to show what are the different entries we put. So we'll have to give host, then replication. That means it has the privilege of replication. Then the username, then the IP address or the range of the IP address, subnet, then the what authentication method. So we will give MD5 over here. Now after that, you have to reload this. So we'll say uh, okay, PSQL-C, select pg reload underscore conf. Just reload this. Yes, this is done. Now what we will do, we'll see a basic demo wherein we'll say pg base backup hyphen u replication user hyphen d, and let me show you the pg underscore base backup hyphen hyphen help. So you can see that pg base backup takes a backup of a running PostgreSQL server. And what is the usage pg underscore base backup hyphen options? Then we have hyphen d, which stands for you mention the directory location. Then hyphen f, you mention the format, whether it is plain or tar. Hyphen r, you mention the rate at which the transfer has to happen. Then you have table space mapping in case you wanted to map it. Then you have the location of the val directory. Then what kind of val method it has to extract, whether it has to fetch or it has to stream, whether you wanted to zip the backup file, or to what extent you wanted to compress it 0 to 9. Then you have, these are the basic stuff, like you do the checkpoint, otherwise it will do it automatically. You create the slot, it create slots when it starts. You set the label, and you set the if you say hyphen progress, this will show you the progress. Or the connections options are if you are doing it from a remote server, you just say the host name, the port number, then you mention the username, whether you wanted the password or no password, so everything will be mentioned. So let's perform the first demo. So we wanted to use this particular location as our destination for the backup. So let's go to this location and remove if there is any data. There's nothing. This should be owned by the current user. My current user is Postgre. And we'll say pg base backup hyphen u. The username is replication underscore user, and hyphen d, and the destination. So this is a very basic backup of pg base backup. Just press enter, and this will prompt for the password of replication user. So we mentioned password as password only, and it is happening in the background. If you go to this location, you will see that the files are backed up now. So these are the different files, and this is the same file which is there in PG data. So let me open one more session, and I'll just say sudo su space minus postgre, and I'll do cd dollar postgre data. This will take me to the default data directory location, and if I do cd to this location, you will see there are so many files. So if I say ls-ltr and count the number of files, you have 27 files. And when we took the pg base backup, you can see everything is here. So if I say ls-lrt wc-l, you can see almost equivalent number of files are there. So if you see pg underscore val is here, and if we go here, so you can see pg underscore val, pg underscore two phase, pg underscore two phase. So whatever was there in the data directory, everything, including the configuration file. So this location is my uh, uh, backup location where we have just taken the PostgreSQL backup in the text format, right? So everything is here as it is. It has taken the backup of pghb underscore conf. It has taken the backup of postgre.auto.conf. It has taken the backup of postgresql.conf, and everything pg back underscore version, pg underscore table spaces. So everything it has taken. So that's the advantage of using pg underscore base backup. It takes backup of everything along with the val, which is write ahead log as well. So we saw that pg underscore val. If you include that, it will take that as well. So here it is. If you do cd here as well, it will show you it has taken the backup of that as well. Now let's do one more um backup, where in what we will do, we will tar it. We will take a tar backup. So let's go to cd and let's remove everything from here. The backup which we had taken rm minus rf, and we have deleted the backup now. Just say ls-ltr. There is nothing, and this is the backup location. What we will say now is pg base backup, the utility name, -u, username, -d, the destination, and then these. Okay, I was supposed to show you the progress as well. So let me execute the backup once again using the same command. So pg base backup -u username -d directory. So this was, if you don't mention anything, so this is going to be the default text base backup. If I say just -v vervo, so this will show you the backup status on a screen as well, like what's going on. So if you see that it is initiating base backup, writing for checkpoint to complete, checkpoint completed. So when you see this, I think it makes more sense instead of just you press enter and it gets completed. So let's remove the file over here. So I'll just remove everything from this directory. Now in the second mm, demo, what we will do, we will perform pg base backup -u username -d directory, then -f, that is the format. If you wanted to use text format, you can do that, or you can take the tar back. Sorry, it is tar backup only. The first one was hyphen plain formats. If you don't mention, that will be plain. So this one we are going to take tar backup -z. We are going to zip this -p. This will show us the progress as well. So just press enter and feed in the password. So you can see it is showing you the percentage as well. If you wanted to make it more, what do you see, the informative, let me remove it once again, rm minus rf. You can see that there is base dot. So it has taken the two backup. One is base backup, another is for the wall files, which is write ahead log file. So it has taken it in two different zip folders, zip. Yeah, a zip file. So let me remove everything from this location. Now what we will do, we'll fire everything same with the -verbose. Feed in the password, and you can see that along with the percentage, it is showing on what is going on. Although though it is a very small database, but in the bigger environment you will be able to see the difference, like what all is going on, and with what speed it is moving on. The -p is for the progress only. And if you wanted to do it from a remote server, you can do it. You mention the -h, the IP address or the host name, then you mention the port name also, so you can do that way. This is just a basic introduction and how to use the PG-based backup. So what we did is we created a user. So just a recap. First we created a role replication underscore user, and we given it the replication privilege. Then the second important step is you have to add that replication underscore code user in pg underscore hba under uh, pg underscore hba dot conf, so that it can take the backup. So that will be in the last option where replication is mentioned. So host, this is not the database name, but this is the privilege. Then this is the username, which is replication underscore user, and then from which IP address. If you wanted to give take it from the other, you can mention the IP address of that, and then PG MD under MD5. That is, it will prompt for the password. And then we reloaded the configuration. Then we took the backup, and there are different options which we have discussed. I hope this is going to help, and mostly this is helpful when you do restore the point in time restoration on the same server with the WAL files, or onto the different server when you create a standby database, a standby server, or a streaming replication. So in those scenarios, it is useful. I hope it is going to help, and thanks for watching. Hello and welcome. In this session, we are going to learn how to upgrade Postgre from lower version to higher version. This is not the demo, this is just the theoretical way, like what are the different strategies available to upgrade Postgre from lower version to higher version. So normally there are three types of strategies available for. In our case, we recently faced some issues with upgrading Postgre from lower version to higher version. That was Postgre 10 to Postgre 13. So in general, there are three ways to upgrade your Postgre. Say for this example, so the best way is when you are upgrading, you just go with pg underscore upgrade, which is the suggested way of upgrading Postgre 10 to Postgre 13, or it may be something else in your case. There is a second way wherein you can upgrade your Postgre from lower version to higher version using pg dump all. In this way, you will just take a backup from source and you will do it on the target. The third way of upgradation is via the replication way, wherein you will do the logical replication from one version to another version. So there's some basic about the database version detail in Postgre. So current Postgre version number consists of a major number and a minor number. Say for example, there is Postgre version 10.1 or 13.4. Let's say, then the first two digits represents the major number, and the last digits represents the minor number. So minor release never changes the internal storage format, and they are compatible with uh, earlier minor releases. Let's say I have 12.1, 12.2. In that case, the compatibility will not be changed because of the minor version change. So there will be a change when we go from one major version to another major version. Let's say 10.1 to 13.4. That's a change in the major version. So the storage, what do you say, the compatibility and other features are going to change. So that's about the major and the minor version. Let's talk about the upgrade speed and complexity associated with the upgrade. Since it is an open source database model which is available, so whenever a new version is available, and if it is a staple, then the community goes and try to upgrade and take the advantages of the newer version. The fastest way of upgradation is using the pg underscore upgrade out of the three upgrade facilities which are available. The traditional way, which is using the backup and restore, is always considered to be the safest way of upgrade. And recently we faced an issue wherein we have taken that approach and we have moved the data using the PG dump all method. So out of the three, when we say about PG underscore upgrade, wherein it is going to do the in-place upgrade, so whatever is available, it is going to upgrade that, and it is the fastest way of upgrading your Postgre from lower version to higher version. So how does PG underscore upgrade works? The PG underscore upgrade tool, which is available in the newer version as well as in the lower version also. So if you have to upgrade from lower version to higher version, this utility you have to execute from the higher version so that it can upgrade from lower version to higher version. So this is the way it works. So PG underscore utility will be available in the bin directory, which is, let's say I have an example. I'm trying to upgrade from 9.6 to 10, which is the change in the version, change in the major version. So when we say PG underscore upgrade, you mention the hyphen hyphen old data directory, you mention the location of old data directory, you mention the location of new data directory, you mention the location of old binary location, and you mention the location of new binary location. And when you do this, you always make sure that you specify user and port number so that it can connect to the proper database. What are the prerequisites when we are taking the upgrade strategy using the PG underscore upgrade? You should always take a snapshot of virtual machine, because most of the time we this is very frequent, and if you have the extensions available, then they will not directly allow you to upgrade using PG underscore upgrade utility. Let's say you have using a foreign data wrapper, and if it is there in your lower version, and if you use PG underscore upgrade, it is not going to allow unless or until you drop the foreign data wrapper extension in your source. And it is not just this extension. If you have, let's say, 100 of extensions in your source environment, then it may be difficult, because it will always ask for some of the conflicting extensions to be dropped. The second one is in terms of the prerequisites. It is when you are trying to upgrade, it always make sure that you take a complete backup using PG underscore dump all, or if you are using PG underscore base backup, if you are using that as a utility to backup your database environment, then ensure you have the proper backup in place. And you have two levels of rollback plan. One is at the virtual machine level, wherein you can restore within few minutes depending upon the size, and another is you have to take a backup using uh, the the PG underscore dump all. And let us see, I have already mentioned it on the notepad. So upgrade strategy, if you are going to use PG dump all, therein, let's say in this demo, when we do it next time, we are going to create two instances. One is for Postgre 10 and another is for Postgre 13. So once you do the installation, what you have to do is, for this particular demo, what I had done earlier is, in Postgre 10 or Postgre, let's say 11, whatever you wanted to install, insert some sample data. Insert some sample data, and then you on the same server, because you're going to do it on the same server for Postgre 13, you install the binary of Postgre 13, and the only thing which you have to take care is, because on both, whether it is this system or another system, the port has to be different. The older system would be running, let's say, on 5432. You make sure you give some other, otherwise it is not going to allow to execute your Postgre 13. So you run it on different port, let's say 5433, and when you are connecting, make sure you mention the port number. If my port Postgre 10 is running on 5433, 5432, you mention PSQL-P 5432. And if you wanted to connect to Postgre 13, then you mention 5433, whatever your port number you have mentioned. So for demo environment, what we had done is in our lower environment, we inserted some data. PSQL-P 5432, it is connecting to my Postgre 10 or 11. Then we have imported some DVD rental data inside that, and then we had taken a backup just to simulate it. And finally, what we had done is we stopped the Postgre 10 because we have extracted the data from there, and we connected to Postgre 13 using PSQL-P 5433. And then if you can check the version, you can check it over there. And when you are going to import it, use PSQL-P 5433, and then you import the data. The side by side upgrade is always supposed to be the safest way, because you are not going to change anything on the source environment. In our case, when we face this situation wherein we were supposed to drop the extensions, we did not do it. We, in spite of that, we went with the other way, wherein we wanted to keep the source intact in case there is some problem. Though we had a virtual machine snapshot, we did not go with that. And then we had gone with the side-by-side upgrade using the traditional way, which is backup and restore, so that at one particular point of time we have both the environments available for testing. In case the application team assumes the newer upgrade system is not valid, then we are always in a system to roll back it without restoring the snapshot of the virtual machine, or without restoring the backup, which is the logical backup which I had, pg underscore dump all. We didn't go with that, and we had this system up and running. This is the safest way, where in side by side upgrade you have it. And if you wanted to go with the PG upgrade, which is the fastest way of upgrading from lower version to higher version, and this is the command which you have to execute. PG upgrade, you have to mention the location of the old data directory, new data directory, the complete location, old binary directory location, and new binary directory location. So it will appear something like this. This is the location of newer version of upgrade utility, old data directory, new data directory, and when you say -c, it is going to check whether everything is uh, met, all the conditions are met for the upgrade, and then you start the upgrade without -c. It is going to upgrade your entire Postgre 10. And once it is done, what you have to do, it will allow you to start the Postgre on your newer system, and then it will ask you to stop the Postgre lower version. So the only problem with this way is most of the time when you have the extensions installed on it, it is going to show you that you drop it on the source environment. So sometimes it may not be advisable to do so, because we wanted to retain both the systems in case we have to roll back. And finally, when this PG upgrade utility goes successful, it will allow you to drop the older cluster. So there is another way also, which is called as the logical replication, where you can replicate your data from source to target environment. So that's all about the conceptual way of upgrading it. So you have the three ways. You have the safest way of upgradation using PG dump all. You can do it using PG upgrade, which is fastest. In case you wanted it to for the continuous replication because of the downtime constraint, then you have to go with the replication way. So PG dump all, when you're doing it, it is a complete downtime. PG upgrade also, you have to shut down your source cluster environment. And if you go with the replication way, then it is a continuous replication, and your downtime will be minimized. Though we did not do the demo has already been performed in previous sessions, so you can refer that. And in some other demo, we'll try how to upgrade uh, lower version to higher version, let's say from Postgre 12 to Postgre 13, using the replication. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to upgrade Postgre lower version to higher version using PG underscore upgrade utility. So first, let's understand what is PG underscore upgrade utility in PostgreSQL. So PG underscore upgrade utility is also known as PG underscore migrator in earlier version of PostgreSQL, and it is a utility which is used to upgrade the Postgre instance from lower version to higher version. Let's say if I have to upgrade my Postgre instance from 10 to 12, I can use PG underscore upgrade utility. So PG underscore upgrade utility supports upgrade from 8.4 dot star version to the latest version. The current version is 12 and 13th is the Vita version. So this particular utility, PG underscore upgrade, is not applicable for minor upgrade. That means if let's say if I'm on 10.1 and if I wanted to upgrade it to 10.2, this is not valid. So this is a utility which is used to upgrade from lower to higher version, and let's see how it is used. PG underscore upgrade. If you say PG underscore upgrade hyphen hyphen elf, you will see the different options. The first option is hyphen small b, which represents to the uh, uh, older cluster having the executable location. If I say capital B, that means the new cluster executable location. If I simply say hyphen C, it means I can check the status whether this particular PG underscore upgrade can upgrade from one version to another version or not. Hyphen small d represents the data directory of older cluster. Hyphen capital D represents for the data directory of new cluster. And some other important parameters are hyphen small p, which represents the port number of older cluster. Hyphen p represents the port number of new cluster. You can mention the username if there is a some other user other than Postgre. You can mention that. Hyphen v is used to for verbose. You can see the proceedings on the screen as well. So how do we use the PG underscore upgrade utility? So what we have to do before running this utility, you have to create a new cluster, and you have to instantiate it using the initdb. And once you instantiate the new cluster, in our case, the demo which we are going to perform is from 10 to 12 upgrade. So there will be one instance of PostgreSQL 10 and another will be PostgreSQL 12. So we will upgrade from PostgreSQL 10 to PostgreSQL 12. So you have to shut down the older instance, and you have to shut down the new instance as well before we use this upgrade utility. So what happens in the background when you use this utility? So what it does, it copies the data from older data directory to the newer data directory. And since there will be two cluster, one will be on 10 and another will be on 12. So you have to make sure that you give the exact location of data directory of old location, new location, binary directory location of old environment and the new environment. So this is how do we use the PG upgrade hyphen D. A small d represents the older clustered data directory location. Capital D represents the new data directory location. and then a small b represents the bin location of older cluster, capital B represents the bin location of a new cluster. So let's see the demo now. And the demo which we are going to perform is like this. So in the demo, what we will do is we are going to upgrade PostgreSQL 10 to PostgreSQL 12 on RHEL 7.5, and we will be upgrading one database, which is DVD rental, or it is applicable for all the databases which are hosted on the older cluster. So let's perform it. So I have listed all the steps here in a notepad. So we are going to execute this. This is a step-by-step procedure to upgrade PostgreSQL 10 to PostgreSQL 12. So I have a Linux system. The IP address is 192.168.1.56. I have the root access and I'm logged in as Mova Extreme. So in this step, first I'll check whether I have the internet activated on my system or not. So I'll just say ping google.com. So this is working fine. In the step two, it is everything from the beginning. So I'm going to install um, the PostgreSQL 10 version. So yum install PostgreSQL 10 hyphen server PostgreSQL 10. So I'm going to install this. This entire demo is going to take at least 10 to 15 minutes. So once we install this, we have to instantiate it. Yes, the packages will be downloaded. It is very, very fast. The next step is we'll say PostgreSQL 10 hyphen setup space initDB. This is going to initialize the database, and your data directory will be created. This is done. Once it is done, you just switch to Postgre user sudo su space minus Postgre, just clearing the screen. Once it is done, you just try to start it using sudo systemctl start PostgreSQL 10. Once it is done, just check the status sudo systemctl status PostgreSQL 10. You can see that it is in running status. Now let's load sample data. So I have a database in copied here in all.sql. So I'm just going to import that. Once it is done, we'll log into Postgre prompt and we'll see what is the database hosted over there. So I have a number of databases. Mostly it is DVD rental. This just to showcase like how this database will be migrated from, upgraded from 10 to 12. Just say PSQL, and so I have DVD rental, uh, DVD rental underscore new, DVD rental underscore now, restore DVD rental, and there are so many DVD rental databases. So I'll just quit out of this, and then we will go to the step 3. Um, so we have performed 2 steps, and now we are going to install the newer version of PostgreSQL. So in this, we are going to install PostgreSQL 12. So this has to be done as the root user. So we'll say yum install PostgreSQL 12 hyphen server, and this all will be mentioned in the command section. It's very, very easy. And just say yes. So this will be downloaded. Once it is downloaded, you just have to go to the complete location of the binary location, and then you have to execute it, because you have 2 clusters now. One is on 10G and another is on 12. So usr slash pgsql 12 bin postgresql 12 hyphen setup initdb. So we are going to initialize it. Once it is initialized, what we have to do is we will switch as the Postgre user, and we have to start the new instance of Postgre, but this is not possible on the default port, so we have to change the default port of 54322 to some other value. So what we am going to do is, so we are going to add it the PostgreSQL.conf of 12, PostgreSQL 12, and we'll replace 5432, which is the default port, to the new port, because you cannot run two instances on the same port, so you have to change it to some other value. So I'm giving 5433, this is the newer port, and then we will restart the PostgreSQL. Just starting, and then check the status. So you can see we have it is running. Now we have two instances running as PostgreSQL. So check instances are running or not. So we will say ps-ef grab Postgre postmaster, which is the main background process. So you can see one Postgre master is running out of pSQL 10 and another from 12, and the data directory are different. Now, using the pgctl, we have to check the status of both the cluster. So we'll say pgctl, and this has to be from the PostgreSQL 10 version, and then we will give the location of the data directory and then just say status. So you can say that pgctl server is running. Then similarly, we'll do it for 12. So you just make sure that you give the location of your 10 and 12 PostgreSQL respectively. So this is also running, server is running. Then what we are going to do is we have to stop both PostgreSQL instances. So using the pgctl only, we have to stop it. So pgctl-d data directory location, and I'll just say stop. So the PostgreSQL 10 instances is stopped. Now we are stopping the PostgreSQL 12 instance. So pgctl-d and data directory location, and then stop. It is done. Just check the status using the status command instead of stop. We'll just say status, it is not running. We'll similarly check it for 12. You can see that it is not running, so both are not running. We can check it from the background process, which is ps-ef grab postmaster. Just execute it, and there you can see there is no output. This is just reflection of the command which we executed. Now we will check if the cluster is ready for the upgrade or not. So I'll explain the what is this all script is about. So this is PG upgrade, which is from the newer so /usr pg-sql 12 bin. The PG underscore upgrade is from PostgreSQL 12 hyphen old data directory. What is the location of old data directory? Or the location of old data directory is this one. Hyphen new data directory. This is the location of PostgreSQL 12. And then we will give the location of old binary location of PostgreSQL 10. So this is USR PGSQL 10 hyphen bin. Then we will give the location of bin directory of PostgreSQL 12. Hyphen C is just to check whether our cluster can be upgraded or not. So you can see that checking cluster version, then checking database user is install user or not, then it is checking the connections, whether it can connect to both the instances or not. Then it is checking whether clusters are compatible, whether it can be upgraded from lower version to higher version, that is PostgreSQL 10 to 12. So everything is fine. So now we will invoke the same command without the without hyphen C option. So that means it is PG upgrade. We have given the location of old data directory, new data directory. We have given the location of old binary directory, and we have given the location of new binary directory. So the first option will be for the existing environment, and the next will be for the new environment, and just press enter. So this is going to take a few minutes depending upon the size of the database. You can see that creating dump of the database schema. So it is taking all the databases one by one, and this will copy and paste from PostgreSQL 10 to 12. So behind the scenes, it is doing a number of things. It is analyzing, it is restoring the objects from from lower version to higher version. So it has created two scripts to analyze the new cluster if in case you wanted to analyze it, and the another script is used to delete the old cluster. What we will do now is we will start the new cluster. Let's stop it first. If it is started, we'll say pgctl-d and data directory location and stop. It is not running, so we can say either start it, or if it is not starting, what we will do is we will change the server status is running, and sometimes it creates the problem. And what we have to do is in PostgreSQL.conf we have to change the port number. So the port number, let's make it 5432 as it was there in the older what do you say, the PostgreSQL 10. So let's start it, stop and start again, and we'll try to connect. It has stopped. Using the pgctl again, start it. It has started. Let's try to log in. PSQL, just says -l, and you will see all the databases: DVD rental underscore new, then now, and there was a user also, which is user2 underscore remote. If something is not migrated, that it will show you like user run this script. So we are not going to analyze it now, and I just wanted to keep it for some more time, the older cluster, and if you don't need it, you just go and delete it. Quit and delete the older cluster. So we have a new cluster now. So I'll revisit what we have done is in our demo we installed PostgreSQL 10. We initialized the cluster. Then we imported some data which was having DVD rental database. Then we installed newer version of PostgreSQL 12. Then we changed the directory from 5432 to 5433 because we cannot run two instances on one port. Then we started the PostgreSQL 12. Then we stopped both the servers, PostgreSQL 10 and 12, using pgctl command, and it has to be from respective binary location. Then we, using the pg upgrade command, we mentioned the location of old directory of existing environment and new environment. Then we mentioned the bin directory location of older environment and newer environment, and we mentioned the -c to check whether the cluster can be upgraded or not. And finally we fired the same command without -c, and we upgraded the cluster within no time because the data was very less. Then we started the new cluster. We changed the port from 5432 to 5433 to 5432, and then we verified if the database is copied or not. So this was all about the PG upgrade utility to upgrade PostgreSQL 10 to PostgreSQL 12 on RHECL 7.5. I hope this is going to help, and all the commands will be there in the comment section. And thanks for watching. Hello and welcome. In this session, we are going to learn how to migrate Postgre database from one server to another using pg dump all. So I have two servers already with me, and the source server The IP address is 192.168.1.113 and the target server is 192.168.1.116. Both of them are already having the Postgre version 13 installed, and as a prerequisite, since this is a lab environment and we have already disabled the firewall and SE Linux is disabled, and the password of Postgre database user has been set to password, and the database can be accessed remotely. I will show you what is there and then we will start from there. So this is my source server having the IP address 192.168.113, and you can see on the listen address this is the IP address. On the target side also, this is the target server which is having the IP address 116, and if I just check the PostgreSQL.conf file, the IP address is set to listen_address. That means they can be accessed remotely with one more setting. If you just check your uh, hba.conf file, you will be able to see that. This is my pg. It should be pg_hba.conf. So I have mentioned that the IP address in this range, they should be accessible. So from my laptop also, which is having the IP address in this range, so I will be able to access it. And the same goes for the source as well. So I'll just show how it is. This is required in order to ensure that we are able to access it remotely. You can see that configuration is also over here. I think it's here. Yeah. Okay. Now what we are going to do is we are going to take a backup of all the database from the source and we will transfer it to the target and then we will restore it over there. It is very straightforward demo that we are going to perform. Okay, so let's begin with it. And the first thing, which there are a few prerequisites that you can check out, like finding the size of the database. What I have done in advance is I'm already connected to pgadmin using to the both the source and the target server. So I'll show this is my source 192.168.113 and the target is 116. So if you go and just check this source database server, this is how it is. Okay, let me go and connect to the source database server in Postgre database, and what you can do is you can fire few commands to find out the size and other details. So what you will do is just replace the database name with the databases which are there on the source side. So I have several databases: demo, DVD rental, DVD rental underscore 2, 3, 4, 5. So just if you wanted to capture all these details, so I'll say DVD rental. So it is DVD rental. So I just check the name, DVD rental. Just checking the size, and we will cross verify this should not be available on the target environment. Okay, let's execute this. You can see there are 1, 2, 3, 4, 5, 6 databases. Just I'm trying to execute because this will be required. There's 15 MB in size, so they are replica of each other, these databases. So somewhere around 60, 70 or 80 MB of data is there on the source side. On the target side, which is my 116, you don't see any database, right? This is just the default Postgre database. So you can capture all the details from here. So you can list down the databases on the source. Using the command prompt, it is easy to do. You just say PSQL, list down the databases like this. You can see there are 9 rows. There are 2 template databases. One is default Postgre databases, and these are 6 databases which are user created. Or you can fire this select DAT name from PG underscore database. That will give you the details of the database on the source side. Also, you can find out all the schemas on the source side. You need to record all these when you're doing the migration, just to cross verify when you are already on the target, just to cross verify everything is fine or not. Or you can find all the details of the individual objects on the source side using this command, and this will show you how many uh, default, non-default, and count of the objects are there. Okay, so and you can list down the users. I believe I have not created any user other than the default one, but if you create, you will be able to capture that. So by default, it is just the Postgre on the source side, and you can find out if you have any extensions deployed on the source side, and the target I believe it is already not set up, so we just installed the binaries there only. And the first thing which we are going to do is we are going to backup of the databases on the source side. So we'll say, and the location of the file system where we are going to store on the source side is postgre/backup, and the same location we have on the target as well. This is not mandatory. There's just we have it. So I'm just going to take backup of all the databases on the source side. Just exit out of the Postgre command prompt and just say pg dump all, and this should be done any moment. So once this is done, you have to transfer. So if you see this ls-ltr, this backup file will be created, and you need to transfer this from source to target side using the SCP. Okay, so what I'm going to say is SCP it from the source side and transfer it to the target. So let's navigate to that location cd, and if you say ls-lrt, you can see all.sql, and we will SCP it from source to target side. Target is 116 IP address. This is the username, and this is the location where it is going to copy. I'm just saying yes, I want to continue. Give the password of Postgre on the target side. It is, I believe, password only, or Postgre. Yes, it is. Let's go to target side. First of all, let's try login using PSQL. Yes, we are able to log in. And now navigate to the location where you have copied the, we have copied it to this location, all.sql, you can see. And if you say psql/l, this is going to list down all the databases. So you have just 3 default databases, and we are going to import all the databases now. So we'll say psql, and the name of, and these are the databases which are required to be over here. But let's see if it throws any error when we say PSQL on the target side. Okay, there are few things which it has not done. We'll say POSQL and just say /l. You can see all the databases are restored. What is not done is the Extensions, so you need to create those extensions manually on the target side if they are not done, and you can cross check the other components which you have recorded when you are trying to record everything from the source side. So in a nutshell, we have transferred the dump from source to target, and we have imported. We haven't mentioned the database name, and the way it is there on the source side, the same databases will be created over here. So what you need to do more than this is you just go here, just refresh it, and you should be able to see all the databases which are restored. You need to confirm the users, the if you have schemas, they are coming over here or not. So you need to check out the table spaces as well, and those are the mandatory things which you need to check about. And since the database size was less, we could have used over the network also. So in another session, we are going to see how to do it over the network when the database size is very small. I hope this migration is going to help you, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to upgrade Postgre lower version to higher version using PG underscore upgrade utility. So first, let's understand what is PG underscore upgrade utility in PostgreSQL. So PG underscore upgrade utility is also known as PG underscore migrator in earlier version of PostgreSQL, and it is a utility which is used to upgrade the Postgre instance from lower version to higher version. Let's say if I have to upgrade my Postgre instance from 10 to 12, I can use PG underscore upgrade utility. So PG underscore upgrade utility supports upgrade from 8.4 dot star version to the latest version. The current version is 12 and 13th is the Vita version. So this particular utility, PG underscore upgrade, is not applicable for minor upgrade. That means if let's say if I'm on 10.1 and if I wanted to upgrade it to 10.2, this is not valid. So this is a utility which is used to upgrade from lower to higher version, and see let's see how it is used. PG underscore upgrade. If you say PG underscore upgrade hyphen L, you will see the different options. The first option is hyphen small b, which represents to the uh, uh, older cluster having the executable location. If I say capital B, that means the new cluster executable location. If I simply say hyphen C, it means I can check the status whether this particular PG underscore upgrade can upgrade from one version to another version or not. Hyphen small d represents the data directory of older cluster. Hyphen capital D represents for the data directory of new cluster. And some other important parameters are hyphen small p, which represents the port number of older cluster. Hyphen p represents the port number of new cluster. You can mention the username. If there is a some other user other than Postgre, you can mention that. Hyphen v is used to for verbose. You can see the proceedings on the screen as well. So how do we use the PG underscore upgrade utility? So what we have to do before running this utility, you have to create a new cluster, and you have to instantiate it using the initdb. And once you instantiate the new cluster, in our case, the demo which we are going to perform is from 10 to 12 upgrade. So there will be one instance of PostgreSQL 10 and another will be PostgreSQL 12. So we will upgrade from PostgreSQL 10 to PostgreSQL 12. So you have to shut down the older instance, and you have to shut down the new instance as well before we use this upgrade utility. So what happens in the background when you use this utility? So what it does, it copies the data from older data directory to the newer data directory. And since there will be two cluster, one will be on 10 and another will be on 12. So you have to make sure that you give the exact location of data directory of old location, new location, binary directory location of old environment and the new environment. So this is how do we use the PG upgrade. PG upgrade -d. A small d represents the older clustered data directory location. Capital D represents the new data directory location, and then a small b represents the bin location of older cluster. Capital B represents the bin location of a new cluster. So let's see the demo now. And the demo which we are going to perform is like this. So in the demo, what we will do is we are going to upgrade PostgreSQL 10 to PostgreSQL 12 on RHEL 7.5, and we will be upgrading one database, which is DVD rental, or it is applicable for all the databases which are hosted on the older cluster. So let's perform it. So I have listed all the steps here in a notepad. So we are going to execute this. This is a step-by-step procedure to upgrade PostgreSQL 10 to PostgreSQL 12. So I have a Linux system. The IP address is 192.168.1.56. I have the root access and I'm logged in as Mova Extreme. So in this step, first I'll check whether I have the internet activated on my system or not. So I'll just say ping google.com. So this is working fine. In the step two, it is everything from the beginning. So I'm going to install um, the PostgreSQL 10 version. So yum install PostgreSQL 10 hyphen server PostgreSQL 10. So I'm going to install this. This entire demo is going to take at least 10 to 15 minutes. So once we install this, we have to instantiate it. Yes, the packages will be downloaded. It is very, very fast. The next step is we'll say PostgreSQL 10 hyphen setup space initDB. This is going to initialize the database, and your data directory will be created. This is done. Once it is done, you just switch to Postgre user sudo su space minus Postgre, just clearing the screen. Once it is done, you just try to start it using sudo systemctl start PostgreSQL 10. Once it is done, just check the status sudo systemctl status PostgreSQL 10. You can see that it is in running status. Now let's load sample data. So I have a database copied here in all.sql. So I'm just going to import that. Once it is done, we'll log into Postgre prompt and we'll see what is the database hosted over there. So I have a number of databases. Mostly it is DVD rental. This is just to showcase like how this database will be migrated from, upgraded from 10 to 12. Just say PSQL, and so I have DVD rental, uh, DVD rental underscore new, DVD rental underscore now, restore DVD rental, and there are so many DVD rental databases. So I'll just quit out of this, and then we will go to the step 3. Um, So we have performed 2 steps, and now we are going to install the newer version of PostgreSQL. So in this, we are going to install PostgreSQL 12. So yeah, this has to be done as the root user. So we'll say yum install PostgreSQL 12-server, and this all will be mentioned in the command section. It's very, very easy. And just say yes. So this will be downloaded. Once it is downloaded, you just have to go to the complete location of the binary location, and then you have to execute it because you have two clusters now. One is on 10G and another is on 12. So usr slash pgsql 12 bin postgresql 12 hyphen setup initdb. So we are going to initialize it. Once it is initialized, what we have to do is we will switch as the Postgre user, and we have to start the new instance of Postgre, but this is not possible on the default port, so we have to change the default port of 54322 to some other value. So what we am going to do is, so we are going to add it the postgresql.conf of 12, postgresql 12, and we'll replace 5432, which is the default port, to the new port, because you cannot run two instances on the same port, so you have to change it to some other value. So I'm giving 5433, this is the newer port, and then we will restart the PostgreSQL. Just starting, and then check the status. So you can see we have it is running. Now we have two instances running as PostgreSQL. So check instances are running or not. So we will say ps-ef grab Postgre postmaster, which is the main background process. So you can see one Postgre master is running out of pSQL 10 and another from 12, and the data directory are different. Now, using the pgctl, we have to check the status of both the cluster. So we'll say pgctl, and this has to be from the PostgreSQL 10 version, and then we will give the location of the data directory and then just say status. So you can say that pgctl server is running. Then similarly, we'll do it for 12. So you just make sure that you give the location of your 10 and 12 PostgreSQL respectively. So this is also running, server is running. Then what we are going to do is we have to stop both PostgreSQL instances. So using the pgctl only, we have to stop it. So pgctl-d data directory location, and I'll just say stop. So the PostgreSQL 10 instances stopped. Now we are stopping the PostgreSQL 12 instance. So pgctl-d and data directory location, and then stop. It is done. Just check the status using the status command instead of a stop. We'll just say status, it is not running. We'll similarly check it for 12. You can see that it is not running, so both are not running. We can check it from the background process, which is ps-ef grab postmaster. Just execute it, and there you can see there is no output. This is just reflection of the command which we executed. Now we will check if the cluster is ready for the upgrade or not. So I'll explain what is this all script is about. So this is PG upgrade, which is from the newer so /usr pgsql 12 bin. The PG underscore upgrade is from PostgreSQL 12 hyphen old data directory. What is the location of old data directory? Or the location of old data directory is this one. Hyphen new data directory. This is the location of PostgreSQL 12. And then we will give the location of old binary location of PostgreSQL 10. So this is usr pgsql 10 bin. Then we will give the location of bin directory of PostgreSQL 12. -c is just to check whether our cluster can be upgraded or not. So you can see that checking cluster version, then checking database user is install user or not, then it is checking the connections, whether it can connect to both the instances or not. Then it is checking whether clusters are compatible, whether it can be upgraded from lower version to higher version, that is PostgreSQL 10 to 12. So everything is fine. So now we will invoke the same command without the without -c option. So that means it is PG upgrade. We have given the location of old data directory, new data directory. We have given the location of old binary directory, and we have given the location of new binary directory. So the first option will be for the existing environment, and the next will be for the new environment, and just press enter. So this is going to take a few minutes depending upon the size of the database. You can see that creating dump of the database schema. So it is taking all the databases one by one, and this will copy and paste from PostgreSQL 10 to 12. So behind the scenes, it is doing a number of things. It is analyzing, it is restoring the objects from from lower version to higher version. So it has created two scripts to analyze the new cluster if in case you wanted to analyze it, and the another script is used to delete the old cluster. What we will do now is we will start the new cluster. Let's stop it first. If it is started, we'll say pgctl-d and data directory location and stop. It is not running, so we can say either start it, or if it is not starting, what we will do is we will change the okay, server status is running, and sometimes it creates the problem. And what we have to do is in PostgreSQL.conf, we have to change the port number. So the port number, let's make it 5432 as it was there in the older what do you say, the PostgreSQL 10. So let's start it, stop and start again, and we'll try to connect. It has stopped. Using the pgctl again, start it. It has started. Let's try to log in. PSQL, just says -l, and you will see all the databases: dvd rental underscore new, then now, and there was a user also, which is user2 underscore remote. If something is not migrated, that it will show you like user run this script. So we are not going to analyze it now, and I just wanted to keep it for some more time, the older cluster. And if you don't need it, you just go and delete it. Quit and delete the older cluster. So we have a new cluster now. So I'll revisit what we have done is in our demo, we installed PostgreSQL 10, we initialized the cluster, then we imported some data which was having DVD rental database. Then we installed newer version of PostgreSQL 12. Then we changed the directory from 5432 to 5433 because we cannot run two instances on one port. Then we started the PostgreSQL 12. Then we stopped both the servers, PostgreSQL 10 and 12, using pgctl command, and it has to be from respective binary location. Then we, using the pg upgrade command, we mentioned the location of old directory of existing environment and new environment. Then we mentioned the bin directory location of older environment and newer environment, and we mentioned -c to check whether the cluster can be upgraded or not. And finally, we fired the same command without -c, and we upgraded the cluster within no time because the data was very less. Then we started the new cluster. We changed the port from 5432 to 5433, 3325432, and then we verified if the database is copied or not. So this was all about the PG upgrade utility to upgrade PostgreSQL 10 to PostgreSQL 12 on RHECL 7.5. I hope this is going to help, and all the commands will be there in the comment section. And thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is logical replication in PostgreSQL, and following that, we will see a demo on logical replication. So what is a logical replication in PostgreSQL? So logical replication is one of the way of replicating the data and its associated change from one database to another database, or the databases may be on same host or different hosts. So we are talking about the tables wherein the individual row is actually identified using the primary key. So any changes which is happening on to the table will be replicated from one database to another database. So when we talk about logical replication, it is entirely different from what we call as the physical replication, wherein bit to bit the data is same on two different hosts. But when we say about logical replication, you can control what data has to be replicated from one database to another in PostgreSQL. So you have a control over, you have a fine grained control over the data which has to be replicated, and you have a good control. So in PostgreSQL, when we talk about the logical replication, we talk about two terms. One is the subscriber and another is the publisher. So the one where the application connects in the particular database, that particular node is known as the publisher node, and wherever the logical replication is replicating the data, that is known as the subscriber. So publisher is the one wherein the changes are actually happening, and subscriber is the one which is accepting those changes. So when we set up the logical replication, we set up two, let's say we set up two different hosts, and we have two different instances, we have two databases. So what happens initially, uh, we have to replicate the data from publisher to subscriber. So the initial data is same. Once the initial data is same, then using the Postgre logical replication, whatever changes are happening on the publisher will be automatically subscribed by the subscriber. So it is like changes are happening on the publisher, and the subscriber gets them onto the subscriber server or the host, and it is all happening in the real time. The way the changes are happened onto the to the publisher, the same way it is applied on the subscriber. So there is always a transactional consistency. Let's see some of the use cases of Postgre logical replication. So what we can do is we can send the incremental changes in a particular database or n number of databases from the publisher to the subscriber. Or what we can do is there may be some kind of data warehouse kind of thing, wherein the consolidation from multiple databases go into a single database. Or what we can do is we can replicate the changes between different major versions. Or it is possible that I have a PostgreSQL instance which is running on Linux and another in Windows, so I can replicate the data from Linux to Windows, and whatever changes are happening, subsequent changes are happening, that one can be replicated on different hosts. Or there may be a case wherein we can share a subset of database between multiple databases. So let's say there is a table which is existing on a database A, and it can be sent to different database, like let's say database B, C, D, and E. It is not like you send the entire content of the database, let's say a few tables, can be subscribed by those databases. So that's a good use of logical replication. So a little bit more about the publication and the subscription. So as we discussed earlier as well, so the publisher node or the publication node is the one where in the application connects, the changes are happening over there, and from the publication node, the changes go to the subscriber, the one which accepts those changes in the downstream. So publisher is the one where an application is going to connect. There will be a table, there will be some primary key, and the changes from publication is replicated to the subscriber using uh, the using the logical replication. So there are some kind of restrictions on also here when we use logical replication. So any kind of DDL changes which are happening on to the publisher, they will not be replicated to the subscriber. In that case, whatever DDLs are running on to the publisher, that has to be manually applied on to the subscriber, or using the PG dump structure only you can move those commands to the subscriber. And the sequence data, this is, I think, applicable mostly in such kind of replication. So sequence data is not replicated from publisher to the subscriber. If you are running the truncate command, the truncate command is not actually replicated onto the subscriber. So instead, you can use the delete command if it is possible. Large objects replication is not allowed, or it is not possible. Maybe in the future uh, versions it will be possible. And replication is only possible from base table to base table. That means if you wanted to replicate the views, metallized views, or partition root tables, or the foreign tables, those are not possible. And let's see the demo on logical replication, which is hosted on 2Node. So let me close this, and we'll see the demo. So the demo is like this. I have two nodes, so 192.168.1.51, another is 61. So PostgreSQL 12 is already installed, and the first node will be acting as the publisher, and the second node will be acting as the subscriber. So on to the first node, what we are going to do is we are going to configure it for the logical replication. So what we will do is in PostgreSQL.conf, we will replace localhost with the IP address of that particular node, which is 192.168.1.51. Then wall level will be changed to the logical, and then we will allow the request from the second node 61. So we will in the publisher node, what will we do is pg_hba.conf, we will add the IP address of the subscriber server. So let's start that. This is my publisher server, so let's check the status. Sudo systemctl status PostgreSQL 12. Oh, it is starting. Let's say check the status. It is running. And the second step is what we will do is we will edit the PostgreSQL.conf, and we will make the changes. The changes is localhost has to be replaced by the IP address of that server, and because we have to connect it from remotely as well. So I'll be changing the localhost to the IP address of the server. The IP address of this server is, let me copy and paste the IP address. IP address is 192.168.1.51. So localhost entry has been replaced by this. And then we will go further to well. So well level has to be changed to logical. So let's change it from replica to logical. So it is going to capture all the changes which are happening on to the publisher database. And these are the only two changes. We are doing a basic logical replication. This is done. Then what we will do is we will add it pg_hba.conf. So this will make sure that the connection from subscriber server is allowed. So we will go to the section IPv4 local connections, and we will add the entry. So the entry will be host all databases, all users from 192.168.1.61 using the password method can connect. So we have to tell the publisher that this is going to happen, and you need to allow if there is a connection request from the subscriber server. This done. Now the next step is you will have to restart it because we have made some changes. Let's restart. Let's create the database user and the table. So we'll create a database with the name create database wrapdb onto the source, which is my publisher. So you can see that database is created. Next, switch to the database, and what we will do is we will create a table, wrap table, which will have the ID, name, and price. Let's create this. This is created. And then we will create a role wrap user with replication, and login password is secret_password. You can keep any other password. This is a demo, that's why we are doing this. We can see that wrap user is created. Then let's grant all privileges on database to that particular user. This is done. Next, on public schema also we are giving it, although this is not the right way, but this is a demo, so we are doing this. Okay, so once it is done, you go to the second node, and we have to create the structure of the database. We have to create the empty table, and then we will start the application. Okay, this is my subscriber server. So I will say create database wrapdb. This is done. Then we will switch to wrapdb database. wrapdb database is created. Then we have to create the table. The structure of the table has to be created first, because DDLs are not allowed. They will not be replicated. Then what we will do is we will set up the replication. Okay, to set up the replication, we have to execute create replication on source database server. So this is my source database server. So we will say create replication, my replication. So this is done. Then you have to add the table to that particular publication. So we are saying alter publication name, and the table name. This is also done. Now we will have to create the subscription. To create the subscription, we have to fire this complete command, and this has everything whatever we have done onto the source. I'll explain what is this. So we'll say create the subscription, and subscription name, connection, host is 192.168.1.51 where my publisher is running. Then port is 5432. This is the default one. Password is secret_password, which we have given. User is wrap user. DB name is wrapdb, and publication name we are giving here is my publication that we had mentioned. Okay, it is not accepting, so let me restart this. Systemctl restart. Okay, let me restart it because I made some changes and I have not restarted it. Let me see the status. Yeah, it is back. And let me try the replication creating the my subscription again. Okay, you can see that create replication slot my subscription on this is done. Now we will test the replication. Okay, the table name is wrap underscore table. So let's say select a star from wrap table. You can see there is no row on to the target. That is my subscriber. On the publisher also, we will check it and there shouldn't be anything because there is, okay, let's switch to wrapdb and then we will say select a star from, okay, there's nothing. Let's insert one row. We'll say insert into wrap table and the first one is ice cream. Let's insert this on the publisher. It is inserted. Let's check the status on here also in publisher because we have inserted it. Under the subscriber, fire the same command. That data should be replicated. You can see the data is replicated. Let's add one more row onto the publisher, and if you simply say select a star from wrap table, there are two rows onto a publisher, then there should be same on subscriber also. You can see that it is getting replicated. So just a recap of what we have done is we have two servers. One is publisher and the other is acting as the subscriber. So we have on the publisher, we have changed the SUN address to the IP address of that particular host. Wall level has been changed to the logical so that it can capture all the changes in wall. And pg_hba.conf, we have added the IP address of the subscriber so that incoming connections are allowed. Then we have created a database, a user, and the table. And then we created a publication. Then we added the table to that particular publication. And on the subscription side, what we did is we said create subscription, subscription name, and in connections, we have mentioned everything. The publisher host, publisher port number, password, user, database name, and then we tested the replication and it was working fine. So I hope it is going to help in setting up the replication, and see you soon in another video. Thanks for watching. Hello and welcome. In this session, we will see how to load the sample database in PostgreSQL. And the sample database which we are going to load in PostgreSQL, it is DVD rental. So what we are going to do is, as a prerequisite, we have an EC2 instance which is running with the RHEL 8. We are able to connect with the EC2 instance, and let me show how it is. So this is my EC2 instance. If I say sudo su space minus postgre, I'm able to connect with it, and if I say psql, I'm able to show you the databases, and there is no database with the name DVD rental. So what we will do is we will create the database and then we will load the database. So before that, what we will do is, so we will transfer it using the WinSCP. So I have the WinSCP tool available on my system, and what I'm going to do is let me create a connection. So I'll say open connection, and where is that connection? New connection, and this is the host name, and you have to go to the advanced. In the advanced, you have to locate the location of your this is your authentication, and you just have to point the location of the private key which you are using, and you just say save and login. Okay, so this is your DVD rental.zip which you can download from the internet. It is easily available, And what I'm going to do is I'm going to put it in my backup directory, which is there in the temp. Not suggested, but just for this demo, I'm going to use it. So I'll go to cd/tmp slash backup, and I'll remove everything over here. And now this is the DVD rental, and this is my blank directory where I'm going to transfer this zip file. This is transferred, and now I'm on my putty session. You can see that I have the DVD rental.zip available over here. What I'll do is I'll try to unzip. Okay, this is unzipped. Now it is in the tar format, and what we will do now is we'll directly go ahead and import it. So to import, what you have to execute is you have to execute this particular command, which is pg underscore restore hyphen u Postgre hyphen d, the database name which I'm going to create. The database name is createDB, and let's say the database which we are going to import, its name is DVD rental. So both these commands we are going to run from the shell only. So I'll say create DVD rental, and if I go to PSQL, you should be able to see that there is a blank database which we just created, and using pg underscore restore, we are going to restore the data in it. Pg underscore restore hyphen u, the user which is going to restore it, and the hyphen d, the database where it is getting restored, and the complete location of the tar file from where this restoration is going to happen. This is done. You go to PSQL, just say L plus. You will be able to see that earlier it was just the blank database, just few KB, and now it is 15 MB in size. If you just wanted to go inside, connect with this and just say dd plus, and you will be able to see there are 15 tables which are imported. So this is how we load a sample database. In our case, it is DVD rental, and this can be used for the testing. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to learn what is a streaming replication in PostgreSQL. This is just a diagrammatic representation of the streaming replication in PostgreSQL, though not much details have been mentioned. It is just like there will be a primary database which will be responsible for read and write operations, and from whatever changes are happening, there will be a wall file generated, and through the wall sender it will be sent on to the replica, wherein it will be received and it will be applied. So that's a kind of streaming replication which happens in Postgre. So let's coming back to the notepad where we have all the details noted. So we are going to talk about the streaming replication in Postgre. For this demo, we are not going to do the live demo. The steps are already executed. In the next demo, we are going to show it step by step. But here, this is a presentation how we are going to do it step by step. So Postgre replication is the process of copying the data from primary to the another host, which is known as the standby. So this particular feature was launched in Postgre version 9.0, and streaming replication was introduced. So how does the streaming replication works in PostgreSQL? So every transaction is in PostgreSQL is returned to a file which is known as wall, which is known as write ahead log to achieve the durability. And when a slave uses these wall segments to continuously replicate the data which is changing on the master, then it will be replicated onto the slave. So in streaming replication, there will be three kind of terminologies which will be used, and that actually works. So there is a wall sender process on the primary server which sends the wall data, which is like whatever transactions has happened, whatever has changed the data on the primary, that will be sent to the standby server. And then we have a wall receiver and a startup process which will be running on the standby server that receives and replay these data. and this wall sender and wall receiver that communicates using a TCP connection. And we know that PostgreSQL has both logical and physical replication, and those are the two important replication. In logical replication, it streams a high level change from the primary database to the replica database. So using logical replication, you can change the streams to whatever is happening on a single database or in a table. So in physical replication, changes to the wall log files are streamed and replicated to the replica cluster. So you can't replicate a specific area of a primary database cluster, but all the changes will be replicated. So streaming replication allows the standby server to stay more up to date than it is possible with file-based logs shipping. So that's the general terms about the logical and the streaming replication. Now we will see how to do these step by step. So I have two EC2 instance which I have launched. So these are the two EC2 instance which I have launched, and these are the public IP address which will be immediately destroyed after this demo. So this is the public IP of my primary server, and this is the secondary server. So these are the two EC2 instances which are launched having the Linux as the operating system. So on the primary, these are the steps which you would have done at least uh, I believe some 30 or 40 times in this entire way through me. So what is the first thing which we are going to do is sudo dnf install -y and the complete location of the RPM, which is your latest RPM for Postgre 13. Then we are going to disable the Postgre, which is the default module available, and then we are going to install the Postgre 13. These are the three steps, and then we are going to initialize the database using PostgreSQL 13 setup init db, and then we are going to enable and start the Postgre 13 on primary server. So I'm already, so let me exit out of this, and if I say sudo okay, so let me show you. So you can see Postgre 13 is already active and running, and if you see it further on the, instead of I'll say it replica. On the replica, what we have done is we have executed these three steps. One is sudo dnf install -y and the repo RPMs for latest Postgre 13. Then we have disabled the default Postgre 13 on Linux. Then we are going to install the Postgre 13 server on replica server. The two steps which we are not doing is we are not initializing the database, and we are not initializing, we are not starting and enabling the Postgre 13. Since there is no initialization, so there is no concept of enabling and starting it. So it is just the software is available on Postgre 13. The second thing which we will do is on the primary server, we will just ensure that our postmaster is running. That means PostgreSQL is running. So you can see that postmaster is running, and there are different background processes which are mandatory, and the something which is of very interest for this streaming replication is wall writer. And one of the things which you have to do is you have to ensure that SES status, because you are doing it on EC2 instance, you have to ensure that SES status, this should be disabled. So in case you have and you are not sure how to do it, just go and make it to disable. So you can see C Linux, this should be disabled for this. Or if you have a firewall, make sure that the firewall is stopped so that the 5432 port where your PostgreSQL is communicating, that should be able to communicate between the two nodes. Then what we are going to do is, this is a very, very important part wherein we are going to enable primary for the replication as below. So what we will do is, let's log into PSQL, switch the service account, Postgre, and then this is going to be very, very important. You just say show config underscore file. So by default, you just graph for listen underscore address, cat, and graph for listen underscore address. So there is something called as listen underscore address on your PostgreSQL.conf in your source and target. In your source, you have to ensure that listen underscore address has to be changed, because by default it will be local. And if you see it, uh, mm, local underscore address, that you have to change it from localhost to the IP address of the server. So in our case, we have just changes to star, or the IP address of the server, so that it allows the remote connection. Then the second thing which we have to do is, we have on the source server. So everything we are doing it on the primary. So we are going to create a user, which we are saying as create user replication. So what this is going to do is, this is going to create a replication user, which will be used to replicate the data from primary to the replica. So this user is already been created. So if you say psql and /du, you will be able to see that a replication user, which is called the rep user, has been created with the replication capability. Then the next thing which you have to do is, you have to tell your hba.conf file that allow the connection from the replica. So what you will do is, this is going to be very, very, very important. Cat pg data hba.conf. So you have to ensure that host replication rep user, and this is the IP address from where your replica will be coming. You have to say that whenever the replica is coming from this, ensure that the connection is allowed. So you have to ensure this, otherwise it is not going to work. Then finally, on the primary server, you have to restart your PostgreSQL. So far we have uh, installed the PostgreSQL binary on the source environment. The database is up and running. On the console PSQL, we have changed the listen address either to the IP address of the primary host, or ensure that star is mentioned so as to allow it. Then the next thing which we have done on the primary side is, we have created a user called rep user with the replication capability. And then in the hba.conf, we have allowed the IP address of the replica so that it can connect. And finally, we have restarted the primary server. Now on the replica side, let's open the replica. This is our replica. Here also you have to ensure that SAS status, it must be disabled so as this demo to work. And we have to create a base backup. So far in replica, you just have the binary and nothing else. So these things are not going to work over here. So initially, when there is nothing, you go and check it over here. This will be blank. As of now, there will be data because the command has already been executed. And the next thing which you have to do on logging onto the the replica is, you have to execute this command. PG base backup, I'm not going to execute it. I'm just going to show how it is going to work when you put it onto the replica side. You just say PG underscore base backup hyphen H. You have to mention the IP address of the source. Then you have to mention the username. This is the username. Then you have to say checkpoint. It is equal to fast. Then you have to mention the data directory. The data directory where the data will be replicated. Then hyphen R and then the slot, and you can give some name. In this case, we have just given the same name only. So what this will do, this PG base backup, this will connect to the primary IP and copy all the data files from the primary, right? And the connection happens through Postgre database user, which is named as wrap user. So initially this directory on the replica was empty. Now it has been filled up. So now if you go over here and just check it out, and if you just check it out, the data has been filled up like this. That means the data using the PG underscore base backup command has been copied from primary to the replica. And how to verify that everything is working fine or not? So initially this was blank, and when you executed this has been filled up. And apart from that, there is one more important file which comes over here, which is called as, I'll show you that. Um, the one which is copied over here, it is called as PostgreSQL.auto.conf. So it has the listen address of equal to star, then primary connection info. It is saying that when it is going connecting to the primary, it is using the wrap user, it is using a password file which is used for this purpose. Then there is a channel binding, and this is the host where it has connected. This is the port number. This is the SSL mode, and these are the basic details. Okay, and finally we have to start the replica. So there is a extra file which comes, which will not be visible on the source, is this file, standby.signal. So I think it is already lost because I have I believe I restarted it. Standby.signal. Okay, sorry. This is empty by default. So this is created, which signals that it is a standby environment of your primary. And finally, you have to start your replica. So how do you start your replica? Initially, you were not able to start your replica because there was no database on it. It was just binary. Using the PG base backup, you have brought the data from your primary to the replica environment, and you have to just using this command, you just have to uh, start it up the normal way. And if you say sudo systemctl start PostgreSQL, this will be started. So in our case, we are just going to check the status. It's running. So I have just completed it a couple of hours back. And then finally, if you say PSAXF grep postmaster or post, this will, okay, let me switch to su space minus postgre, sudo su space minus postgre, and you say just postmaster. You will be able to see the background processes, and there is important background process which you need to check, that Postgre wall receiver streaming that should be working, because that is something. So there are two things. One is wall sender, which will be there on the source side, and there is something called as wall receiver on the target side that must be running. That ensures that this is a replica and it is in the standby mode, and it is replicating the data from the primary using the wall receiver process. Now, how to ensure that Postgre application is successful? What you have to do is on the source side, you will just say, so these are the two important commands, so which confirms that it is in the replica mode. Expanded display you must set on, and then you have to simply say select star from pg underscore stat underscore replication. So this view tells that replication is running. This is the process ID, this is the user SSID. Who used this replication? This is rep user. This is replication name is rep receiver. The client address is this one. This is your target side, and status is streaming. It is in the asynchronous mode. And then finally, when you check it on the replica side, you set the extended mode on, and then you simply say select star from pg underscore stat underscore val underscore receivers. And if you see the detail like status is streaming, and slot name we have not given anything, and you can see the details who has caused this replication to initiate. So we used rep user to initiate the replication. And if you, in case you wanted to check whether replication is working fine or not, you can create a table. That's the basic thing on the primary side, and the same will be replicated on the target side. But in our case, we have just seen that the status is working, so everything is fine. So just to recap, like what all has been done so far. Streaming replication is very important in PostgreSQL, because this is going to be the base for wrap MGR, which is going to be used for failover and other stuff. So before that, we should know like how the streaming replication works in Postgre. In our case, we use two EC2 instance. We have launched two EC2 instance which were running on Linux, and then we have carried out few steps. The few steps were just we executed 6 steps in primary, wherein we installed the binary, we initialized the database, we enabled and started the database. On the target side, we just installed the binary, and on the primary side, we checked what is the status of postmaster. We disabled the SC Linux on both source and target, and on the primary side, we have changed the listen address from localhost to star, or the IP address of the source. Then we created a replication user, which is going to cause the replication data to move from source to target. And then we have allowed the remote connection in pg underscore hba.conf in our source, and we have mentioned the IP address of the target. Then we have restarted the Postgre server on source, and then on the target side, we created a PG base backup using this command, -h. This is the primary host IP. Then we have used the replication user, which we created on source side. So using this is connected to primary side, and it is doing the continuous checkpoint, and this is the current location of the data directory wherein it will be dumped, and we have given a slot name for this to happen. So these are the details which are mentioned. -d, it is the for the destination directory. -r is for replica for the replication, and then finally the val comes into the picture. So once it is done, it gets executed within few seconds only, because there was no data at all. And on the replica side, there will be one important file which will be created. That's an empty file, which is standby.signal, which represents that it is a standby environment only, and it is going to receive the data in continuous mode from the master, and that's the way it is going to work. And if you see the postgresql.auto.conf, this will have the commands which are being used. And then we have started the replica. To start the replica, there should have been the data directory, which has been brought by pg underscore base backup, And then when finally we checked using the two commands, one is select star from pg underscore stat underscore replication, and other is pg underscore stat underscore val underscore replication. So using this command on source and the replica side, we verified everything is fine and working. So this is on our source side, and this is on our target side, or replica side. So I hope this is going to help. Hello and welcome. In this session, we will see how to optimize the backup and restore speed of PostgreSQL. So as usual, everything is mentioned in a notepad, and we will follow through this, and we will see how we can improve the speed of PostgreSQL when we are going to take the backup and we are going to restore using pg underscore dump and pg underscore restore. So we have a scenario. We have 500 gigs of PostgreSQL database, and there will be two sub scenarios wherein there will be very small size tables, and there will be few large size tables. For this particular scenario, just say if I have a database which is of 100 GB, or let's say it is of several hundred GB, and we need to take the backup using pg underscore dump because we need to migrate it to the cloud. Maybe it any sort of cloud. It may be your Google cloud, it may be your Azure cloud, or it may be your AWS cloud. And for this particular demo, not this is going to be very specific, but I have just an EC2 instance which is of very small in size in terms of the CPU and memory. This is just the demonstration purpose. For this we have done it, but we'll go through the theoretical part wherein we will try to understand what are the different factors which are going to impact the speed of the backup and restore using pg underscore dump and pg underscore restore. So to speed up the backup of your large database, when I say large database in Postgre, anything above 100 GB, we say it is a large database. That doesn't mean that it is some sort of restriction. It is just that this is common terminology used when you have to take the backup using pg underscore dump. So for the large database, which can be 100 GB and more than that, pg underscore dump, which is a command line utility, or which is a utility which can be used to take the backup in parallel mode. So if you wanted to take the parallel mode backup using pg underscore dump, then you have to use the -j flag of pg underscore dump, and that's only possible when you are using the directory of or archive format. So you can say pg underscore dump -j. This denotes the number of parallelism, and uh, how many parallel threads you can invoke. It entirely depends upon the number of CPUs you have. So if you say ls CPU, that will show you how many CPUs you have on your system and how many can be used for parallel purpose. So let's say if I say ls CPU, it will show you how many CPU and how many cores you have. So you can see the core sockets, and you can see the cores. Let us say, for example, if this is 2 and this is 4, in that case, what is going to happen? This is just for the demo only. We'll say pg underscore dump -j. You have to mention the number of parallelism. If it is 2, mention 2. If it is 4, the number of cores, you can mention 4 over here, whatever suits your requirement, or whatever is the strength of your server, you can mention hyphen that. So then you can mention the format. This is directory format, and this is the name of the this is the location where you are going to put the zipped directory structure. And I have mentioned the database name as DVD rental. So if I simply I need to first remove, I think it is already existing. There's a very small size database, so probably you will not see any sort of impact also, but when it is a large sized database, you will be able to see the impact. So if I say rm -rf, I have just removed it, and what you can do is you can simply fire this command. So what this will do is this is going to parallel put your backup in parallel mode. So pg dump will be parallelized in -j, which is equal to 4. So there will be 4 parallel threads which will execute, and this will execute your backup in parallel mode. So this is going to be highly effective, and this is going to speed up the way of your pg underscore dump. And this largely helps when you have to restore, or when you have to back up your large size database. You have enough CPU on your system, and it is not going to impact the number of cores which you are going to utilize for the backup purpose. In a similar way, you can use it for the restoration. You simply say pg underscore restore hyphen hyphen no honor. You mention where is the location of your backup, which is in the zipped, or which is in the in particular format. Then you mention the number of restore operation, I mean the number of threads. If I say 4 cores are there, I'll just mention 4. I this The important part of this is you should have enough CPU on your system so that it is not overburdened, and it should not impact your normal database operation. And -d, I have mentioned the database where it is going to restore. So using pg underscore restore with the -j flag, you can restore a dump in parallel. So it works with the archive or the custom or the directory format. So one of the other important thing is, so I'll just mention in note. So whatever it is, if you have not taken the backup, which is already there in the archive or the custom format, so that's the important. If you have not taken in parallel mode also, you can restore it using this. I'll just save it. And the deciding factor when you start your migration to the cloud, whether it is online or offline. In offline, when you take the backup, you have to ensure your application is down. And when you put pg underscore dump command, which you have executed in the parallel mode, it is assumed that it is a downtime has started. So anything after that is not going to be captured. So what we will do is, we need to check the number of free CPUs on your system and the number of cores. Based on that, you can perform the parallel backup and restore using pg underscore dump and pg underscore restore. You have to make sure that it is in the proper directory format, and when you use the zip format, it is going to reduce the size, so that when you are restoring, the size will be very small in size. So it always matters. So the number of free CPUs or the number of available CPUs on your server, the storage, because when you are going to compress it, it is going to take the CPUs, so for the compression purpose. So this is a generic scenario. Now, if the migration has to be done for small size tables, but some of them are large size table, then what is that we have to do? So it is just few large size tables. Let's say it is 50 GB, and remaining tables are just of 1 GB, 2 GB, or 5 GB in size, and we have to perform the migration. So you can adopt the mix of backup and restore activity. That means when you say pg underscore dump, you can put in parallel mode, and you can use another utility, which is pg underscore loader. If these database size or table size are very small in size, so instead of dumping it on the operating system then shipping it to the target, or what you can do is, you can perform this way: pg dump hyphen d. Let's say this is my database name, and this is custom format, and this is the restore. So this is, you take the backup, and the output is simultaneously redirected for the restoration purpose. In that case, you are not supposed to store in the on the host at particular file system. In this case, you have a restriction. You cannot use the parallel mode because that's the only restriction. If you have large size database with very small tables, you don't want to take the backup on the operating system. You want to take a backup and restore simultaneously. You can use the redirect option. So pg underscore dump hyphen d DVD rental. This is the database name, and this is the format. So and you can redirect the output so that PG restore will pick up the backup from here. If you use hyphen J option also, it is not going to helpful. So you can ignore that. Not you can ignore that. It will be ignored during the restoration. There is another good utility which is available, which is PG loader. So PG loader, a combination of PG loader, PG dump, and PG restore can be used for varying table size in Postgre. So if you have to compare the performance and the speed of PG underscore dump with PG underscore restore and the uh, PG loader, then you can do that. So there are some of the test scenarios wherein some 500 gigs of Postgre database, when it was used with the PG underscore dump and PG underscore restore, and when it was used with PG loader, it has been entirely different. If it is a single large sized table, you can use PG loader. It is going to increase the speed of migration to a large extent, and in some of the lab scenarios it has been observed with PG loader, the speed of backup and restore is almost 3 times as compared to PG underscore dump and PG underscore restore. And this is largely applicable or only applicable to the tables where the single table size is large. So you have to ensure that. So a database with multiple tables, uh, some of them are large, some of them are very small. So you can use the PG dump and PG restore for the small tables, and for the large table, you can use your PG loader, which is going to speed up the migration speed. So it is up to you how you wanted to use, but in some of the scenarios, mix of both PG underscore dump, restore, and the PG loader, it really helps. And the most important part is the CPU. If you do not have the enough CPU on your system based on the number of cores, so you have to check this particular parameter, which we just saw. It was the number of cores, and where is that? Okay, let me execute it once again. ls CPU, and you have to check this. So ensure and make sure you have enough of the CPU capacity free on your system, because it is going to entirely bring your system at the knee, because it is going to consume all of your CPUs, because you are going to use the pg underscore dump in the parallel mode. And if you are executing the same command from here also, you are going to use the pg underscore restore utility as well. And if you are using pg loader also, you can do it from here. So we just saw like a combination of pg underscore dump with the parallel mode, pg underscore restore with parallel mode, and pg loader for the last size table. It helps in migration from on-premises to cloud, or maybe from one system to another if you have enough CPUs which are. This session we will see if the Postgre releases the space when a user related database is dropped. So in short, when you drop a database, is Postgre going to release the storage at the operating system or not? So as usual, we will go through the steps which are mentioned in the document. So the question for today is, does PostgreSQL release a space when the database is dropped? So to destroy or drop a database, you should have the drop database privilege. Either the owner of the database can do it, or the super user who is having such super privileges, he should be able to do it. So to drop the database, it is very, very simple. You just log into PSQL. I'll quickly log in. PSQL, just list down the databases, and whatever database you wanted to drop, let's say I wanted to drop TestDB, I can do it. Drop database and the database name. The important part of this is not how do we drop it, how easy it is to drop. Like some of the important things, if the user application is already connected, and if you are connected to the test DB like this one, you would not be able to drop the database. Let's say this is the last database in your PostgreSQL. In that case, better you get connected to some of the template database which is available, and you should drop the last user database. The command will be either you use the drop database name, or you can use the drop DB at the operating system which is available. The important fact about this is uh, in some of the cases, it has been seen the database size is has gone beyond our imagination because of the fragmentation and because of the number of tuples which get increased in your table. So basically, the table size goes beyond imagination. The number of rows which is actually is there is and the size, they are not corresponding to each other. That means there are some unused space which cannot be used, but they are actually occupying the space because of the dead tuples. And to best of our vacuum, auto vacuum services, which is launched on the regular basis, somehow we were not able to reclaim the storage. And the last thing which we thought, like, why don't we drop the entire cluster with the content and rebuild it from beginning? So what we need to do is, I'll basically go through it. We will take a pg underscore back, dump all backup of the PostgreSQL databases, and in case you have since we are doing everything on the same operating system, I'm not going to zip it. In case you wanted to do it on other server, better you go for the zip, compress it so that you can save some storage. But when you zip it with the maximum number, that means it is going to exhaust all the CPU and IO subsystem on your system. So what I'm going to do is, I'll show you what we have at this point of time. I'm running everything on an EC2 instance, and I have Postgre 12 running, and you can see this is my postmaster, and these are the different background processes available over here. And what we are going to do is, we are going to take a backup. This is the location, this is the default location where backup is residing. So let me go here and remove some of this stuff. So I'll say rm minus rf star dot zip. Okay. So what I will do now is I'll just take a compressed, uncompressed backup using pg dump all, because we are going to remove everything and we are going to rebuild so as to release the storage at the operating system, though it is not being visible over here because the database size which is there in the Postgre as of now, it is DVD rental. So let me show you PSQL/L plus. You will be able to see there are some DVD rental databases which are 15 MB in size. We are going to drop everything and we will see how to rebuild it from the beginning using the backup and restore feature. So the second thing which we are going to do is perform the backup of PostgreSQL configuration file. So we'll just say show config underscore file or show data underscore directory. So what we will do over here is there are n number of configuration files available over here. So if you just say ls-ltr start.conf, you will be able to see at least 5 files should be visible. It is ident hba postgresql.auto.conf and postgresql.conf. So we are going to take a backup. How we are going to take a backup? Using the cp command, we are going to take a backup of all of these in your backup directory where you wanted to create a fresh backup for everything which you are going to destroy. So we have taken a backup of all the configuration file. And the next thing which we'll be doing is there are a lot of information which you can see using these commands. You can see show all or table pg underscore file underscore settings. That will show you all the details in case you wanted to see. You can see the different options in your postgresql.conf in case in case you have to modify some of the parameters since you are going to restore it from the backup which you have just taken. And what we will do now is we are going to stop the cluster. So one of the things which you should be doing is you should create a profile for PostgreSQL so that in case if it is not able to export the binary location, it should automatically do when you export the profile. So I have exported the location of bin location of Postgre where all my installed binaries are available. Now what we will do is we will go ahead and check if the OS processes is running. Yes, it should be running as of now. What we will do is, okay, I'll put couple more commands over here. We'll check the status, then stop, then check the status again to avoid any kind of inconsistency. Let me save this. Now we will go ahead and check the status using pg underscore ctl hyphen d location of the data directory and then the status. So status is running. Let us stop it. Then we will check the status again. It is stopped. Now let us check the status again and check because it has stopped, so nothing should be running. And at the operating system also the background processes should go off. The next thing which we will do is we'll go to the data directory location where all my data directory files are available. You can see there are a number of data files, and what we need to do is, since we have already um stopped the cluster, we are going to remove all the files from here. We removed all the files. Now what we will do, just say ls-ltr just to check if everything is removed or not. Since there is no error, so there should not be any problem. ls-ltr, everything is done. Now what we will do is again check the location of your bin. So bin is here in /usr pg sql-bin. So for 13 it will be something else, for 11 this will be something else, for 10 this will be something else. So what I'm going to do, I'm going to initialize my data directory because I have deleted everything. So all the directories, subdirectories which are required to build your PostgreSQL, they will be initialized over here. Okay, you can see that it has been initialized, and if you go to this location, because we are in the same location, just say ls and you will be able to see all the files are reconstructed or reinstalled. Now what we will do is we will restore all the configuration files that has been picked up prior to the deletion of the cluster, because by default these are the default configuration files, and we might have made a number of changes in your postgresql.conf or in your pg underscore hba.conf. So just go ahead and restore it from the settings or from the backup which you had taken. Okay, this is wrong. Okay, this is restored. You can cross verify every time you do such things, because if they're not properly copied, it might create a problem. Next thing what we will do is, so we will, since the cluster is in the stopped status, we will go ahead and start it. Just say psux. You'll see everything is stopped. Just check the status. It is not running. Start and then check the status. It has been started. Check the status. It is running. You can see the background process is also running successfully. Now, if you have compressed your backup and transferred to some other server, you have to uncompress it so that you can utilize it. Since we have not done it, we are simply going and restoring it using PSQL. So restore the backup of PostgreSQL using, so new pages will be written and there will not be any what do you say, the extra space between the rows in the form of dead tuples which has been removed or deleted. It is restored. All the databases, they have been restored. Now the next thing which we will do is we can check if everything is fine or not. PSQL/L plus. This will show you. So what happens is, in this case, when you have restored it again, it is entirely a new cluster which has been rebuilt, and it surely releases your storage. What you should have done earlier is you could have checked what is the size of the files which are occupying. If you go to this location where my actual files reside for the databases, cd pg data in base location, and if you say lswc-l, this will show you there are 8 folders over here. And if you see over here, 1 2 3 4 5 6 7 8, they are 8 over here. That means, and if you wanted to see the individual file, what do you say, the sizes, you can see it once you have before deletion and after deletion. You should be able to see the difference. Since our database size is very less, which is just 15 MB at the database level, the operating system level, that would be lesser. But when you do such activity, this is going to release the storage. And one of the other thing, if you have fired the delete command, or if you have removed and still it is not, if you have fired the drop command and still if it has not released any storage, what you need to do is you can, there might be a possibility like archiving has been enabled on your database. This is just some of the thing which may be possible. If your archive mode is enabled, and if you have mentioned some other location, non-default location, or what I will say, the archiving location, and if you have not removed the archive from there, it may be possible like those, it is getting stored over there, and you have to manually delete if it is not already deleted. So this may be one of the case. After deletion of the database also, this might not have been removed from non-default location if it is. So you have to verify, or before deletion also you can check what are the different locations where it is keeping the archives if you have enabled the archiving. And when you rebuild it using the pg dump all backup and restore, it is going to release the storage. And sometimes it also happens like when you have executed such a script for the deletion at the operating system, it might be deleting slowly depending upon the size of the database, and you have to check what are the different activities which are happening inside the database. If you say simply select star from pg underscore stat underscore activity, this is going to show you the query, and if the database which you have deleted or going to delete, if there you are facing any problem, you will be able to see the details from here. Select star from pg underscore stat underscore activity. This gives you good information, and if the deletion is already in progress, you should be able to see it using lsof grep deleted. So this will show if there are any open file descriptors which are still in progress. In some of the cases, you might have to reboot your operating system in the worst case scenario. Not very usual, but sometimes this has been seen to release the storage because the file descriptor might have been in used space, in used state. I hope this is going to help, and mostly it's a very simple and straightforward stuff. Drop the database, it is going to release the storage. If it is not, that means you have to make sure your auto vacuum process, whether it is releasing the storage back to the table or as applicable in vacuum full, it is giving the storage back to the operating system. And this one, this has been done in the lab environment. You can check it out, and this is going to help you. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to see how to backup and restore using the PG-based backup on the same host. So as usual, everything is there on the notepad. So we are going to discuss about the backup and restore using the PG-based backup on the same host. And what we are going to do is we are going to restore by taking a backup using PG-based backup. So as a prerequisite, we have an EC2 instance having RHEL8 installed on it. We have a sample database which is called as DVD rental, which is already loaded on that. So let me log in. So I'm in PSQL, and if you simply say, I'll just copy and paste for quick reference. Show data underscore directory. This is my data directory, and if you say /l, this will list down all the sorry, I have two /l. It will show you there are 100 DVD rental databases that we are going to backup using pg underscore base backup. And if you see more details, you will be able to see like this. This is the detail of the table spaces which we have. We have only default table space. We do not have any non-default table space in this environment. And what we are going to do is, if you see L plus, that is the detailed view of the databases, this is what it is. So everything is there in the default table space. We do not have any non-default table space. So if it is non-default table space, you have a couple of extra steps involved, but since we do not have it, we are going to skip that. And before doing anything, what you need to do is you need to make sure that the details related to the archive. So if you say select name comma settings comma unit from pg underscore settings, where name like archive percentage, it will show you all the settings related to the archive. So if you see if you say archive underscore mode, it should be on. Archive timeout, it should be 5 minute. If you say archive command, uh, this should be enabled so that the archives go to a particular location. And archive cleanup, we are not going to do it. It's not required for this one. And we already changed it from a default to the non-default value. So earlier it was disabled. We made it to 305 minutes. Archive mode, earlier it was off. We made it on. And let's go to the next step. The first step which we need to do is just go to show config underscore file. That will show you the location of postgresql.conf. And what you need to do is you need to change 4 parameters. One is archive mode, which we have turned on from off. Archive timeout, we have made it from disabled to 300 seconds, which is 5 minutes. And archive command, we have made it to the particular location. Then once these changes are made, because I'm not going to do it again because it's already done. So you simply say sudo systemctl restart PostgreSQL 13 so that these changes are in place. So the next thing which we will do is, since we have 100 approx 100 databases and we have already checked like archive mode is on, archive default timeout is 5 minutes, archive command is we have given something, and then we are going to forcefully switch the pg underscore the wall files. So let's quickly do it a few times. Let me log into PSQL, and we have done it. Let's change the password of Postgre database user. We have made it to password. And then what you do is let's create a directory wherein we are going to initiate a compressed PG based backup to a particular destination. Let's quit from here and just say mkdir-p. So there should be something already over there. We are going to remove it, rm-rf star. So there is nothing inside that. So we created a destination where we are going to take the backup. And now what we are going to do is we are going to execute the pg underscore base backup. The prerequisite is the archive mode should be on, and there should be an archive command. So these two are the minimum values which are required. So now we are going to execute pg underscore base backup. It is being done from the local host. If it is from a remote host, you have to mention the IP address or the host name. Then the port is 5432. We need a super user, either the replication user who can have that privilege, or the super user. In our case, we are doing it from the Postgre super user. -d is the destination where we are going to do the base backup. And there are few options which we are doing. -f, which is the format, we are doing it in the text format. -z is the zip we are doing. -access is for the wall method, and we are doing it for streaming. And that's it about it. So let's execute it from here. Feed in the password. So once this is done, what we will do is we can initiate an uncompressed backup as well if you want. But in our case, since we have to save some storage, we are doing this. If you wanted to do without the compression, you just have to remove -z. Okay. You can see that backup is already done. So we have a base backup, we have a backup of wall, and we have the manifest. So during the restoration, we need just these two files. And if you wanted to have an uncompressed backup, you can do that. Now we are going to perform the disaster recovery by cleaning all the data files. So before doing that, let's do something. So we just wanted to verify what is our data directory location. And then what you are going to do is just go to this location and see the contents. The contents are here. And the next thing which you have to do is you stop the PostgreSQL services. Let's stop the PostgreSQL services. Stop. And then we will check the status. And then we are going to delete the data directory where all the files are there. So just delete everything which is there in the data directory. Okay, so if you just say ls-ld and this particular data directory location, you won't be able to see that because it has been deleted. And the next step, since we do not have any table space other than the default one which we have already seen, we are going to continue with the below untar command. So let's go to this location. If you say ls-ltr, you will be able to see there are the zipped tar file for base and wall backup. What you need to do is, let's create the data directory where we are going to restore all this. So it is just we removed it here and then we are going to create it again. The next thing which we will do is we are going to unzip the base backup and the wall backup, pg underscore wall, from zipped to unzipped. And the second thing which we will do is we will unzip the wall file as well. That will be required. This is done, and the next thing which we are going to do is we have to untar the base backup to the location where it is required. So there is no special command for the restoration. It is just OS level, uh, what do you say, the untar command which we are using. So it is going to untar. Ensure that you have the data directory created and we are going to restore it over there. It is done. If you see pwd, and if you go to this location, you should be able to see that. Okay, one more thing we are going to do is we need to restore the wall backup as well. So we have already unzipped it, and whatever wall we have which is restored from the backup, let's remove that as well. And what we are going to do is we are going to create that directory and we are going to restore it from the backup which we had taken. And finally, what we are going to do is we are going to untar the wall backup which we have taken during the backup into the location, wall backup location. Okay, this is done. If you do cd over here, you will be able to see it. Okay. The next thing which we will do is we do not have any default table, non-default table spaces, so we have to move to the next step. And one more thing we have to do is we have to inform PostgreSQL.conf about the restore command. So in the restore command, you will have to mention the location where your wall files are there. So you just search for restore and restore, you have to mention it's already mentioned over here. Since I'm doing it again, so it has retained the previous value. Now once we have restored the base backup, wall backup, we need to try starting the Postgre, and we need to verify what's happening in the environment. So what we will do is we will check the status and try starting it. So any issue which is related to the PostgreSQL startup will be recorded in var log messages, which is at the system level. Since PostgreSQL might not come up, and any problem writing into the PostgreSQL log will not be written over here, that will be written into your var log messages. So if you simply say sudo systemctl start PostgreSQL, it is showing us there is some problem and it might have returned some information. So this is the latest. So I have just done tail 100f and it will show you data directory has invalid permission. So it is saying permission should be this one 0750, but let's give it to 700. So we will pick up the information from here itself and we will give it to chmod 700 and this one. If we try restarting now, it should work. It is working, and if you see here, it started PostgreSQL 13 server, and if you check the status, it's up and running. So just a recap, what all we okay. Let us cross verify. Uh, let's log into PSQL and just say /l. You will be able to see there are 100 PostgreSQL databases. Sorry, the dividend databases, and they are available. And that's all about how do we restore PostgreSQL using the PG underscore base underscore backup. So this comes by default, and if you know how to use it, is sometimes going to be really, really helpful. I hope this is going to help. Hello and welcome. In this session, we are going to learn how to obtain the continuous archiving and how to perform a point-in-time recovery using PostgreSQL 13. So we are directly going to start with the demo, and as usual, everything is going to be placed on a notepad. And before we start, what is continuous archiving and how to perform point-in-time recovery with PostgreSQL, we need to understand one of the thing. Like before we discuss about this, we need to understand what is WAL, which is known as write-ahead logging. So what is WAL in Postgre? So WAL is a standard method of ensuring data integrity. So before the changes which are committed in the Postgre database, before they are returned to the data files, they are returned onto the WAL logs as well. So these are some of the questions which comes up very frequently, like does Postgre have a transaction log? Yes, Postgre has a transaction log which is known as WAL, and WAL has a record of all the events or changes that has changed the WAL data, and it is just a description of the changes which is made to the actual data. Using the Postgre WAL entries, you can restore the database back to the state at its previous state. And where are the Postgre WAL files located? So WAL files are located in their default location under your data directory in pg underscore WAL. And the size of each WAL segment is 16 MB in size. You can modify it according to your requirement. So another popular question for this is what are the WAL files used for? The WAL files, they are used for roll forward journal, and they record the transaction that has been committed against your database. And that's all the basics about your WAL and why we are discussing about it. So we are going to set up our environment in such a way that we will take a backup and we can restore it using those transaction logs to a point in time to a consistent state. We already know that there is a pg underscore dump and pg underscore dump all utility which can take a backup of or the snapshot or the database at a particular point of time, but anything which has happened after that, that will not be recorded. So to perform all this continuous replication, a continuous archiving and point in recovery in PostgreSQL, we are going to set an EC2 instance. So I'll directly go to the console and launch an EC2 instance, and then we will discuss about it. So I'm going to use RHEL 8, the free tier, add storage, So all defaults only, nothing special. So we just wanted to make sure that only I should be able to and PostgreSQL port I am enabling so that I can access it from my system in case it is required. Though this is just for this demo purpose, and then we will say review and launch. I have the private keys already created and located on my system. So once it is available, we are going to work on this. So this is going to take at least a minute or so. In that time, we will try to navigate through the steps. So we are going to launch an EC2 instance. It's just one instance, it is not two. Then we are going to connect with the PuTTY session, and then we will disable the Linux, SC Linux, and we will start from there. Though these steps are not important because we have seen it earlier as well, but I wanted to show it from the beginning. So let me see if the instance, I'll copy the public host name, and I will locate where my uh, keys are, so that once the system is up and ready, we'll directly go over there and start from there. Okay, so I'm waiting for this to get in 2 by 2 checks available. So what we are going to do it, let's navigate through the step. In the first step, we are going to download and configure the PostgreSQL 13 on the Linux EC2 instance. Once the installation is done, now we will set the listen address equal to star or the IP address of the system so that we can connect remotely. We will change the Postgre database user password as well, and then we will enable sudo access to Postgre so that whenever we restart our Postgre instance, it should not ask for us as the root user or the sudo user. So we'll give the sudo access to Postgre. Let us see the status so that we can directly start the steps, because it is going to take at least 25 to 30 minutes. Still it is an initialization phase. Still going over there. So let me, sometimes it is very irritating. Okay, and then we are going to add our Postgre OS user to the sudoers, and then we will reboot it, because initially we disabled the SE Linux. So to just make it effective, we have to do that. Then in our pg_hba.conf, we are going to add the IP addresses, which I am going to access it, and then we are going to restart the Postgre. Then the second step onwards is the step which is required for this demo. So it is already configured, the system is up and running. Let's connect, accept, and we'll go to ec2 user. Okay, I'm connected. Now let's follow the steps. So we are going to execute the first step. Let's do the SC status. We are going to uh, disable the SC Linux. So what I'm going to do is I'll say vi. It creates a problem. So instead of enforcing, let's and make it disabled. Save it, and then move on to the next step. Let's see the um, let's start downloading and configuring the PostgreSQL 13 on EC2 instance. So I'm just going to copy and paste all the 6 commands. I'm not going to discuss because we have already seen these commands earlier as well. This is going to take a minute or so, and after that we are going to configure the remote access. In remote access, we will just say alter system set listen address equal to the IP address of the system. This shouldn't take less than 30 seconds, I believe so. And back behind the scene, when this continuous archiving and this thing is configured, back behind the scene, it is going to use your PG underscore base backup. So we'll see some more details about PG underscore base backup, which somebody has asked me earlier how to restore it. So the restoration step will be over here. So we will be using the restore command, how to use the restore. So we have seen in one of the session how to take the backup, but we will see how to restore using the backup which has been taken from PG underscore base backup. This is almost done. Just yes, 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 yes. Come out. Yes, this is done. And now what we are going to do is let's switch to the Postgre user. This is done. Now let's say PSQL. We say PSQL, and then we will execute two commands. One is alter system set local listen underscore address equal to star or the IP address. We'll cross check it once it is rebooted, and we are going to change the password of Postgre uh, database user. This is also done. Just quit out of this. And one of the things which we should do is we will add the Postgre OS user to the sudoers. If you do it, the advantage which happens is um, every time you use Postgre OS user for rebooting the starting the Postgre service, it is not going to ask for the password. So we are enable. It's a good practice to have it to the restricted mode. So put the details over here. Postgre all and yes, save it, and then we will say reboot. Let's reboot the instance. It will take at least 30 seconds or so because we have changed some of the settings which require the reboot. So once it is done, we are going to change the hba underscore pg underscore hba dot conf file. We are going to add our IP address so that we those IP address will connect to this. It's just a demo, but this is something which you need to make sure that in your organization, if you have to ensure connectivity, you mention this thing in pg underscore hba dot conf file. So we'll say restart session. If it is up, it will allow me to connect. If not, we will wait for another few more seconds. Okay, it is allowing me. So it hardly takes 30 seconds. Now what we are going to do is we will switch to the Postgre user. Sudo su space. We are logged in. Now just update your hba.conf file and add the IP addresses which requires the access to your system with proper the authentication way. So I've just added. So what next we are going to do is let's go to PSQL and just to verify show listen underscore addresses. So we wanted to see this. We will say show listen underscore addresses. Yes, this is fine. Now what we are going to do is we are going to restart our instance and we are going to restart and check the status. It is restarted. Check the status. This is up and running. And then what we are doing is now from here, this is the important step, configuring the continuous archiving on Postgre cluster. So what we are going to do is we are going to configure PostgreSQL cluster to archive the files in a directory which is different from the default data directory. So this is my default data directory, and I'll show you where is the wall going as of now. So there is something called as pg underscore wall. If you see over here, the the walls are here. So you can see this is just created. What we have to do is we have to make a mechanism, and we will have to move these walls from this particular location to somewhere else. This is not the correct way to put it over there, but since I don't have any other file system, so what I will do is I'll create a directory under the data directory, which is pg13 underscore archive. So I have created it. So everything will be done through the service user, which is Postgre. This is the first step. Then what we will do is we will add it our postgresql.conf file. So the first thing which we will do is you just have to make sure the location of your configuration file. So if you say show config underscore file, you will be able to see the location of postgresql.conf. The next thing which you will do is you will add it, and you will add three important parameters which is mandatory for your this demo. So first thing is archive mode on. You have to make sure that archive mode is on. So in postgresql.conf, search for this. By default, this will be off. You need to make it on. So this is on. This is first parameter. The second parameter is the archive command, where you wanted to move your archive. So by default, these will be in the default mode, and they will be appearing as commented. So uncomment, and you need to make the changes over there. In our case, we wanted to move the archive to this location, so you have to put this command over here. This is just a location which I have mentioned, and ensure that it is put in the same format. And an example is already mentioned over here. So we are just following it. There's nothing great about it. It is just like you maintain the proper what do you say, spacing between them. Okay, this is the second part, and the third part is wall level. By default, wall level will be in replica mode. This is the minimum which is required. Ensure that you have the information captured uh, to your so these are the three parameters which you need to put it, and then we will restart the. Now what we are going to do is three parameters which are there, and they need the recycle of your system. So we will say sudo, and we will recycle the sudo systemctl restart PostgreSQL 13. It is done. Just check the status. This is done. Go to psql command prompt and verify all the three uh, status of all the three. One is the archive mode, which is on. Another is archive underscore command, which we have just created. A third is the wall level. And then what we are going to do is just see some information. By default, wall level is 16 MB, and Postgre will archive wall file once it is full. In case you wanted to forcefully switch it, you need to use this command. So let's say if I wanted to switch it forcefully, I should do this. So this is going to forcefully switch it. And then third step, which we are going to do is we are going to initiate a physical backup of the PostgreSQL 13. So what we are going to do is for PostgreSQL point in time recovery, we need to take a physical backup of Postgre cluster. And what we will do is we have to take a copy of all the data files in Postgre 13 data directory, assuming everything is in the default location. So what we will do is we will execute PSQL and we will just check what is our data directory. The data directory is that current one. In your case, it may be something else. So what we will do is we wanted to take a backup of our cluster using the PG based backup. So we will create a directory. For my case, it is just one file system I have. This is not the best way, but you need to have it somewhere separately. I just created a PG underscore PG13 underscore backup. And what I'm going to do is I'm going to take a backup. It's very straightforward. PG backup hyphen capital D, and I just mentioned the complete location of the backup. So this is going to copy and paste the entire content of data directory to this location. And now we are going to test the PostgreSQL point in time recovery. What is the prerequisite? The prerequisite is latest physical backup of the Postgres cluster should be have been taken using PG base backup. We have done that. We should have enabled archiving and wall files to some non-default location. We have done that. And now we will try to perform the point in time recovery. So what we will do is let's stop the cluster because we wanted to do everything on this cluster itself. What I'm going to do is just clear the screen and stop the cluster. Just check the status, everything is down. Now what we will do is we are going to rename the data directory of Postgre cluster. We are just simulating like we have lost the data. So what we will do is I'm going to rename the data directory so that we cannot start our system. So instead of deleting all the contents of the data directory, I'm just going to remove it. So if you go to this particular location and try to find data, you will not be able to see it. And what you need to do is you need to create it. Let's create the data directory again, and you will be able to see that there is no content inside that. And if you see this, there it is empty. Now what you have to do is we are going to restore using the cp command. So what has been done so far? We have lost the environment. There is nothing inside that. You cannot restart your system. And what we are going to do is we are going to restore the database or the entire cluster, which we have taken the backup using PG underscore base backup. Now what we are going to do is all the contents, it is available over here because we have put the backup in this location. If you see ls, you will be able to see everything is it is same the way it was there in data directory. This is just a kind of cp which has been done by pg underscore base backup. Now what we are doing is using cp-a command, we are trying to copy everything to the data directory which you had earlier. So just copy and paste using this cp command. If you go to your new the data directory location, now you will be able to see everything has been copied using cp command. What next we are going to do is this is going to be very important, otherwise your cluster will never come up. Ensure honor is Postgre slash Postgre for this particular data directory, and the permission is 700. So what we will do is uh, you need to make sure the permission is 700. Otherwise, during the startup of the cluster, it will not come up. So you can verify you have made the changes. Now what next we are going to do is the wall files in the pg underscore wall directory are restored from pg base backup. They are old. Let's say I have restored it from the older environment. Then if you see this, let's say I have restored it from a backup which I had taken yesterday. So pg underscore wall will have the older wall files, but I wanted the latest one. So what I will do is remove everything from here just to simulate it. Rm minus rf star. And then what we will do is now we are going to restore the wall files which were available to this particular location. So just control C to the location, because you remember we renamed our data directory to data underscore old, and this pg underscore val will have that data. So if you say ls, you can see the data over there. So what I will do is I just wanted to copy this from all from here to the to the wall directory. Is it copied? Cp hyphen a star to this. So if I go to pg val location, I should be able to see everything. And one more thing we have to do is, since we have started the archiving, whatever is there in the archive location, in the backup archive location, we have to restore it from there. You can see there are some files available over here. So you have to copy it from there as well. Copy everything from here as well to the pg wall location, because these will be required when it is being restored. There's also, so if you go to pg underscore val, you will be able to see there are a lot of val files. So the only thing is we restored the data files into data underscore directory, which is this particular location where lib psql 13 data, and we have restored back the the wall files to pg underscore val. And one more thing which we have to do is, since we have restored it from the backup, we need to there is something called as okay, let me do this. Just go to pg postgresql.conf file and for restore command. You wanted to restore back the files. Just mention the location your where you archived your works. Once this is done, what you have to do is you have a number of options for the recovery. You can recover the target to a particular timestamp, to a particular transaction ID, to a particular log sequence number, or the name of the restore point if you have created something before doing some activity, and if you wanted to restore that, you can do it. And there are some of the things which are available. There is something called as recovery underscore target. If you do not mention it, so it will try to apply all the available wall files and try to bring it up to a consistent state. This is the default one. So before starting the Postgre, you make sure that you start the PostgreSQL in recovery mode. How can you do that? You create an empty file in PostgreSQL data directory which is called as recovery.signal. So it is going to look for that. So what you have to do is you have to ensure that you mention this. So this should be available, recovery dot, yes. And now try to restart it. Just check the status. It is down. It is expected to be down because we have removed everything, and this is the first time we are trying to start. Oh, wow, this is started. Normally there will be the issues with the um, status. See it is up and running. So what you need to do is you can check the log files to make sure what it has done. Just say ls-ltr and do a view what it has done. So okay, it is trying to find out some of the history files which we have already restored to the actual location. You have already copied it in the wall location, and where from where it is starting the disk system. Okay, consistent recovery state reached at this particular point. So during the restoration it has applied whatever wall files it was available for it to start the database. These are not available because we have moved it to the pg underscore wall location. Otherwise you have the option to put it at a particular point in time, and you can, and this is a great thing, and all the environment should have this kind of this thing, setting, so that you can restore and recover your wall according to your requirement. So just a recap of what we have done is we have set up the continuous archiving and perform the point in time recovery. What we everything behind this is wall. You need to ensure your wall is properly configured. The first thing, we initiated a Postgre 13 instance on EC2, and then what we have done in the second stage, which is the most important stage, is we have configured continuous archiving. To configure the continuous archiving, there are three parameters which are enabled: archive mode on, archive command, where do you want to keep the archive. So we have created a directory outside the data directory, it should have been, but in my case it is, I have made it over there. Then we have enabled the wall level, like what kind of information, the changes you wanted to capture. This is the minimum requirement, this is what we want for our environment. Then we restarted, so we made the changes in the postgresql.conf file. Then we restarted and we cross-checked if everything is as per our requirement. And then we tried switching some of the wall files just to make sure they are archived and they are not in the default location. Then we initiated a physical backup of the PostgreSQL 13 using pg underscore base backup. What we created it, we created just a backup location, and using pg underscore base backup, we mentioned the location, and all the data files are copied over there. And during the just to test the point in time recovery, we stopped the cluster. We excuse me, we renamed the data directory to data underscore old, and then we created the data directory again so that it is empty. We cross-checked it. Then using the cp command, using operating system cp command, everything which was available in pg base backup excuse me, they have been restored back to data directory. And the important part is you need to make sure the permission is 700 for the data directory. Once it is done, you make sure the walls are restored. Else you mention the information in your postgresql.conf file for the restore command, like they are available at this particular location. And you have to create a and what you have to do is, there is an important parameter recovery underscore target. It it has a lot of options available according to your requirement, but in our case we wanted to take consistent state. Whatever archives are available, we wanted to apply all of them. And there is important parameter which we need to create in our data directory, which is recovery dot signal. We need to create a blank file. And then finally we started the PostgreSQL 13, and it started uh, uh, actually. I hope this is going to help, and try to test it out a couple of times, and probably in some other session we will see how to use different options. Maybe restore point is a good idea to test it out. We will test it out and we will see how it is going to behave. I hope this is going to help, and thank you. Welcome. In this session, we are going to learn about what is PostgreSQL log underscore statement. So we are going to start with the introduction to PostgreSQL underscore Postgre log underscore statement. So log underscore statement is a parameter in Postgre which will allow you to log the SQL statement which you run in PostgreSQL database. So um, log underscore statement it is available in the PostgreSQL.conf file, and the way you wanted to log your SQL queries in that, it can be controlled from here. So this particular parameter log underscore statement has four parameters which are allowed. The options are none, DDL, mode, and all. So by default, log underscore uh, a statement parameter, it will be turned off. So it is set to none in your PostgreSQL.conf file, right? So when you say none, this option of log underscore statement is defined, and it doesn't log any query in error log file. So when we say any SQL statement which you fire is not going to log that. DDL, so any DDL statement, create, alter, and drop, they will be logged. All, any statement which you fire, it will be logged. Mod, mod is for all the DDLs along with the DMLs and some more parameters they will be allowed in mod. Sorry, in mod kind of this thing. So we are going to log into this. The first thing which we are going to do is, okay, let me go to PSQL. So I'm logged in as Postgre. Just go to PSQL and just say show config underscore file. Sorry, it's we have already fired it. So this is our PostgreSQL.conf, and if you wanted to see this parameter using this, you can just vi this and just say log underscore statement, STATEMENT, log underscore statement, and this will take you to log underscore statement parameter. So let us see where it is. Uh, log underscore statement, yeah. So log underscore statement by default it is none, and you have other parameters DDL, mod, and all which are allowed. So what we are going to do is we'll go to the command prompt. Let us come out of this and just cd to the data directory, and then you have log. Then you will see some file with the PostgreSQL hyphen date hyphen um, today's today is Saturday, so it is going to show you that. So what we are going to do is now we will start with the first option. What we are going to do is we are going to change our log underscore statement. So first of all, let's check what is the log underscore statement, because I have already tried earlier, so our default configuration may not be available over there. Okay, none parameter is already set. So what we are going to do is we are going to change it to let's change it to DDL. So we'll say alter system set log underscore statement equal to DDL. We wanted to capture the DDL statement which we are going to log. The system is altered. Just show. Okay, let's restart it. Sudo systemctl restart PostgreSQL hyphen 13. There is some spelling mistake. POSTGRE SQL-13. So it has restarted it. Just check the status. This should be running. So you can see it is running. So now we will fire PSQL statement again just to check what is our current logging status. All right, you can see it as DDL. So any DDL statement should be logged over here now. So we will say trail minus 1f and the log file. Database system is ready to accept connections. Now let us fire the first statement. Okay, let's create the table. Table is created. You can see the table is, this statement is logged. And let's fire the select star. There is nothing inside this table, but if you check out here, this statement is not logged. Let's insert some data in this. We are going to insert 3 rows inside this table. Okay, 3 rows inserted. If you say select star from course, it will show you 3 row, but these 3 statements are also not captured in PostgreSQL .log file, which is log underscore statement, which we have set to we set it to DDL. So it is going to capture all the DDL statement. Now let's do some DML. So DML will be captured in your all option. So anything which you fire it is going to be captured in all. So let's check the status of log underscore statement. It is set to DDL. Let's change it to all. Then any statement which we fire, it should be logged over here. So we have already done it. Just say show log underscore statement. Okay. Just to let's restart it. We are going to restart the now PSQL, and this should show you what is your current status of log underscore statement. It is also any command which we fire, it will be logged from hereafter. So just say select star from courses. So your select star from courses is logged. Now just do one thing, just drop and create the table. Drop table course. So this should be also captured. This is captured. So just say again select star from course. Course doesn't exist. Course doesn't exist. So it is capturing everything. So it is very very disastrous to have all statement logged in your Postgre database in log file. So the next one is mod. So what it is going to include, it is going to include your DDL and DML statement. So let's change it to mod and restart Postgre, and then you just say select star from course. Check out what is the log statement which is set. It is set to mod. So let's say select star from courses. It is logged over here. Sorry, this is okay. We haven't fired any DDL and DML statement. Let's first create the table. So we are going to create the table first. So let's create table. So it should be logged over here. This is logged in the log file. Then again, you insert few rows. This should also be logged because this is DML. This is logged, right? So just a recap. And when we say none, it is not going to log any of these things, which is default one. So what is log underscore statement? It is a way to log your DDL, DML statement and any other statement in PostgreSQL database in terms of the file. And where this file will be stored, this file will be stored under your log directory. This is my data directory, and inside the log you will see this file generated. So you can view, and if you wanted to capture some of these things which is happening, so you will have to turn on the log underscore statement parameter in PostgreSQL.conf, and using the alter system set command you can do it, and it will be very useful if you are doing it for a short period of time, and then make it turn back to parameter none, which is default, which is not going to log anything. I hope this parameter is going to help you, and thanks for watching. How to monitor the PostgreSQL streaming replication on a setup which has one primary and one slave. So that's one master and one slave. So I have already the setup done, which is there on EC2 instance, and it's Postgre 13, which is running on the primary and the slave. So all the details are over here. So one of the thing is whenever we have the PostgreSQL replication and we are involved in the monitoring, there are few commonly known issues which makes your streaming replication go out of sync. Everything is recorded there in the WAL files, and if there is a problem in sending the WAL files from your master to slave or from your primary to the replica, then there is a problem. And the problem exists in the form of a replica which is going out of sync. If there is a problem in accepting the write ahead log files on the standby side or the replica side, it might go out of sync. If there is a high load on the primary, it may lead the replica to go out of sync. If there is a high load on the replica, it may also cause the replica to go out of sync. And one of the major contributing issue for the replica to go out of sync is if the network outage is there between the primary and the replica, then it also results. Or there may be a scenario wherein your replica has been down for several hours and the WAL files which has been generated on the primary, they are not available. And there are some commonly known things about the replica which is going out of the sync is if my primary, which is accepting the transaction from the application, it is highly active. In that case, also, it may be possible that those changes they are not replicated or propagated to the replica. It may also cause the standby to or your replica to go out of sync. There may be a network outage between your primary and the replica. It also may cause the replica to go out of sync. Or there may be some unknown issues apart from these known issues, which may also cause the replica to go out of sync. So what are the different important parameters which contributes to the valid state of the replication? So you need to have a quick watch on those. One of the parameter on the primary is your WAL keep segment. So this is the minimum number of WAL files that you keep on the primary. If it is a higher value, then the replica going out of sync is minimized. But if you keep the higher value, that means you have the high requirement for the storage on the primary. The second parameter is max wall size. So this is the maximum size of all the log files which is available on your disk. And then we use the term replication lag. So it is how do we find it? So let's say if I execute a query on the master and it returns 10 rows, and if I execute the same query on my replica, which is in the read mode, and if it doesn't produces the same result as it was on the primary, then there may be two things. One is replica is already in the recovery mode, or it may be it is lacking so much behind in terms of the wall files that those changes are not replicated on the replica side. So we'll see what are the different basic queries which can be used on the primary and the replica side. So I have a Postgre 13 streaming replication already set up. This is my primary, this is my replica. So I'll go to the primary and I'll just say PSQL, and if I say select star from pg underscore stat underscore replication, okay, let me put it in the extended view. And if I say select star from pg underscore stat underscore replication, it will show the status of the replication. This is the PID, and this is the username. Then this is the IP address of the receiver where my streaming replication is happening. And this is the backend start time. The status is streaming, and this is the sent LSN, write LSN, and replay LSN. So you can see it is consistent. And if there is some lag on the standby, you will be able to see the status over here. Write lag, flush lag, and replay lag. Write lag, like what is the delay in writing, what is the flushing of those files on the disk, and then applying those files on the standby environment. Sync status is in asynchronous, and the replay time is the current time. As of now, my primary and the replica, they are connected. It is in running mode. What I'm doing is I'm just going to stop my replica, and we will see uh, what happens to this select star from pg underscore stat underscore replication. You will not see anything. So it's like the connection is not established because it is down. The standby is down, or it might be a scenario your network is not there, so it's not able to communicate, so it is not going to see. So this is one of the basic thing which you can check from the primary side. The other thing is, if you have a streaming replication and if you have used replication slot, let me start the instance on the replica side. Okay, so let me simply say start. It is started, and the same command pg underscore stat underscore replication, you will be able to see now the connection is established. Write lag, there is a slight lag which is very less, and if you see it now, that write lag has gone away, though there is no activity on the primary side. And the second command which you can fire is select star from pg underscore replication underscore slots. So it is like I have given some slot name, the slot type is physical. This is active. Active is true. That means it is doing its work and it is transferring the connection is established, and the wall files are getting applied. What I will do is, again, I'm going to switch off the replica, and then let's see this command. You can see that active is false. That means there is no streaming replication happening at this point. So you have to check this active. it will remain in the false state unless or until you establish the connection. So to establish the connection, this is a pseudo status which we have created. I'll start it, and then this should go and become active again. So this active is true, so this is fine now. And another thing which we can check on the primary side is we can check the current wall LSN status. I'll go to the primary and I'll fire this. Select pg underscore current underscore wall underscore LSN. So this is the current wall log sequence number, and then the final command which you can fire on the primary side. So it depends upon your scenario what suits best for you, but most of the information you will be able to see. Using this command, you will be able to see the application name as you would have seen in the first step, then sending lag, receiving lag, replaying lag, and total lag. So this information might help you when there is a large gap between your primary and the replica. On the replica side, you can check what is the current status of your replica. Let's go to the command prompt and say select PG is in recovery. So this will show you PG is in recovery. It is in the true state. So recovery is happening without any problem. We can check the status of wall log files, how it is getting received over here. So I'll say select PG last wall receive, and this is the last wall which is received. Then what is the last wall file which is getting replayed on the, or it is getting reapplied on the replica? So you can see it has given that information as well, and I can check the replay timestamp as well on the replica side as well. So going back to the last one in this also shows some important information. So most of these values are valid for Postgre 10 and onwards. If you have to check the prior versions, then there is a slight change. Probably I'll put that as well. There is no replication log delay, so everything is fine. And the final thing, if there is an out of sync replica and there is no way to correct it, then you need to check the archive command on your primary, the restore command on the standby. And what you need to do is on the replica side, you need to export the data directory, remove everything, and then you do a PG based backup on replica to bring the data from the primary. So you can use the data directory location, then you can use the -r, which is going to create your recovery file. Then you can use a -access file, which is going to send all the log files, which is written on the primary to the replica. You can use the -v, which is the verbose. It will show you the display on the screen, and the -p that will display the progress of the restore. And then you have to check your log files if everything is fine or not, and then it should work properly. So it's always good to give importance of the how can we monitor the different things. So everything is available over here. So I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to see some basics about the PostgreSQL log. So I have the notepad. I'll quickly show how it is going to look like, and okay, here it is. So we have everything recorded in a notepad, and we are going to see some of the basics about the PostgreSQL log. So like any other relational database or any other or operating system or anywhere wherein you wanted to check the issue with your environment, the logs are very, very important. So in our case also, we have the PostgreSQL log available, which will be used for troubleshooting and doing some analysis on your environment. So Postgre has an amazing log management facility. If you what do you say, if you maintain the proper configuration of your PostgreSQL according to the requirement, then it is going to be really helpful for you. So starting with the overview of PostgreSQL log management. So PostgreSQL supports three types of logging your server messages. So you can have a standard error log message, which is known as stderr, or you can put it in CSV log mode or sys log. So if you're working on Windows, obviously it is going to event log. So everything can be put into the SQL PostgreSQL.conf file, and it is going to pick up the information from there. If you wanted to keep the logging in CSV format, then you have it will be coming into comma separated value. And if you wanted to feed this into some tools wherein it is going to read the information from there, then it is going to be really useful. But by default, your logging mechanism is going to be stderr. So if you wanted to see like what is happening and what is the current location, if you haven't made any change, so by default in your data directory, if you go to log directory, you will see something like postgresql.log or postgresql.csv if you have put it in the CSV format. What is most important before you go to the log format, the std rr format or CSV format, that logging collector must be enabled, which is a background process which is going to pick up the information and put it over there. There are different severity level which are as usual in any other environment. So you have informational messages, you have panic, fatal, log, and info. We are not going to discuss about those, like what are those. We are directly jumping to the different parameters which are of utmost importance when we are talking about the PostgreSQL logs. The first parameter is logging collector. So if you see this parameter helps in enabling the logging character. What it is, so it is a background process which is going to capture the log message, and either it will redirect it to the stder or comma separated value, whatever format you have defined. So I have an EC2 instance running with the PostgreSQL installed on it. So I'm going to just execute this. I haven't made any change. So if I say show logging underscore collector, by default, this value will be on. That means the messages will be logged into your standard error log file. The second important thing is where it is going to log it. So when logging collector is enabled, which is the first step, which is by default enabled, then in that case it will go to write to some particular location. By default, this is in your log, which is in your Postgre uh, data directory. So if you simply say show log underscore directory, this will point to the log directory which is in your data directory. So let me show you show data underscore directory. If you go here and just say ls, you will be able to see a directory called log. So it is pointing to this. So you can see these are the log files which are available, and it is rotating on daily basis. So we'll talk about that. But before that, let's go to further different points. So the next PostgreSQL conf parameter is log file name. What should be the file name for this particular log file? So when logging character is enabled, when the collector is enabled, then it is going to put it into a log file. So if you simply say show log file, so we know that it is going to, okay, let me log into PSQL again and fire show log. So You can see the format, the file name is PostgreSQL hyphen percentage a dot log. So it is going to put uh, the uh, the uh, the format of the weekday. So whether it is Sunday, Monday, Tuesday, Wednesday. So those things it is going to put over here. So this is the default format, and the next parameter in this is the log file mode. So on Linux system, this parameter sets the permission for log file. What should be the permission on this? So by default, this will be 0600. So if you see show log file mode, it is going to show you. So these are the default parameters. So you can see this is the default parameter. But so by default, only the owner should be able to read and write this. So this is a special parameter. If you talk about the log rotation age, in case your database is very active, and if you wanted to rotate your log file onto a particular time period, then you can do it. So if you say show log rotation age, it will show you what it is. So by default, it is 1 day. You can change it according to your requirement. Log rotation size, if by default it is 10 MB, so after 10 MB, if you specify, it will auto rotate it. Auto rotate means it's going to create the new one. So by default, it is set to 0. Set to 0, that means it has been disabled for size based. But it is a good idea in case you have it for the specific date, let's say after 1 week or something like that, or in between, if you wanted to put the size like after 100 MB or something, like this should create a new, then you can do that. There is another one parameter which is called as log truncate on rotation. So it is something like you wanted to truncate rather than appending it, so you can rely on this parameter. So log truncate on rotation, so it is showing on. So this is the default value. And if you're using the syslog facility, so you can simply say like where it is going to log your syslog value. So show syslog underscore facility. So there are different parameters, local 0 to local 7. So you can, by default, it is going to local 0. These are very important, which is log min messages. So it is going to control which message level. So there are different message levels which are available in a server. It may be a panic level, it may be a warning level, it may be a fatal level. So which one you wanted to log. So this is very important. So one of the most important parameter for log. So if I say show minimum log messages, so warning. So you can see this series, warning is coming over here. So anything above the warning, they will be returned into your log file. So what it is doing, it is going to control which message are returned to the server log, and by default the value is warning. The next important parameter is number 10. If you see log min error statement, it is going to control which SQL statement is going to be logged. The previous one, number 9, it is showing which level. So it is warning level by default. And number 10 is which statement caused this warning, error, log, fatal, or panic. So if I say show log min error statement, and if you execute this, this is error. So by default, anything related to error, it is going to pick up. So error is here, so you will be able to see these messages will be logged. So anything after that, they will be logged. Next one is log minimum duration statement. So here you are going to control the timing, at what time. If it is running in the database at a specific time, then they should be logged or not. So if you simply say show, okay, let me type this. I think I have not. If I simply say show log min duration statement. So this is set to -1. What does it mean? So it means that it is disabled by default. If you set it to 0, that means any statement which is executing in database, that is going to be logged into the log file. So what it is doing, if you set it to, let's say, some particular value, 250 milliseconds, then anything which is running up to 250 and greater than that, 250 and greater than that, they will be logged in. So you have to be sure what SQL statement which is residing in your database at a particular time, they should be logged. Next one is if you wanted to log the application name, not the name which is reflected by the application, but it is something which is going to be read by the PostgreSQL. If you wanted to capture that, so that will be enabled. So next one is log checkpoint. Why we are discussing about these? Because these will be used in next topic, which is about the PG Badger. So we are going to talk about PG Badger after this, but let's see what is there in show log underscore checkpoint. What it is going to see is, what it's going to do, it is going to cause checkpoints and restart points to be logged in your server log. So if you say show log underscore checkpoints, by default this is off, and for your troubleshooting and analysis purpose, if you put it here, so that will show like what is the checkpoints and restart being done, and it will be logged. The next one is log connections. If you enable this, then every attempted connection to the PostgreSQL will be logged. So by default, this is off. If for troubleshooting period you wanted to do that, this will be good, but you have to turn it off immediately after the troubleshooting is done. The next is log disconnection. If it will capture what sessions are terminated, and they will be logged, and it also captures the time for which they were connected. So if I say show log underscore connections, let's capture this. If you say show log underscore connections, oops, what happened? Okay, it is log disconnections. Log connections we have already seen. So let's see log disconnection. So by default it is off. If you turn it on, it is going to show what all has got disconnected just for the troubleshooting period. And the next one is the log duration. It is going to log the duration of every completed statement in your database. So if you say show, let me fire this. It's good to know about these parameters, like there are these many parameters existing, and in case if you have to use them, it is going to be helpful. So it is by default it is off. What it means is it is going to track the duration of every completed statement in your log file. That is going to be helpful. These parameters we are going to learn in the next topic, which is all about the PG Badger. I hope this is going to help. Thank you. Hello and welcome. In this session, we are going to learn what is the usage of Python in PostgreSQL, or how do we integrate Python for the PostgreSQL. So you already might be aware that Python is one of the most powerful programming language nowadays, and this has been everywhere. So we will try to see for PostgreSQL database how can we use it to a minimum extent. So we will see the module which is being used for Postgre, and we will see a basic thing in PostgreSQL, like how do we make a connection to the database, and then how do we create a table, how do we insert one or two row, and then how do we display the data from the table. So this is all about what we are going to see in this demo. So the first thing, the PostgreSQL database can be integrated with Python using this module, which is PSY COPG2 module. So what I'm going to do is I already have an internet connectivity with my Postgre server. So I'll just say sudo yum install Python and the module. Since it is already installed, so it will show it's already installed and with the latest version, so nothing to do. But in your system, it is a Linux environment. You have to install this module for your database. So the next thing which we are going to do is we are directly going to create a Python script and we are going to log into the database. So I'll show you the script which is there. So the script name is login postgre.py. So we are just saying the location of the Python executable, and then we are importing the module which we have just installed. So this is very important. Then we are going to say uh, connection equal to the module name, and then we are connecting, and then we are saying database, which database I want to connect. I want to connect with the DVD rental. User is Postgre, password is password, this is the host IP, and this is the port number where Postgre is running. And then it is going to display the database login successful. We are not going to mention if any of the parameter is wrong, how to handle that. We are not doing that. It's just a straightforward, basic, very basic Postgre uh, Python script. So we'll just say Python, and the script will try to execute, and we'll see if it displays the success or not. So it is displaying database login successful. Since it has met all this criteria, so it has printed the login successful. Now what we are going to do in the second step, we are going to create a table. To create the table, this is the script which we are going to use. So we just mention the Python, and then we are going to import the module. So we are just saying import and the module names. Then in the connection, we are just saying the module dot connect and the connection string. This is the detail of the connection string: database name, username, password, host IP, and the port name. Then it is going to print whether login is successful or not. Once it is successful, then we are mentioning the cursor, and then we are going to execute the create table statement for a table called as films, and that has one column with the code, and it is going to store char 5, and then it will display the table creation completed successfully. So let me first connect to Postgre and drop that table. Okay, it is not there, I believe. So let us go and execute create table, and then we will say Python and the create table. So table creation is successful. Now what we will do next is we will insert a row. For inserting a row, we have the script. So it is just insert data dot py. What we are doing over here is the same thing. We are going to import the module. Then in the connect, we are just saying we are giving the dot connect, and then we are showing we are mentioning all the details which are required for the connection. So once it is connected, then we are going to execute the, so you need to understand what is this the connect module, and then you have the in the cursor you have execute. Okay, so in the execute we are just saying insert into films, and then the column name, and here is the data. Then we are going to commit it, and then it is going to print the message, and then it is finally going to close the connection. So let's execute it. Python and insert data. PYTH1. Okay, the records are inserted, and the final one where since there is no index created and there is no constraint, so if I insert the same record n number of times, it is going to be getting inserted over here. The last one in this one is the selecting the data. So we are just going to select the data. What we are doing again is we are going to import the module, then we are going to connect it. This is the connect string, and I believe I have created some more table. So here, okay, this is going to display. So once I have mentioned the connection details, it is going to, since my table films has one column only, so I'll just say when you are displaying the rows, just display all the rows. Okay, so this is going to display, since it has only one row, so it is going to display only one uh, column details. So let's execute it, Python, and select data.py. So you can see this is the data which is available as of now. There are many rows with the same uh, output because I have inserted this many times during the creation of this demo. So this is just the basic. There are a lot of things which can be done depending upon what do you want. So it is just like just what we have done is we tried how to connect to the database. Then we had created a table. Then we created we inserted some row, and then finally we fetched the data. If you know the basics of this will be useful, and you can implement many more things as you move further. I hope the basic thing is going to help you, and thanks for watching. In this session, we are going to learn what is IaaS and PaaS, which stands for Infrastructure as a Service, and the second one stands for Platform as a Service. So our requirement is we need to have the Postgre deployed on a machine in the cloud, and there is a decision making which has to happen, and mostly there is a lot of discussion which happens whether you wanted to install the Postgre on a virtual machine in a cloud, or you wanted to have a pre-installed managed instance of PostgreSQL. So there are two terms which are very oftenly used. One is IaaS, which is known as the virtual machine deployed in the cloud, and the other word which comes is PaaS. There is a spell mistake over here, which is PaaS. It should be platform as a service. So it is simply like if you wanted to have the full control over a machine and you wanted to deploy Postgre on top of that in the cloud, maybe in AWS, Azure, or Google Cloud, you need to have the virtual machine spin up in any of these preferred cloud or any other cloud service provider which you have. The other way is you can choose with the pre-installed managed instance of Postgre in any of these three major cloud service provider. So that's the basic difference between the infrastructure as a service and platform as a service. So basically, a virtual machine which is there in the cloud is called as IaaS. And if there is a pre-installed instance of Postgre in cloud and you do not have access to the operating system, it is termed as the PaaS, platform as a service. So What is the decision making factor, like what shall I choose? So it depends upon how much control do you want over the machine. If I wanted to have the full control in terms of the Postgre instance which I wanted to install, let's say I wanted to install a Postgre which is quite legacy that's quite old, let's say 9.5 or 9.6, just because of my application dependency and something like that. This is just an assumption. And most of your Postgre managed instance, which is available in either of these three service providers, cloud service providers, they may not have the oldest version. And if somehow you have those binaries you wanted to get installed on a virtual machine, you have to select a virtual machine in any of these cloud, and there you can go with that. So when you choose between infrastructure as a service or platform as a service, you need to have some decision making, like how do you want to manage the database? How do you want to apply the patches? How do you want to manage the backups? And how do you want the operation related what do you say, the operational things of Postgre managed? Right, so you need to consider all of these. If you are running your Postgre on a virtual machine in the cloud, and then you have to take care of everything, starting from the deployment. Then you have to manage the high availability, you have to manage the disaster recovery, you have to manage the monitoring, you have to manage the backups, you have to manage the replication if it is there. So it is, everything is customer managed. But when it is about a platform as a service, in that case there are a lot of overheads which you, or there are a lot of work which wherein an administrator work. Those are already taken away from the administrator, and they are already automated in cloud. So there is an easy manageability when you work in a managed instance, be it any of these three: Azure, AWS, or Google Cloud Services. So we will see some of the attributes. So availability SLA. If let's say my virtual machine or infrastructure as a service, it is in the AWS cloud, then the SLA depends upon the virtual machine which you have selected. If I talk about Postgre as a managed instance, or as platform as a service, in that case, it will depend upon the managed instance SLA. What about the operating system and PostgreSQL patching? If you are running it on a virtual machine as infrastructure as service, then it is your responsibility. It's customer managed, and you have to manage everything. If it is with platform as a service, then it is optional, and you can manage it in the managed window. But most of these things are automated by the cloud. High availability, you have to architect how you wanted to maintain the high availability of Postgre when you install Postgre in a virtual machine in cloud. And when you go with the managed instance, it is available built in. So you just have to find out what kind of high availability which is available in the particular cloud you wanted to go with. Hybrid scenario, if you wanted to have the what do you say, the multiple instances of the Postgre, say for example, for high availability, you can have you have to manage it yourself. But there are some in case of the cloud, it is termed as the read replica, and there is a consistent replication happening between the primary and the read replica, so they are in continuous replication with each other. So that's easily managed. But when you have to do it yourself, you have to manage all the challenges. The backup and restore, which is one of the most critical part in Postgre, If it is on a virtual machine, you have to manage everything yourself, whether you wanted to do either of the three, the way like you wanted to use the PG dump all, or you wanted to have using the PG based backup, or you wanted to use some third party tool to manage the backup and recovery, you have to do it yourself. But when you go with the platform as a service, so everything is automated, the point in time recovery, the backups, and everything is managed by the cloud service provider. Then the important part is about the monitoring of the database. So if you are doing it yourself, then you have to make sure what individual components you wanted to monitor. But when you are in managed instance, everything is pre-managed, and you just have to trigger what alerts you wanted to see. Let's say for the storage, for the CPU, for the memory, for the maximum number of sessions, about some performance threshold. So everything you can set in the managed instance. Threat protection in case of a virtual machine, you have to manage it yourself, not at the cloud service provider, but something where you wanted to protect the data internally. But when you talk about the Postgre as a managed instance or platform as a service, so you have a lot of things which are available that you can enable. Disaster recovery in case of managed instance, it is we call it as replica, and in case of virtual machine, you have to manage it yourself. With infrastructure as a service, what do we get? It is if you are trying to do, if you have the shortage of the manpower or the skilled worker, and you do not have any dependency on the operating system, then probably managed instance is one of the good thing to go with. But if you have some dependency, and those dependency cannot be ruled out with the managed instance, then you have to go with the infrastructure as a service. So full control, you can have it over the virtual machine, but not over the managed instance. With platform as a service, what do we get? So you are not supposed to bother about the underlying infrastructure, the operating system, the hardware, and the internal software. Everything will be taken care by the cloud service provider. But other than that, let's say the managing of the high availability of the databases, the read replicas, encryption, those things will be taken care by the cloud service provider. So everything has its own pros and cons. So it depends upon what kind of scenario you have. And if you wanted more flexibility, you have to go with infrastructure as a service. If you are fine with the less, what do you say, less flexibility, and you wanted to give away all the management part to the cloud service provider, you can go with the managed instance. So it depends upon what you are looking for. So it's all about the virtual machine and the managed instance. So sometimes there is some kind of confusion, like what is this IaaS or PaaS? So it's very simple. If it is a virtual machine, it is infrastructure as a service. And the way you work on the on-premises environment, you will have to work it in the cloud as well. If it is platform as a service, that means everything is pre-decided, and there is just few clicks, and your the way you wanted to enable the high availability backups and other things, they will be created. I hope it is going to help, and thank you. Welcome. In this session, we will see what is AWS database services, though we were supposed to talk about the RDS in AWS, but we will start with AWS database services. So in AWS, which is Amazon Web Services, there are 15 types of database engines which are offered by AWS. And these are the different types which are offered. So you have relational database, you have key value database, you have document based database, in-memory database, graph database, time series database, wide column database, and ledger based databases. So what are the general features of these databases which are offered by the cloud service provider, which is AWS, and in wide terms for any cloud service provider. So these database services which are offered by AWS, they are fully managed. That means most of the administration part, the critical time consuming part, that will be taken care by the cloud service provider, which is AWS. The performance which is seen in terms of the managed instance or the databases in AWS which is being offered, they have the performance at a scale because of the intelligent hardware which is being used. And in some of the scenarios, let's say the MySQL which is being used in on premises and the MySQL which is being used in AWS, there is uh, a lot of difference in terms of the performance. So what it says is there is alternative 3 to 5 times of millisecond response time. The databases which are offered in AWS cloud, they're highly secure and highly available because of the kind of security algorithm which is being offered, and because of the infrastructure and the management, they are highly available. This is the first type of database, which is relational database service. So relational database is the one where in your data will be stored in a table in terms of columns and row, which is the normal way of storing the data in a table. The example is Amazon Aurora database, Amazon RDS database, which has 7 different types of engine. You have Amazon Redshift. So maybe when we talk about the RDS for Postgre, we will talk about these three databases which is available for Postgre as Amazon Aurora, Amazon RDS, and Amazon Redshift data warehousing solution. In case of relational database, you have a predefined schema. That means the table structure. If I talk in the technical terms, the table structure will be predefined, or unless or until you modify the structure of the table. Your relational databases are asset compliant. That means there will be atomicity, consistency, and the data will be durable. You have the referential integrity for the transaction, and the data is consistent. This is mainly used for ERP and e-commerce. There are n numbers, but these are just too few. Another very popular NoSQL database is document database in AWS. So it is called as Amazon Document DB, which is MongoDB compatible. That means the MongoDB which you have been using on premises, the same thing can be used here in AWS cloud. It is highly, very, very fast. It is scalable and it is highly available. So what you can do is you can store the data in the form of JSON format, and the updates happen very, very fast. What are the use cases? You can use it for content management, for catalogs, and for storing the user profiles. The third type of database is key value pair database. And the example for key value database is Amazon DynamoDB, which is really a very successful database in AWS. So key value databases are optimized for common access pattern. It stores and retrieves large volume of data, and these databases deliver very quick responses. That means if you have a huge volume of the data and you wanted the concurrent request, then Amazon DynamoDB is one of the fastest way of retrieving the data. It is used for high traffic web apps and e-commerce system, and it can be used for the gaming application, wherein you will have the large data set and there are high requirement for concurrent requests. The fourth type of database is wide column database. It is in AWS, it is called as Amazon Key Space, and this is compatible or equivalent to your Apache Cassandra. So what happens? A wide column stores it is a kind of NoSQL database. It uses tables, rows, and columns, but unlike a relational database, the name and format of the column can vary from row to row in the same table. So there is no, it is not as equal to your relational database. So it can be used for fleet management or route optimization. So in that case, your wide column database called as Amazon Key Space can be used. The fifth type of database is in-memory database. So normally outside of AWS, it is known as Redis. So here you have two types of offerings from AWS. So one is known as Elastic Cache for Memcached, and another is Elastic Cache for Redis. So it is in-memory database which is used for application that require real-time access to the data, and another is by storing the data directly in the memory. These databases deliver the microsecond latency and high throughput. It can be used for caching purpose, for session management, and for gaming leaderboards. The sixth type of database which is being offered by AWS, it is graph database. The example is Amazon Neptune database. It is mainly used for the application that need to navigate and query millions of requests, millions of relationships, which is not possible in any other sort of database. So the graph database, it is for multiple what do you say, the relationships, then you have to use it. It is good for large data sets with the millisecond latency. It is mainly used for the fraud detection and social networking recommendations, wherein you have to go deep into the relationships. Uh, the last one in this, I believe, is time series database, which is called as Amazon Time Stream. And time stream database collects the information and derive the insight from the data that changes over the time. And it is used mainly for IoT application, DevOps, and industrial telemetry. And that's all about the databases